Hey guys, welcome back to Intellipaat's YouTube channel. In today's session, we will be learning about Pyspark. This session is conducted by an industry expert who is having more than 15 plus years of industry experience.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
Pyspark is the combination of Apache Spark and Python. PySpark is a great language for data scientists because it helps in analyzing huge data sets, which helps in decision making. It's no secret that Python is one of the most widely used programming languages among data scientists, data analysts, and many other IT experts. The reason for this is Python is simple and it is general purpose language. Therefore, it is trusted by data scientists to perform data analysis, machine learning, and many more tasks on big data. So it's pretty obvious that combination of Spark and Python would rock the world of big data, isn't it? Yes. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Big Data and Hadoop. Post that, we will be learning about MapReduce and HDFS. Then we will introduce you to Apache Spark and its basic concepts. Then we'll move on to applications using Apache Spark. Post that, we will introduce you to Pyspark and its installation procedure. After that, we will be learning about Pyspark Dataframe and Spark RDD concepts. Then finally, we have covered Pyspark hands-on demo to give you a better understanding of the subject. So guys, this is the agenda of the video. Now let's begin.
What is big data? It has its, in the name itself, it is defined. It is big data are extremely large data sets that may be analyzed computationally to reveal patterns, trends, association, especially related to human behavior and interactions. Okay, but before we go into that, let me give you a background why big data came into why big data became a problem statement. Okay, so what is happening is the thing is earlier they had data warehousing, right? So you would have heard about data warehouses like Ab Initio or Informatica, and I forgot the traditional data warehouse tools. So earlier on, there were a lot of traditional warehouse tools that were being used by companies, but the problem was as the data got big, it became very difficult for these companies to handle them, okay, to process them on two parameters. One is the processing part of it, and the what do you say, storage part of it. They're running out of storage, right? And these are all commercial softwares. Okay, so there were other there are also other what do you say, systems like mainframes. Okay, even there the problem was with the data. When the data got too big to store or process, again the hardware itself was, commercial hardware, not something, I mean, not commercial in sense, proprietary hardware, right? It's not easily available. It costs very high. Okay, same thing with data warehousing also. It would be running on some server like Microsoft server or some Unix server. Okay, and they would have purchased it, and the cost of maintaining that, paying for that, and all those things got too costly. They're not easily available. None of the softwares are open source. None of the hardwares are non-proprietary, available on the commercial market. Okay, so these were the problems that were that the companies were facing, especially the people who were working on data warehouse. It was a single server. Okay, it was a single server that was hosting the data warehouse, and the memory was getting too big. The amount of data that was going into a particular table was too big that when they used to run select star also, it would say that it is running out of memory. It's not able to process that data. Right? So processing got too difficult, storing the data got too difficult, tables would go so big that the hard disk would be filled up, right? So all these problems were the reason why big data framework came into picture. Big data became a problem because of that. Because in the last 5 years, if we take, there's this saying, okay, whenever someone talks about big data, they'll tell you this: the last 5 years, the amount of data that we have generated, it is 97% of all the data that we have generated throughout our lifetime, right? So there are a lot of data being generated every day, and people want to, make some sense out of it. Okay? They don't want to just let it go. Earlier on, companies would not monitor these logs, Windows logs of each employee, right? because storing them was a big headache. Storing them, processing them, everything was a big headache. But with big data tools and all this Hadoop and Spark coming into picture, they're able to get this data, store it in their cluster, analyze it, and find out, okay, this guy is not working as much as he's claiming to be, or he's downloading it from some GitHub, and all the stuff they're doing. And your employer may be doing it, okay, in the backend. There's a software tool. Was that touch point or something? Okay, so basically they do that. They are into log analysis of uh, customer workstations, right? So they install a client on your machine, and regularly they download your machine's logs and send it to their big data cluster, and from there on they do all this sorts of analysis, till what time to what time this guy was working, till what all downloads that we do, all those kinds of analysis they do, right? Earlier on, all this were being missed because they knew that this would cause a problem. It was not feasible, right? Doing all this stuff on a single server, single machine was not feasible. Okay, so that's where they started saying, okay, we are losing a lot of data, we are not able to make sense out of it. We can use it to make more money, right? Let's say, for example, if you talk about supply chain management, right, there the problem is, if we are able to get customer data, right? If in a particular big bazaar store, we know how many customers are buying chocos, then for chocos, the Kellogg's company, for them, they can maintain, okay, in this, during this month in big bazaar, this place, we sold around 100, right? 100 boxes, okay, and in this month we sold around 200 boxes. So all this data they could I mean, they used to do that even before big data. They used to do that, but as the data got big, it was difficult for them to collect this and make sense out of it, right? So they cannot, they used to do all this stuff like, okay, big bazaar Mysore, during the month of March, they're consuming more chocos, so we need to make sure that our supply to Mysore for this particular day or this particular month is this much, okay? So all those kind of business decisions were being taken. But as I said, as the data started growing bigger, it was difficult for them to capture historical data, current data, live data, all these things in one single machine. Okay, that was not possible. And if they wanted to move into a new machine with a much better processing space and much bigger hard disk, it all used to cost a lot of money, right? From 8 GB RAM, if they wanted to move to a machine that had 16 GB or 32 GB RAM, and from 1 terabyte hard disk, they wanted to move into a machine which had 1 petabytes of hard disk, they all were, they used to cost money, right? So big data came into picture because of that. It solves all those problems. Facebook, if you look into the Facebook data, the amount of data they're storing is pretty huge. Okay, every day they are getting around 2 terabytes of data. So in a normal single machine, if every day 2 terabytes of data is being filled up, that is not possible. By the end of next day, their hard disk would be full, right? Every day they have to go in and they have to find, either they need to find a server with bigger hard disk space, or with this server itself, they have to do a lot of engineering and engineering solutions that apply to make it big, or archive this data. A lot of things they have to do, right? It's a big headache. So these are the kind of typical problems that you would see in big data. The name itself says the data is too big for people to handle, but people want to handle it because there is a lot of value in it. There are 2.3, for example, if you look into Facebook, there are 2.3 billion monthly active users. Okay, there are 250 billion photos uploaded to Facebook. That equates to around 350 million photos per day, right? So that is almost 4 petabytes of data per day. Okay, imagine handling that in a single server. It is not possible. It's next to, it's impossible, right? So that is where Hadoop came into picture. Okay, and Hadoop was the first fully functional, tested, and without any bugs, right? Fully functional, tested, distributed framework that used commodity hardwares and commodity softwares. That means everything is either open source or very cheap. Commodity means what? Something that is available on Amazon.com, right? You can just order a laptop, connect it to your LAN, you can create a new cluster, new Hadoop cluster. And if the cluster is too small, the data is too big, you can buy another new laptop on Amazon.com, connect it to your existing cluster. Again, it becomes bigger, right? So you can scale it without much interruption, okay, and it is cheaper. So these are the qualities of Hadoop. That is why people moved into that. We'll anyway look into the three components of Hadoop. There are three main components. We'll look into that one by one. So before we go into that, what are the 5 E's of big data? This is a very common question. Okay, so that is nothing but velocity, volume, veracity, and value. Velocity is the speed at which the data is accumulated or the data is coming into your system. So as I said earlier on, let's talk about Facebook itself. When they were on a single machine, every day 4 petabytes of data was coming in. So we have to quickly make some decision based on that, right? So that is where the problem comes in. So that is one solution that big data gives you. Okay, it can handle high velocity of data. You can keep on sending data every second. Your cluster will be able to handle it, process it, analyze it, give you some result, something that you want, any functionality you want to apply on that, and get some business value out of it. You can do all the stuff. So these are some of the things that are not available in the traditional system. When I'm saying traditional system, it's a single machine instance. Okay, so traditional system is single machine. Hadoop is big data is nothing but distributed system. So it's kind of a cluster of machines that are interacting with each other simultaneously to complete a task in a parallel way. So it's like a parallelly processing, parallel storage. Everything is happening in parallel. So that way, all the machines resources are being utilized, and it is faster compared to the traditional systems. Okay, let's come back to the next one. That is volume. As I said, the amount of data that is coming in is huge. Every day, you may be generating data that is worth upwards of 4 petabytes, right? Then there is variety. You may get data that has some tabular structure like CSV file. If you look into that, some sources may be generating it that way. Okay. So your system may be getting data from source that is giving you structured data, maybe a CSV file or a MySQL table. Or there may be some sources that may be giving you unstructured data. For example, log files, right? It doesn't have any structure. It is nothing but line by line text. It contains nothing but line by line text, right? So that is what we call as unstructured data, right? Then we have semi-structured data. If people are aware of what NoSQL is nothing but a semi-structured data, where one row may have 5 columns, the other row may have 10 columns, the other row may have 15 columns. There is some sort of a structure, but it is not completely structured, right? So that kind of variety is there in big data, right? Something that traditional systems cannot handle, but in big data we can handle them. At the same time, the variety of sources of data, you can have CSV file, you can have text file, you can have Parquet file, you can have Avro file, you can have data from MySQL, you can have data from Oracle, various different databases, you can have it from ELK. Okay, all that can be processed, stored in Hadoop or any big data tool, right? So that is where big data solves something that is not available in the traditional system. Then comes veracity of data. It refers to the consistency of data. So you may have data that may be there sometimes, or it may be corrupted, or it may not be that consistent. Like you may be getting data at 9 o'clock every day, but there's a chance that some day it doesn't come, right? So there is that uncertainty that exists. Even that problem can be solved using big data. Okay. Final thing is value. As I said, until now people were ignoring a lot of the data because it was not feasible for them to process and store it in a single machine, so they just let it go. But with big data we are able to extract that value. So what is Hadoop? Hadoop is a framework which is used to store big data across a spectrum of devices. This is done to help you process big data in parallel. Okay, so now let's come to big data. What is big data? It has three components that I was talking about. One is called as HDFS, Hadoop Distributed File System. The other is called as MapReduce, and the last part is called as yet another resource negotiator, or YAN. Okay, so before we dive into that, we'll see what exactly I mean by a Hadoop cluster, right? So what is a big data cluster? Let's imagine these are the three laptops. Okay, I went to Amazon. I brought three laptops from Amazon. I created a LAN between them. That means they're able to communicate with each other. Okay, and then I installed Hadoop on top. I installed CentOS. First thing is I installed operating system on all three machines. Okay, I installed CentOS. That is nothing but Linux distribution. So on top of that Linux distribution, I installed Hadoop file system and everything, and I started the Hadoop cluster. So in Hadoop, basically, in big data, you'll always see that the entire architecture is master-slave architecture. There will be one master and many slaves, okay? And master is in charge of monitoring the cluster, its health, and a lot of other functionalities. Main thing is it is acting as a mother figure, right? It will be taking care of the entire cluster. So this is where you start the cluster. If you see here, so if you see here on the master, I have started the Hadoop cluster. Okay, I did start all as such. That started the Hadoop cluster. So if you see, it went into slave 2. It logged into slave 2. That is the another machine. Okay, it logged into that. It started the Hadoop daemons in that slave machine. It logged into slave 1 and started the Hadoop daemons in that slave machine. So all that stuff, management stuff, monitoring stuff, everything is taken care by the master, whereas slave are the ones that store the data parallelly, process the data parallelly. So this is my master. These are the two slaves, okay, in my big data cluster. So I'm starting the entire cluster from the master. Okay, it will log into the slave 1, the necessary Hadoop daemons you can call, or Hadoop threads that run on the back end. Okay, and same thing, all the threads that need to run on the master machine, everything is taken care of by the master. Whereas the slaves are in charge of the processing the data parallelly, storing the data parallelly. Okay, now let's come back to the data part of it. So what exactly is HDFS, right? I talked about it being a distributed file system. So what is HDFS? Hadoop distributed file system, right? So how is it distributed and how is it a file system? In Linux, if you see the file system minus h. So if you see the here, it's not showing the file system. Yeah, it is showing, right? But just a minute. df minus h is not showing. Just df command. There is temporary. What is this df, by the way? Okay, but I don't know which exact command. But Linux file system is basically called as ext3, right? And in Windows, it is called as fat. If you look into it, you can actually see, I think, not sure. Earlier, it used to give it someplace. It actually tells you it's a fat file system, right? I think it's on the D drive. NTFS, yeah, NTFS and FAT. So these are the Windows file system. Whereas for Linux, it is ext3 something something, right? Same way, HDFS is the Hadoop's file system. Okay, but one difference is these are all running on the same machine, single machine, right? If you see the C drive and D drive, they're the same machine's hard disk only. It is split, logically split into two logical drives, that is C drive and D drive, right? In Hadoop, what happens is physically it takes the hard disk of all these three laptops, okay, and combines it into a big data pool, or what you can say, big data lake, right? And on top of that, it will create a logical layer. That logical layer is what is given to the user, and that is what is called as HDFS, right? So in order to, for example, to access HDFS, I'll run some command hadoop fs minus ls dfs, let's say dfs minus ls dfs minus fs minus fs, sorry, minus ls. So in even Hadoop language, I mean the what do you say, scripting languages in Hadoop was also similar to Linux. So if you see here, minus ls is nothing but same thing what we do in Linux also, right? List the contents directory. So I'm listing the content of the root directory. So if you see here, it shows me all the files in my HDFS, right? So there is a chance that the contents of this checkpoint directory the contents of the files in checkpoint directory may exist in any of the three hard disks. Okay, it is distributed that way. There is no guarantee that it will be in the same machine's hard disk. It may be in hard disk of slave 1 or hard disk of slave 2. But on top of that, it is creating a single logical layer for the user so that for him it looks as though it is on a single machine, right? In the back end, it is not. It will be there in different machines hard disk, right? In fact, if there, let's say there's a CSV file that is there in checkpoint, it may be split into two parts, and one part may be in slave 1's hard disk, the other part may be in slave 2 hard disk. Okay, so that's how distributed storage happens in UI itself. So I'll show you the Hadoop UI. 192.168. So I have to give the master's IP address. So this is the master IP address, and then the port number 50070. This is my Hadoop UI. Okay, so if I go to the browse file system, yeah. So if you look at this, there's a folder called as checkpoint ex5 my program log. Okay, this is a file basically. Okay, so let's say this file. Let's take the my proglog file. So it looks like as though it is there on a single system, right? No, this is nothing but a logical layer that the Hadoop has formed on top of the physical hard disk of all three machines. Okay, so my proglog.txt is split into 3 MB on all three machines hard disk, or an entire file may be on slave 1, entire file may be on slave 2 hard disk. So it all depends on the size. Okay, so let's come to that. How does it divide the file? Let's say my proglog was of size 256. In Hadoop, if a file is greater than 128 MB, right, then it will get divided. Okay, so I have created a CSV file. Let's see if it works or not. What happened to CSV file? Yeah, full CSV. Let's see. So if you see full CSV, it is what more than 1.6 GB. Yeah, 1.59 GB. Let's see how many blocks of data it gets divided. Okay, so let me come back and tell you what happened. So let's say this 1.5 GB file data, I push it to the Hadoop cluster, right? HDFS. So once I push it to HDFS, what happens is it will break that file into blocks of 128 MB, and each block may either go into the same machine. I run this command in slave 1, so it may go into the slave 1's hard disk itself, or the blocks may be scattered across the cluster. It may go into slave 2's hard disk. Some blocks may go into slave 2's hard disk. Some blocks may go into slave 1's hard disk, slave 4 hard disk, and so on, right? So that can also happen. So now let's see how a file gets divided. That's a better example to show. Okay, so how do we do that? Hadoop DFS. So this the next command that I'm going to do is Hadoop specific. It is not a Linux command. That is called as copy from local. So copy from local, it takes the local file and puts it in the HDFS. Okay, that is local file system is my Linux file system. That is the ext3. So in my Linux file system, there's a file called as full csv.csv in my root folder, right? So /root/ full csv.csv, and then I will put it in my HDFS root folder itself. So we must be able to see it in the UI that I showed you. Okay, so first let's run this, and root full CSV, no such file. This is 140, right? Cannot create, name node is in safe mode. Okay, Hadoop DFS admin safe mode leave. Problem is my cluster has some of the corrupted blocks, so that's why it always goes into safe mode when I start the cluster. So I have to do this every time. Anyway, so now let's run this command, copy from local. That's a big file, I guess. I mean, generally, see, when in an actual cluster, it won't take this much time because the RAM allocated to it will be huge, and they would have actual physical machines running in the backend, right? Mine is, since I'm running it on my laptop, I've given it very less RAM and everything. So, all this movement of data and everything requires a huge amount of RAM and stuff. It might also fail. Let us see. Still running. Yeah, finally it is done. So now let me change the screen. Let's go to the UI. Okay, where is that file? Full CSV. Okay, 1.6 GB. So if I look into that, there are 12 blocks. Okay, so this file got divided into 12 blocks. I think each block is what size? Let me check. Yeah, most likely 128 MB. Okay, that's what I said. Each 128 MB will form one block. So it has made into 12 blocks, and each block may be in a different hard disk. Okay, so that's this block pool ID is nothing but the cluster ID. So and all three hard disks combined will create a block pool. In that block pool, it will give all the available blocks where the data can go in and fit. On the high level layer, if you want to know what HDFS is, if you push data into your Hadoop cluster, it will get divided into 128 MB blocks, and that each block there is a chance that it may be in a separate machine's hard disk. That means if there are 5 slave machines or 6 node, it's a 6 node cluster. Any one of the nodes hard disk, the file may be existing. Okay, even inside the master node's hard disk also, it will consider even the master node's hard disk as well. So in my cluster, let's say this is my 3 node cluster. In my 3 node cluster, this 1.56 MB, when I pushed it into my HDFS, it got divided into 12 blocks, and those blocks can be scattered across the hard disk of any of these 3 machines. But when I do a cat command, you know what Linux cat command does, right? It will just show you the contents of the file. So when I run cat command, or let's not run tail -n10. Hope this works. I'm not sure if tail is that one. Let's see. Sorry. Full. Sorry. Let me change it. Applications slave one. So full CSV. So if you look here, as I told you, Hadoop commands are very similar to Linux commands. Only thing is you have to give Hadoop, then you have to mention the distributed file system, and then the Linux command. Okay, so here the Linux command tail, and then the file. It should give me the last amount of lines. So when I do this, it will take all the data from all the blocks, combine it, put it into the RAM of this particular slave one, and show me the data. So that's how the file is distributed physically. But in a logical layer, it will show me as one big file. If you look into the UI, it will show me as though it is just one big file, right? So if you look at the UI, if you see here, is that full CSV? Yeah. So full CSV is one file. It makes me look. I mean, it makes me believe like as though this is one big file that is existing on one single hard disk. But that is not the truth. That is just to make it easier for users to understand. Okay. But in the backend, as I said, it is on a different. It is scattered across the hard disk of all the machines in your cluster. So that is your HDFS. This is how you're able to store more data. Let's say all the three, now see, you're using 3 laptops. So your HDFS capability is what? Combined capability of all the hard disks. So if I have master 1 has 500 GB hard disk, slave 1 has 500 GB hard disk, slave 2 has 500 GB hard disk, then your HDFS size is 1.5 TB, right? So let's say tomorrow, even that 1.5 terabyte, your entire HDFS is full, okay, and you are getting critical. There are tools that does the cluster monitoring, health monitoring, and all this. There are big data tools that do that. So it will send you a mail saying that, okay, boss, your Hadoop cluster is almost full. Your HDFS is almost full. Please, create more space. So in what do? You just go to amazon.com, buy another laptop, connect it to this LAN that you have already created. You will increase the hard disk size, right? HDFS size will get incremented. Let's say you bought a new laptop for with 1 TB of hard disk, then you connect it to this LAN and you install Hadoop over there, and you have to, by the way, you have to stop and start the cluster again. So this cluster will accept that new node, okay, the one that you bought it off Amazon, and since it has 1 GB extra data, 1 TB extra hard disk, so now the now your clusters hard disk size HDFS HDFS space will be 2.5 terabytes instead of 1.5 terabytes. That's how you can keep on scaling your cluster. Okay, as and when your space or space issue comes in, you can keep on scaling. It's not a big thing to do. It's very easy. You just have to install Hadoop on that, connect it to your existing cluster, and you can just get get started with all your work. Okay, so this is your HDFS. Okay, that's the first part and the most important part. MapReduce, on the other hand, is the distributed processing part. So HDFS is what? Distributed storage. MapReduce is distributed processing framework. Okay, so what it does is, now the, let's say on that file I did that I ran a cat command, right? That is nothing but processing the file. So what happened, part of the file, it ran cat command on both the slave machines, and then the final result, it sent it to the slave machine 1 from where I ran the cat command. So parallelly, whatever blocks were there in slave 2, for that it did the cat, whatever the output came, it sent it to my slave 1, and slave 1 again on its own RAM.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Whatever on its own hard disk, whatever blocks were there, it did cat and merged the data what it got from slave 2 and sent it to me. Okay. So this is how the processing is also distributed. But again, the processing framework is called as MapReduce. It has its own characteristics. This is just a simple example that I gave you, but the actual examples are more complex in nature. I'll give you, I mean, I cannot show you the examples because most of the MapReduce programs are written in Java, and I don't have an example. Even in Python it is there, but I have to do a lot of exercise for that. I have to do a lot of circus. I don't have an example for MapReduce, but I can tell you what it may look like. Okay. And then we have the third part, what we call as yarn, yet another resource negotiator. So I told you that master has some significant functionalities, that is management of the cluster, right? Monitoring the cluster, managing the cluster, and all those things. So there are a couple of daemons, Hadoop daemons, that if you look into your master, you'll come to know what it is. So if you see your master, so when you look into my master, when I do Java process system, JPS is the command, I will see two daemons, okay, resource manager and name node. Okay, so these are the two daemons, Hadoop daemons. Daemons in the sense processes that are running on the backend 24/7 unless you stop it by default. So when I did startall.sh, when I started the cluster, these two daemons started running on the backend. Okay, so unless I stop it, it will keep on running 24/7. So name node is the part of Hadoop master functionality which keeps track of the metadata, right? So I was talking about the pool block pools and all this stuff, right? So all that information is captured in the name node. Name node's job is to make sure, okay, if that file full csv.csv got split into 12 blocks and all these blocks went into 3 different hard disks, how do you combine the data? How do you know where the each block of data is, right? So that information exists in the name node. Name node will have a log table. Okay, it will say, okay, full csv.csv, it has 12 blocks. First 3 blocks are in this particular machine, slave 1 machine. It will give the IP address of the slave 1 machine. In that slave 1 machine, this is the actual memory location, that is the physical memory location in that particular machine. So all that meta information is captured in the name node. Okay, and at the same time, the parallel task that I was talking about, right? Which machine will run the parallel task? What parallel task? It may be a five node cluster. Okay, it may not be necessary that all the 5 nodes will do the parallel processing. No, name node will keep track. Okay, this is the actual job. The job is to do cat full csv.csv. So I will see, I would suggest that this task be run on 2 different machines, 2 different nodes. Out of the 5 slave nodes, I'll run it on 2 slave nodes, and I will give them enough information for them to pick the data. So at that point of time, it will say, okay, slave 3 and slave 4, please run this cat command and send the result to the user or wherever he has requested, whatever, whichever place he has requested it, right? So that again job is taken care by name node. Whereas the job of resource manager is to make sure that the cluster is running without any issues. There may be a operating system corruption in one of the slave nodes. Slave node 3 may go down because the RAM got corrupted or the operating system got corrupted, right? So that information again is captured by the resource manager. It will say, okay, it will go to the name node and say, boss, uh, the slave node 3 has fallen down, so please delete all the information in the log about that particular block, because that name node is gone. Okay, so all the stuff is taken care by resource manager. It is managing the resources, and resources are nothing but the slave nodes. Okay, so these are the two daemons that run. So resource manager is nothing but the yarn. The another name for resource manager is called as yarn, yet another resource manager. And his main job is to make sure the entire cluster is running. Okay, and if anything happens, any minor stuff, it has to report to the name node so that it can make all the changes to its metadata information that it is carrying. So that is MapReduce and HDFS. One thing in MapReduce is, again, the job is basically divided into key value pairs. One more thing I forgot to tell you. The restriction for okay, so we discussed about HDFS and yarn, a bit about MapReduce, okay, that it runs parallelly. But what goes into MapReduce program basically is, your MapReduce program basically will be your Java program, and that will take the data in, it will take the input data and split it into key value pairs. Let's say your job was to read a text file, the CSV file. Let's go with the full CSV file only. Yeah, our job was to read this full csv.csv file and count the number of what is there in the CSV file. Okay, age count. Okay, so for, let's say, we'll take one column only. So our MapReduce job was to get the total sum of all the counts of the column count. Okay, so what we do is, first thing, okay, so okay, let's not go with this example. I'll go with a much simpler example. Let's say I had a text file. Where is, I know there's no text file. The Okay, let's say this is my text file that is there in my HDFS. Okay, so my MapReduce job is to read line by line and find out the total word count. This is the simplest example. So it should be like, so number of times Hadoop, the word Hadoop has appeared in the file, maybe 10 times, right? Usage 1 time, something like this. So this is what my final output is. This is my final output requirement, right? So in my MapReduce, all the problems that I put into my MapReduce, it has to be broken down into key value pairs. Okay, that is how it works. That is the entire MapReduce framework, because MapReduce consists of 2 sub programs. One is called as mapper program and other is called as reducer program. Okay, so in my MapReduce mapper program, what it does is, it takes the file as input. Let's say that some example.txt file is the file name. Okay, so my mapper will read this file, it will traverse line by line, and each line it will take each word and map it to a particular value. Let's say first time it encountered Hadoop, I will map it to a constant 1. Okay, next time again I get another, in the same line I get Hadoop, then again I map it to 1. Next time I'll go through this file by line by line. Okay. Yeah, first time I encounter usage. Okay, so it becomes 1. Next word is Hadoop. Again it is 1. Okay, next word is generic, something like that, and that is 1. So on and so forth. Let me go to another time where Hadoop is or anything is repeated, right? Pen to file, nothing. There's no repetition here. DST is repeating. Yeah, that's it. Okay, so it came to second line, and I mapped the word DST to 1. Okay, and then all the other words also, cat, everything. Then I came to this line. Okay, and again here I find DST, so again I will map it to 1. So this is what my mapper will do. Okay, then my reducer will do the aggregation, so it will aggregate based on the key. So all DST key, let's say DST is repeated in like 5-6 times in the file. In mapper the output will be like this, right? But once this will be the intermediate result of the mapper function. This intermediate result will be the input for my reducer function, reducer program. Okay, so my reducer program will take this intermediate input and do the aggregation based on the key. So now for DST key, the aggregation I'll do is sum. Okay, so it will sum up all the values. So I will get 1 2 3 4 5 6. Okay, so 6 will be the output for DST. Rest all it is repeating only once, so the value will be 1 itself. Okay, so this final result will go into my output file. So every problem in map reduce, I have to break it into key value and then do it like this. Okay, first I have to create a mapper function which will map each key to some value. Okay, here I have given a constant 1. You can do whatever you want according to your problem, right? According to what exactly your problem is, you can work it. You can map that particular value there. For me, my problem is to get the word count, so I have given the constant value 1 for each of the word in the text file, right? So once this mapping is done, this intermediate result is stored somewhere in that particular slave node's hard disk. Okay, HDFS, basically HDFS. So let's go into more generic terms. It is stored in the HDFS of the it is stored in the HDFS, this intermediate result. Again, this intermediate result is read from the HDFS by the reducer program, and some aggregation is performed. In my case, the aggregation is sum. Okay, so I'm summing up all the values for same key. So for each same key, it is doing the aggregation function sum, and then the final result is written back into your HDFS. So that is what the map reduce is all about. But this is done parallelly. So this, let's say this file, right? This file is divided into 2 blocks, and it is there in slave node 3's hard disk, slave node 4 hard disk, right? Then I write this MapReduce job and I submit it and I run it. So when I run it, the master node, the resource manager and name node together will decide which 2 nodes to run. I mean, which nodes to run. Okay, so it will say, okay, out of the 4 nodes, slave nodes that I have, I will slave node 3 and 4 are busy, even though the data exactly resides on their hard disk. They're busy, their RAM is completely full. They're running some other MapReduce job, so their RAM is full, we cannot use it. So that's what resource manager will tell the name node. So then name node will decide, okay, then we will go with slave node 1 and 2. Their RAM is completely free, but they do not have the physical data on their hard disk. It's not a problem. I will give them meta information about this Hadoop command.txt file, where exactly where exactly in slave node 3 and slave node 4 the block of files exist, so they can take it up from there. So slave node 1 and 2 will run the MapReduce program in parallel. Slave node 1 will take the data that resides in the hard disk of slave node 3. Slave node 2 will take the data that resides in the hard disk of slave node 4, and parallelly they will do this computation. Okay, so once this computation is done, so on slave node 1 this may be the result, slave node 2 there may be some other result, then finally they will shuffle it up and final result will be there. Okay, that final result will be written into the output file. Okay, so there is mapper, there is a reducer, and then there is a shuffler. shuffler will shuffle the final data and write it to your HDFS. That is what MapReduce is. The problem with this MapReduce is two things. One is how it runs. There is too much of IO interactivity. As I told you, mapper will directly write the intermediate result to HDFS, and reducer will read the intermediate result from HDFS and work on it, right? So if I have a very complex program, then I cannot do it in one single MapReduce program. I may have to write a chain of MapReduce, right? So this reducer output will act as an input for my next MapReduce program, right? And that MapReduce program's output will act as a input for the next uh, MapReduce program, right? So there will be a chain of MapReduce programs to complete one single user goal, right? So at that point of time, the IO operations will become very costly. Each mapper will write to HDFS, each reducer will read it, and then finally it will again write it back to HDFS. Then the next MapReduce functions mapper will read it from HDFS, write the intermediate result to the HDFS, then the reducer will take it from there, then the reducer will write it to the HDFS, then the third MapReduce program, MapReduce program's mapper function will again take it from the HDFS, and so on and so forth, right? So the IO part itself will be a process overhead. Latency will be very slow, right? For example, if the data resides on a different node, every time it will go to that particular node and get the data, right? So that will be a problem. And even if the intermediate result also is being written to a completely different node, then again that's a problem. Network bandwidth and all those things. Even let's say it is on the same slave node where the MapReduce function is running, the intermediate results is also being written there. Even then, again, every time you're contacting the hard disk and getting the data, that is a process overhead. Okay, so that is why the Spark became more famous. And Spark is nothing but it is replacing the component 2. Okay, it is the distributed processing framework which solves the stop gaps, which solves all the gaps in the MapReduce processing framework. Okay, so that is the simplest way you can put Spark. So Spark also uses HDFS for its storage layer. Okay, and it uses Yarn, the resource manager, to fetch the resources.
Just a quick info, guys. Intellipaat provides Pyspark online training mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session.
But it is not necessary. Spark can also work without HDFS and without Yarn. It can work with any file system. It can work with Windows file system. It can work with Linux file system. It can work with any other file system. So this Spark doesn't have any compulsion as such. But the best combination you will see in your client environment will be storage layer HDFS, resource manager will be Yarn, and the processing framework will be Spark. Spark is basically solving all the problems. One is in MapReduce, you have to break your entire complex problem into key and values. Okay, if your problem in this case, that's why I didn't pick that CSV file. In that CSV file, it was a table, right, where you have to do some. They're doing some count and stuff. Let's say you want to do some operation like this, right? Select star count, select name or something like that. Name count star from user group by department, something like this. If I'm saying you have to visualize this SQL operation into an actual big data problem. Let's say from the CSV file, you want to get all the names for a particular department, all the name of the employees belonging to a particular department with the department count, number of employees in a particular department. So sorry, department. Okay. Yeah, so let me rephrase my problem. Let's say my problem is to get all the departments in a particular university or a college and the number of employees in each department, right? So in order to do that, your SQL query will look something like this. Okay, and your MapReduce program will be even more complex. It will be a chain of MapReduces, because every MapReduce you have to break the problem into key value. Okay, so you have to first take the key as department, and then first count the department total count, and then in the reducer you'll have to sum it up, and then you have to you can also use another aggregate. You can use group by also in reducer. Okay, all the stuff. Okay, so it will be like 2 or 3 MapReduce functions that you will have to write. So every complex program, the number of MapReduce programs that you will have to write, the chain of MapReduce will be huge. So that is cumbersome in terms of development. At the same time, as I told you, each MapReduce there is intermediate results being written into HDFS. So that again is a problem that fetching the data from HDFS, writing it to HDFS every time will be is a process overhead that slows down your processing. So that's why Spark comes into play, and what it does is it will do all the processing, all the saving of all the intermediate result into the RAM of that particular machine where the processing is happening. Let's say I told you in my example, the name node chooses slave 1 and slave 2 to run the processing parallelly. So in this slave node 1 and slave node 2, all the computation will be happening on the RAM itself. The intermediate result will also be written in the RAM. Again, the next part of the code will be taking the intermediate result from the RAM itself and again processing in the RAM itself. So the data movement is from RAM to RAM, right? Within RAM, or you can say within RAM, right? So there is no latency there. There is no process overhead there. That is the biggest example and biggest problem that was there in MapReduce that was being solved. The next biggest problem is the key value. You cannot put every problem into key value, right? So there we have a lot of concept called as Spark SQL, data frames, RDD, and all the stuff. So it is providing data structures that can capture data as a table, like a MySQL table itself, and that table will reside in the RAM of that particular node's particular machine where the processing is happening, right? Hadoop is basically fault tolerant distributed system. Okay, how is it fault tolerant? So what happens? There's something called as replication factor. So when you look into this file, full CSV, I told you that it got divided into 12 blocks, right? And 12 blocks is scattered across the cluster's hard disk, each machine's hard disk, right? Another thing it does is it creates a replica of each block. So there's a replicated block of 0, replica of block 1, replica of block 2, replica of block 12. Okay, each of the blocks, and each of the replicas will exist in a different machine. Let's say block 0 was in the hard disk of slave 1, then block 0's replica will be in slave 2. Okay, block 1's replica is in slave 1 because the original copy is in slave 2. So what happens is, in case slave 1 falls down, the name node and resource manager will inform the name node boss, the slave node 1 is gone, the operating system is corrupted, it fell down, I don't know what the reason is, it is not coming up, so please remove all the entries and bring up the backup nodes, backup blocks, and make them as the original backups now, right? So what happens, let's say slave 1 was having the block 0, okay, and slave 2 was having the replica of block 0. Now what name node will do is name node will erase the entry for block 0. In block 0 it would have given the entry block 0 exists on slave 1's hard disk in this memory location of slave 1's hard disk, right? So that it will erase, then it will make slave it will say block 0 now exists on slave 2's hard disk and it is in this particular location of that particular hard disk, right? So all those metadata changes it will do. So how now what we can call this is a fault tolerant system, right? Now there was a fault, system fell down, one of the slave nodes fell down, but nothing changed. Data did not disappear, data did not get corrupted or anything, it is as is, right? So this is called as fault tolerant system. So for that to happen, you have to set replication factor when you're configuring Hadoop. So if you keep replication factor as 2, then it will keep original copy and 1 backup. If you make it as 3, 1 original copy, 2 backups. If you keep it as 4, like that, so on and so forth. And each backup, you will try to make sure that it is on a completely different slave node, so that when it falls down, there's always a copy of that particular block, right? So that is what fault tolerant system is. There are more components of Hadoop. I mean, not Hadoop, Hadoop-like tools that you can have a look at. So within big data ecosystem, these are the most commonly used tools. Okay, we have MapReduce that is used for processing. Spark is a competitor of MapReduce, but it is more efficient. So this is also a parallel processing framework, and this is in memory. The biggest advantage is in memory, so there it solves a lot of gaps that exist in MapReduce. So these are the two tools when in big data, which is used for parallel processing. Okay, then we have Hive and Drill, that is SQL-like tools in Hadoop. Okay, so in the backend, for example, if we take Hive, Hive is called as a data warehousing tool in big data, but that is not what it initially was. It is initially people brought in Hive as an SQL interface for on top of MapReduce. I told you, right, in MapReduce you have to break down every problem into key and value, right? And people cannot not I mean beginners or beginners into Java programming, they cannot create all those complex MapReduce programs. Rather, they would be comfortable writing SQL like queries, right? So Hive was built specifically for that. Hive is just like your MySQL. Only thing is it acts as a SQL-like interface. In the backend, MapReduce is running, and it is being processed parallelly. Since in the backend MapReduce is running, the data is being processed parallelly, right? So that is the difference between Hive and MySQL. So overall, over the period of time, Hive became what we call as a data warehousing tool for Hadoop. Okay, everyone is like, okay, you want to work with Hive, then that we can configure it as a data warehouse, and all their data warehousing stuff is moved into Hive. Okay, so just give you sample on how Hive looks like, and I can even show you in the backend what happens. Okay, so this is the Hive shell. Something. Oh, I haven't started Hadoop. Just give me 1 minute. Start all. Search. Hadoop. DFS admin. Safe mode leave. So if you see, the commands are same, like show databases, same thing what is there in MySQL, but MySQL is this what is there, databases, DATABACS. Okay, so only difference is the couple of differences. MySQL, first of all the processing, it's a single machine software tool for databases, and so it's running on a single machine. Okay, there's no parallel processing. Hive, it is using MapReduce for all its processing needs, so definitely it is a parallel processing tool, right? Second thing is Hive doesn't have a ID per se. You have to use shell. Okay, MySQL has a lot of IDs to support. There are even actually for Hive, you do have third-party tools that can IDs that can connect to the Hive shell and give you a much better look. But for now, yeah, I don't have any. I think there's some tool I forgot. Okay, yeah. Third thing is this is what I saw. Yeah, this needs Hadoop in the backend. Okay, without Hadoop, Hive won't run. As I told you, Hive is using MapReduce, right? So in order for MapReduce to run, it has to have. So in order for Hive to run, MapReduce should already be there. So for that, Hadoop should have been started. Hadoop cluster should already exist, right? So that's why it gave me an error initially, because it said that Hadoop is not running in the backend. So I'm not going to allow you to do anything. Okay. So show databases, use test one, show tables, select star from user one. Okay, so now if you see when I run this command, okay, it's not showing the number of mappers. We'll insert something into user, then you will see. Generally, any command you run in the backend, the MapReduce is being run there. Okay, but generally it should give the mapper information. It's not giving actually. Okay, failed with exception, could not. Okay, the block is corrupted, that's why. Okay, fine. So we will create a table. What's that? Create table, user2, name is string, employee ID is int. Okay, oh, user2, I made it at user1. Okay, yeah, okay. Insert into user2 values, Praveen, 1, 2, 3, 4. Okay, now if you see, number of reduced tasks is set to 0. There is no reducer operator launching. So all these are map reduce stuff. Okay, it gives you a yarn tracking URL also. So this is the yarn URL. Unfortunately, I cannot see it on the browser because it doesn't allow me for some reason. Okay, and then see if somewhere it will give number of mappers used, number of reducers used. Okay, map reduced jobs launched. Mapper is 1. Okay, number of reducer, it already said that there's no reducer, so that's why it's not shown. Okay, some if you do some aggregation, you will see that some reducer is also used. If you're saying select count, let's do that. Select count group by empid. Okay, empid is not there. Describe user to. Oh, I didn't give from user to. Okay, number of reduced tasks not specified. In order to change average load and reduce or something. Hadoop job, number of mappers 1, number of reducers 1. So if you see, in the earlier one, there was no need for a reducer, so it did not create a reducer. In this, since we are doing some aggregation, a reducer was used. Okay, so this is the basic example. Anyway, we will do more. I mean, it won't be an in-depth session. We'll do a basic session on Hive as well when we are working with Spark, SQL, and data frames. Okay, but basically, this is what it's all about. There's nothing much apart from this. It's a SQL-like interface built on top of MapReduce. Okay, so that data warehouse developers can also use Hadoop. Okay, so that was the basic aim of bringing in Hive.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. dstream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So similar tools, SQL-like tools like drill also exists. Okay, it is quite similar to Hive. Only difference is, I think, there was a, known difference, but this is a newer tool. Okay, Apache drill came after Hive came into picture. So now coming into streaming, we have Kafka and Storm, and also Spark streaming. Okay, so these are the 3 common big data tools used for streaming. So what is streaming? As I told you, it is to create a channel between your system, your cluster, big data cluster, and the live source, live data generating source, right? Like Twitter. In Twitter, every second some guy is tweeting, right? So it's a live data source. It is generating data every second. So all these streaming tools basically create a channel between your cluster and the live data source so that it can pull in data as and when the data is generated. Okay. Then for ML machine learning, we have Mahout and Spark MLlib. Then scripting, we have Pig, which is again a tool that is going to be removed sooner because the adaptation is not that great. Earlier, when Hadoop was there, only MapReduce was there. Pig was a big stuff. It was occupying around 40% of the big data market. But in today's date, it is around 10%. Okay, it is kind of like a scripting language where somewhat similar to SQL only. Okay, if you look at the scripting language, sounds similar to SQL, but not exactly SQL. Okay. Then searching and indexing, we have Solar and Lucene. Okay, and NoSQL, we have Cassandra and HBase. Cassandra is basically, yeah, again, one more thing. Hadoop, by default, it is open source. Okay, what I have installed in my cluster is basically open source Hadoop, but it also comes in flavors, meaning that on top of these tools, some distributors like Cloudera, the exam that we are talking about, right? Cloudera is basically a company that initially started by giving its own distribution of Hadoop. Okay, so what it used to do on top of all this tool, it would create its own layer. Okay, it created a managing software called as Cloudera Manager. Okay, so it's like a UI one-stop shop.
You just start the Cloudera manager. From there on, you can start on all these tools automatically, right? So that is kind of what distribution is, third-party distribution. But people can use free open source Hadoop as well. Okay, but generally, people go for Cloudera MapReduce for the reason any problem we have a team from the Cloudera side or the MapR side or Hortonworks side. These are the companies that actually give distribution of Hadoop. Okay, so we can contact them and get it solved, right? Whereas in open source, we have to rely on open source community. So all these clients basically don't want that. They don't want that risk to exist on their side. They would rather have other companies taking that risk, right? So that is the reason why all these enterprises go for third-party distribution of Hadoop rather than the original free open source Hadoop. Okay. So, so coming back, so Cloudera has its own NoSQL also called as Cassandra. Okay. Then in scheduling we have Uzi. Cloudera has Cloudera Manager. Okay. Cloudera Manager does both management as well as scheduling. So Zookeeper and Uzi has been combined in Cloudera Manager. And again, Mapper also has its own, Hortonworks also has its own tools. Apart from the secondary layer that is creating on top of all these tools, they also have their own tools for that. Okay. And resource management, there is Hadoop Yarn, Apache Mesos, and Kubernetes and all those stuff. Storage, there is HDFS. Okay. In offline, there is only one distributed storage, that is HDFS. That's why it has dominated the market when it comes to storage layer. But on cloud, there is S3 in AWS. In Azure, we have ADLS, Azure Data Lake, and then in GCP, I think it is called Google Storage or something. Okay, I'm not sure about that. So yeah, basically this is what your big data ecosystem will look like. These are all the tools that you may work with. You may work with. It's not like you'll have hands-on on all the tools, but major ones will be your Spark. If they are not working on Spark, then it will be MapReduce, Hive definitely, and if they are working with live data, then Kafka, and for storage, definitely HDFS if it's on premises. If it is cloud, then something equivalent, right? And resource manager, basically it will be Yarn. Yarn also dominates the market when it comes to resource management. Okay, so that was about the Hadoop ecosystem. What is Spark and why it has become more dominant when compared to MapReduce. Right? So Spark was introduced by Apache Software Foundation for speeding up the computational procedures of the software process, basically the processing layer. Spark uses Hadoop in two ways. One is storage, that is HDFS, and another is processing. Since Spark has its own cluster management computation, it uses Hadoop for storage purpose only. Not exactly true. Spark also comes with its own cluster manager. But as I said, Yarn has a bigger market. So Hadoop uses it in two ways. One is the storage layer and the resource management layer. Okay. But yes, Spark also has its own cluster manager also. So it is called a Spark standalone cluster manager. But it has its own advantages and disadvantages. People generally don't use it. In a ideal setup, your company will be working with Hadoop cluster, and on top of that Hadoop cluster, they would have installed Spark cluster. So that way, Spark will be using HDFS for storage and Yarn for resource manager. Okay, that is an ideal setup. On cloud also, S3, like if you're talking about AWS, you may be working with EMR. So in EMR, Hadoop cluster will be created. On top of that, Spark cluster can be created. Okay, either that setup or they may be using Databricks itself. So AWS has okay. So yeah, first before going to what Databricks is, we'll look into basics of it. Okay, so basically this will be your ideal setup. Okay, but that doesn't mean Spark doesn't have its own cluster manager. It has, and also it doesn't have to completely rely on HDFS for its storage. It can directly work with your file system. That means it can directly read and write files from the local file system. If I've created a Spark cluster on these three machines which have Linux installed, then my Spark program can directly pick up files from the Linux file system and read and write into that only. It doesn't need HDFS. Okay, but people want that because there's an additional distributed option that it gets, right? HDFS by default is a distributed storage system, right? And Spark is a distributed processing system. So there are two layers where the distribution happens. So if your Spark is not going to use a distributed storage system like HDFS, and it's going to go with a local file system like Linux or NTFS in Windows, then you lose that advantage, right? There's no replication factor for the data that exists on NTFS, right? But in HDFS, that is there. So basically, that is the reason why they go with this ideal setup. Okay, before going there, Spark founder is Matt Zaharia. Okay, so this guy saw the gaps in MapReduce that we talked about, and he decided, yeah, I know all this writing intermediate data for processing into HDFS is a time-consuming process. That is the reason why it is comparatively slower, and also imagining every problem as a key value pair is not going to solve everything, right? So rather we should create something that first thing, it does all the processing in that particular nodes slave machines RAM itself, rather than writing the result to HDFS. So that was the first problem that he solved. And second problem, he brought in more functionality, okay, that would allow you to move away from that key value pair problem, key value pair solution, right? Breaking down every problem into key value pair solution. He improved that. Okay, it's not just you can use MapReduce in Spark. You can also have 100 different other. There are around 60-80 API functions that allow you to imagine the problem beyond the key value system. Okay, you don't have to break the problem into key value every time. Spark will allow you to do that. So that's the two things that he solved. Okay, and also, yeah, allowing a lot of integration with a lot of tools and data sources. Hundreds of data sources can connect to your Spark cluster. You can read and write from hundreds of different data sources. It can be a CSV file, it can be a MySQL database, it can be an ELK stack, and hundreds of sources. Okay, so these are the couple of advancement when we compare it with MapReduce. Yeah, and he also started a company called as Databricks. Okay, so that company is basically responsible for all the Spark versions, even though it's an open source software. But the versions and everything is developed by Databricks. Okay, and they also have their cloud platform, which is now the dominant big data, dominating the big data market. So if you look into big data market, Databricks itself, Databricks big data platform takes around 60% of the big data market. So it's a cloud platform built by Databricks that has integration with AWS, Azure, and Google cloud platform, GCP. Okay, so it has all the three integrations. So that means even in your Amazon, if you see AWS, you will see that it is selling the Databricks platform. Amazon Web Services, Databricks on AWS cloud. Okay, so they are integrated in that sense. You will see when you create an AWS account, you will also see that Databricks platform, Databricks cluster is also part of its solutions. Okay, then if you look into Azure, okay, fine, Azure Databricks. Okay, so Azure also has it. Once you log into the Azure portal, you will see that there is a separate tool for data, I mean, separate section for Databricks, in which you can create a Databricks cluster, and then you can integrate the Databricks notebooks with the Databricks cluster and all those stuff, create workspace, etc., etc. Right? So that kind of a platform it is. So that's the biggest achievement by Databricks. They successfully integrated their big data platform on all three leading cloud solutions, right? So that way they have dominated the market. So everything you see is basically from the guy who invented Spark. Okay, yeah, so that is about Databricks. So every year now they are release around 2 or 3 versions of Spark. Okay, currently the Spark version is 3.0 something. I think it is 3.1 or something. 3.1.1. Okay, yeah, Matai Zaharia is the guy who founded Spark, and initially it was written in Scala. Okay, but a lot of people found Python as an advantage. We will anyway read it when we go through it. Why Pyspark became more dominant. Okay, in Spark there are 4 languages that you can use: Scala, Python, R, and Java. Okay, and even now they're adding Go and Node.js and all those stuff. But these are the four basic. Initially, these were the four languages that you can use to write Spark code, right? Okay, Apache Spark is a lightning fast cluster computing technology designed for fast computation. Okay, there are two questions here. Is Scala faster than Python? Yes, of course. It's not an interpreter based language. It's a compiler based language. So technically, Python is 1.5 times slower than Scala and Java. Okay, but that disadvantages doesn't exist in Spark. I will tell you why. Okay, so in next few slides, I think we do compare it. Fault tolerance, use Spark. No. Okay, we are just comparing Hadoop and Spark. It is based on Hadoop's MapReduce, and it extends MapReduce model to efficiently use for more types of computation, which includes interactive queries and stream processing. So this is what I told you. It not only uses MapReduce, what was there in Hadoop, it also extends the model and adds more functionality to it. So you don't have to imagine all the problems in key value pairs. Okay. Spark is one of the Hadoop sub-project developed in 2009 in UC Berkeley's AMP lab by Matai Zaharia. Okay. Apache Spark started as a research project in UCB. It open sourced in early 2010, and in 2013 it became top Apache project. So top Apache projects are when people start adapting to that technology. So any project that goes into Apache, first it goes into research phase, then all this testing, bug fixing, and all those stuff, and ultimately it is given the status as top project. Okay, so once it becomes a top project in ASF, basically that means that it is stable. There is a stable version of the software, and people can use it. So it became a stable version in 2013, and early 2014 is when people started adopting it. Many of the ideas behind the system were presented in various research papers over the years. Today, the project is developed collaboratively by a community of hundreds of developers from hundreds of different organizations. But Databricks is the company that releases the each version of Spark. Okay, but they look into the community issues. So if you look in, there is a Jira dashboard for Spark, where the community can so Spark ASF Jira. Within this Spark support or somewhere, Spark Central, this is the one, correct. So here you can create issues and submit. If you have found out any issues with the Spark code, then you can submit it there. All those issues are taken up by Databricks, and when they release the next version, that those bugs will be fixed. Okay, so it is collaborative. It is run open source only, kind of, not exactly truly open source, but yeah, the code is available to everyone. Everyone can look into it. It's there in ASF. Okay, but the versions is being delivered by Databricks. Okay, features of Apache Spark: speed. Spark helps run an application in Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. This is possible by reducing the number of read-write operation on a disk. So something that MapReduce was doing every time, right? It stores the intermediate processing of data in memory. And the next feature is support of multiple languages. So Spark provides built-in APIs in Java, Scala, and Python and R. Okay, therefore you can write application in different languages. Spark has 80 high-level operators for interactive query. So this is what I was talking about. 80 high-level functions is provided by Spark. So two of them are map and reduce. Okay, two functions are map and reduce, but rest are all more advanced functions that allow you to imagine a problem beyond key value. Okay, and you can use any of the language. They are all the function. If you see the Spark, these 80 high-level functions provided by Spark is same same in Java, same in Scala, same in Python, and same in R. Maybe the rest of the stuff is different, but the function names, how you call them, what are the parameters of a function, are all same across the languages. There's no difference in that. Only the implementation part is how, like in Java, you use curly braces and you use system.println, all those stuff. In Python, you use print, you use what do you call, tabs and stuff. That's the kind of way you write it. So that is the kind of differences. Okay, the way you write Python program is of course going to be different than Java, or how you write Scala is going to be different than Java, right? But at the end of the day, the Spark provide the functions provided by Spark. These 80 high-level functions have the same names across languages, and it takes the same number of inputs. That means each function will be taking some input, right? So the number of inputs are same in all the languages. Advanced analytics. Spark not only provides map and reduce, but also supports SQL queries, streaming data, machine learning, graph algorithms, and all the stuff. That's what I was talking about. It has moved on from MapReduce, moved on from the key value pair solutions that MapReduce was giving, right? Hadoop's MapReduce was giving. In-memory computation, no need to fetch data from disk every single time. Most of the data will be on your RAM itself, on that particular machine's RAM. Okay. Fault tolerance is provided through Spark abstraction of RDD. So there is double when you're the another advantage that I was talking about, right? Fault tolerance. So HDFS is also fault tolerant, as I told you. If a particular slave node falls down, then the replicated block that is there in the other machine comes up. That becomes the original block, right? So that's how fault tolerance is implemented in HDFS. In Spark, also similar stuff is there. While processing, a particular slave node fell down. So the data that the particular slave node was working on is gone, and the processes that it had already completed is all gone, right? So that again is that fault tolerance is again brought in Spark. Okay, so there is a way where even if a slave node that was processing goes down, there is no stopping. I mean, there is no breakdown of the system. Okay, the processing completes even when a single slave node has gone down, which was working, which was processing the data, falls down. This processing will still complete without any errors. Okay, so that kind of fault tolerance is given in Spark. So there is double fault tolerance, one at the processing layer given by Spark, and one at the storage layer given by HDFS, right? So that is the reason I'm telling you, in an ideal scenario, it is Spark for processing, HDFS for storage, Yarn for resource manager. Okay, so this will be your ideal on-premises setup. Apart from this, they may go for other tools also, like, instead of Yarn, they may use Apache Mesos, but that adaptation is very less. Okay, I don't see any advantage there. Okay. Similarly, instead of HDFS, they may go with local file system also, but that is very rare. Unless you are on cloud. In cloud, of course, they have their own storage layer and resource manager. But even in cloud, resource manager is still Yarn, I guess. I'm not sure. Databricks, by default, it works on top of an Hadoop only. Okay, but storage layer, it is using the cloud's native storage layer. Like in Azure, it will be ADLS. In AWS, it will be S3, right? So Databricks will use that only. But for processing, I think even that uses Yarn, if I'm not wrong. Okay, yeah, and it is lazily evaluated. Again, we'll see this property in module 4 when we look into what is lazy evaluations. Okay, all transactions made in Spark RDD involves creation of a new RDD. This enhances efficiency of system. Basically, lazy evaluation is something where the slave node that is working on the data doesn't initially start the execution as soon as it gets all the information. It will wait for a certain action that comes from the master. Until and unless the master sends that action, the slave node will keep on it will keep on collecting all the data and stuff. It won't start the processing immediately. Okay, so that kind of brings in efficiency. We'll anyway, and at this point it will look it will be very confusing, so I don't want to go in detail into what lazy evaluation is. But when we start in module 4, we'll talk about fault tolerance and lazy evaluation. Okay, and how it is doing in memory computation and stuff. So basically, this is your architecture that I was talking about. So we have processing layer, we have Spark, we have Yarn for cluster manager, resource allocation, and we have storage layer as HDFS. Okay, then we have Spark streaming to get data from live sources and either use Spark later on for processing and do all those stuff. Okay, so this is generally what I was talking about. Ideal scenario: storage HDFS, processing Spark, resource manager Yarn. Okay. Who uses Spark? Everyone does today. In today's date, all the companies use Spark only. They have moved away from Hadoop's MapReduce framework. There may still be companies using it, but of course, I'm pretty sure they are thinking of moving from MapReduce to Spark. So they may be doing some migration. That is also possible since Spark came only in 2014, right? And as you know, any new technology is not adopted by everyone immediately. It doesn't mean that Spark is not being done. Spark has 90% of the big data market. Okay, there's only 10% of people who are still using MapReduce. So they are also moving. There is all migration. Currently, what I'm doing is also migration. Earlier on, but my migration is different. It was from a distributed data warehousing tool called as Netezza. So from Netezza, I'm migrating it into Spark cluster. But I've also done Hadoop MapReduce to Spark migration also. Okay, that is also happening across companies. So if you ask me who isn't using, I don't know. Everyone is using Spark. That much I can guarantee. If not, they're thinking about using it. So in the Spark ecosystem, even though Spark is a processing framework, within the processing frameworks, there are sub-modules. Okay, so the first sub-module is Spark Core. That is the main module, and it is the top layer in the Spark ecosystem. It is the one that directly interacts with the data sources. I mean, it's not exactly correct, but yeah, data sources directly interact with Spark Core. It can also directly interact with streaming Spark SQL also, but it is now you can say that Spark Core is the one that is directly interacting with the data sources. Okay, then we have data frames. Data frames is where is a copy of pandas data frame. Okay, so in Python we have all the data analytics is being done using two tools, pandas data frame and TensorFlow. TensorFlow is the ml ai library, ml ai library, right? And data pandas data frame is to capture all data in a table like structure and do all the joins that you do in your MySQL, right? Same thing you can do using data frames. So that is the reason why pandas data frames became very famous. We can capture the data in a very structured way. We can use all the SQL like joins. Okay, so people need to know very less about coding, but need to know more about all this SQL stuff, right? So but the fault with pandas data frame when compared to Spark data frame is it is not distributed in nature. Again, pandas data frame is working on a single machine, and also again, even in pandas data frame, the data frame itself is being stored in the RAM of that particular single machine that we are talking about, right? So all the processing is happening on the RAM itself. Pandas data frame won't generally store it in the hard disk of the machine. So that's why it became more famous. Okay, yeah, that is the main reason why it became famous. The processing, the data frames, the table like structure that I was talking about is generally saved in the RAM, and all the processing happens there. So when you are picking the data from the RAM itself, it is faster compared to picking it from the hard disk. But one disadvantage between pandas data frame and Spark data frame is the distribution nature, right? It is a single machine. Pandas data frame works on a single machine, whereas Spark data frame works across a cluster. So the data frame itself is split into parts and being processed separately. Anyway, I'll tell you how when we look into that Spark module, right? So that is the difference between them. Then we have a machine learning library. We have Spark streaming used for live streaming of data. I mean, to work with live data, right? So there is a difference between how you process batch data and how you process live data. In Hadoop, there is no way you can process live data. Okay, everything is batch processing. Hadoop MapReduce is only used for batch processing, meaning that the entire data already exists somewhere. Either it's in HDFS or is in some other storage layer, but the entire data is already there. Okay, it's in a CSV file or it's in a text file. But live streaming or live processing or real-time processing doesn't work like that. It works on data that may come at 9 o'clock. Okay, and it may be you may not get the data for next 5 minutes. Then again you may get some data. Then again you may not get some data with in the next 2 or 3 minutes. Then again you may get some data. So live data works like that. So you don't know when the data will come in. Whereas in batch data, you already know where the data exists and you can process it. So Hadoop MapReduce only works with batch processing. Okay. Whereas in Spark, there's a separate module to deal with live data. It's called as Spark Streaming. And then they have another module for SQL like development. If for people who do not have much knowledge on Python and do not have much knowledge on coding, but they are good with database development. They are a DBA guys, database developers and database admins. Okay, so they know all this SQL like querying. So for them, they have created a separate module called as Spark SQL, wherein which it's more like doing what exactly they're doing till now. Only thing, little bit of Python, Pyspark code needs to be used. Other than that, it's all about the querying only. Okay. Then for graph data, we have another module called as GraphX. Spark Core is the main one, as I told you, is the underlying general execution engine for Spark platform that all other functionalities is built on top of it. Okay, it provides in-memory computing and referencing data sets in external storages. Not exactly true. I mean, Spark Core is not the only one. All the other layers also do the same thing. Okay. Spark SQL, the Spark SQL component is a distributed framework for structured data processing. Using Spark SQL, Spark gets more information about the structure of the data and computation. With this information, Spark can perform extra optimization. It uses same execution engine while computing an output. It does not depend on API language to express the computation. So this is the main thing. Basically, it is all about SQL querying that you can use. You don't need to know other languages. Maybe you don't need to know Pyspark complete in detail. You just need to know how you can use Pyspark to run your SQL queries. Okay, how you can use the Pyspark SQL. That's all you need to know. Spark Streaming is an add-on to core Spark APIs, which allows scalable, high throughput, fault tolerant streaming processing of live data streams. Okay. Spark can access data from sources such as Kafka, Flume, Kinesis, TCP sockets, AKK, 0MQ, a lot of other sources are there, live data sources, right? Flume is already there, right? Yeah. So it can ingest live data from any of the streaming tools. Okay. There's also a provision within Scala Spark, not in PySpark actually, to directly connect to live data streams. Okay. Like in Scala Spark, we have an option to directly connect to Twitter and get the data, but unfortunately in PySpark we don't have it. As I told, okay, yeah, I forgot to tell you one thing. The Spark is developed in Scala language originally. Okay, then all the Java native conversion, Python native conversion came in later on. Okay, so Scala, in terms of that, it has good integration.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, since Spark was built on top of Scala, so there are a lot of extra functionalities in Scala Spark that is not there in PySpark. One of them is connecting to live sources. Okay, so Scala Spark has a library, or I don't know what we call in Scala. I mean, we call it library only. Yeah, in Scala there's a separate library that connects to Twitter directly. Okay, but in Python, PySpark, we cannot do that. We have to write a separate code in Python using TweePy module that will connect to Spark and push the data to Kafka cluster. Okay, but in Scala we can directly connect to Twitter. So there are some differences. So of course, Scala Spark and Python Spark, there are differences. We will see that which one is better. You'll come to know later on. Okay, but I'll tell you the answer also. PySpark is still better. Okay, we will see that why. Okay, why the answer to that question why, we'll see that in module 4. Okay.
Just a quick info, guys. Intellipaat provides Pyspark online training mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session.
Finally, the data received is given to the file system, databases, and live dashboards. Spark uses micro batching for real-time streaming. Okay, so it takes ingests the live data and splits it into micro batches. Okay, but again, that doesn't mean that it is doing batch processing. It is called as real-time processing only. We'll again see that in Spark streaming. If I tell you everything now, it will become something that is confusing. For now, you need to know that there is a module in Spark that allows you to ingest data from live sources and process it. Either you can store it in databases or push it to some live dashboards like ELK or Zeppelin and stuff like that. Okay. Machine learning library in Spark is scalable machine learning library that discusses both high quality algorithm and high speed. The motive behind MLlib creation is to make machine learning scalable and easy. Okay, again, the distribution parallel, it is processed parallelly compared to what we have in Python. Let's say the most dominant ML library is TensorFlow and skitlearn, right? So the same functions are used, just like how I told you about pandas data frame. the same functions are used in somewhat similar in Spark data frame. We are using some same similar kind of functions. Same thing with MLlib also. If you look at TensorFlow and Skitlan, if you have worked with that, most of the algorithms, most of the functions that you have used there is available in MLlib, Spark MLlib. Okay. Only thing is that is working on a single machine. This is working on a cluster where the processing is happening in parallel. Okay, and it is easily scalable, meaning that any of the processing or storage resources in short, you can just buy that laptop or hard disk or RAM on Amazon.com and just integrate it with your cluster. Okay, not a big problem, right? Compared to what we were doing in previously, right, in our traditional systems. Okay, and all the as just like how in TensorFlow and Skitlan, most of the algorithms are all out of box functions, right? Just meaning you don't have to know the algorithm. Like what is clustering, you don't need to know the algorithm. In TensorFlow or Skitlan, you actually have a function. You just have to call that function and clustering happens, right? Same thing, out of box algorithms are provided even in Spark MLlib. Now let's see the difference, Hadoop versus Spark. Biggest first difference is, as I told you, Hadoop only works on batch processing, whereas Spark can do real-time processing of data, right? It can directly, for example, if we are doing some tweet analysis, we can directly connect to tweet, and live tweets we can capture, we can process right then and there. As soon as someone tweeted, we can capture it, we can do some processing, and maybe we're trying to find out if this person is talking negative or positive or Modi or something like that. We can do all kind of analysis right then and there. As soon as the data arrives on Twitter, we'll get the data on our Spark cluster and we are doing some analysis over that. But such kind of facilities are not provided in Hadoop. It is all batch processing. That means the complete data set should already exist somewhere in the storage layer. It can be either in HDFS or it can be in some file system, wherever it is. But if MapReduce has to process the data, then the entire data set should be available in the storage layer. For Spark, that is not a compulsion. That doesn't mean Spark doesn't do batch processing. Spark does batch processing, okay, but it also gives you an ability to process live data. So you can process a data from CSV file in Spark. You can also process data from Twitter. But in Hadoop's MapReduce, you can only process data from CSV and other text files or database, wherever the data is already there. Complete data is there, right? So that is one difference. Next is usage. Okay, and this is already done. Third is latency, high latency in computing, because it is constantly writing the intermediate results into hard disk, right, or HDFS storage layer. Let's not go into much deeper. Let's say everything is written into the storage layer, and every time the processing is done, it has to read and write from the storage layer. So that causes high latency. That means more time for processing, right? Whereas the Spark is low latency computing because all the intermediate data, most of the data resides on the RAM itself. So RAM to CPU is less time, hard disk to CPU is more time, right? So that is the difference. Okay, data processing is done in only batch mode. Data can be processed interactively as well. Yeah, so there's one more mode, like in MapReduce, you have to write the MapReduce program and do it. That's what I told you, right? I cannot show you the MapReduce program because I don't have an example. Not good with Java and stuff. Even in Python, you can do it, but you have to do a lot of exercise. So that's the biggest disadvantage with Hadoop. You cannot do some interactive processing. That means you cannot have a shell. I mean, you cannot have a, like I showed you in Hive, right? That was a Hive interactive shell. What I showed you, where we are doing live querying and we are getting the data immediately, right? Same thing doesn't exist on Hadoop. Hadoop, everything has to be written as a .java file, and that .java file has to be put into jar file, and then that jar file you have to execute using the Hadoop submit command. Okay. Whereas in Spark also you can do it. You can create a .py file script. You can write everything. You can write all your Pyspark code in that .py file. Then we can do Spark submit, and we can execute it. But other than that, Spark also provides a way to do it interactively. I will show the example. Spark home has been start all.sh. Okay, so it is done. Let me show you. Spark Home, bin Pyspark. Okay, Pyspark. So this is the Spark interactive shell for Python. Okay, it also have interactive shell for Scala, interactive shell for R. For Java, it doesn't have, but for other three languages it has. So this is the interactive shell. So what do you mean by interactive shell? So let's say I do some Spark code, right? Sc dot nice code. I get immediate result. I can do rdd1 dot show. Sorry, collect. Okay, so I can do something like this. These are all basically my Pyspark code. I get the result immediately. I don't have to write it into a .py file and then run it using Spark Summit. Okay, this is the second option that I have. That doesn't exist in Hadoop. We don't have an interactive shell like this in Hadoop. So only batch mode is there in Hadoop. So that is one other difference between Spark and Hadoop. Ease of use, MapReduce is complex and requires handling of low-level APIs. As I told you, you have to imagine everything in a key value pair problem. We have to solve the problem using key value pairs only, right? Whereas in Spark, easier to use, data can be processed using high-level operators. There are 80 high-level operators that goes beyond the key value pair solutions, right? Scheduler, no in-memory computation, external job scheduler required. Whereas Spark does support for in-memory computation, no need for an external scheduler at all. Okay. Using Apache, Hadoop, Spark, and Hadoop. Hadoop adding value to Spark. Hadoop includes HDFS, which allows you to distribute data across nodes. So that's why I'm telling you, when you are using Spark on top of Hadoop, we get distributed distribution at two layers. One is at the storage layer provided by HDFS, and one is at the Spark layer, that is the processing layer provided by Spark, right? So that is one value that Hadoop is adding when you are using Spark on top of Hadoop. Okay, Hadoop provides enhanced data security, which is critical for production workloads. It has its own. There are around 3-4 hash algorithms and security protocols which Hadoop provides. Okay, so that is another reason why you should be using Hadoop Spark on top of Hadoop. Okay. Spark adding value to Hadoop. Spark machine learning algorithm is faster and all those things. Spark provides real-time processing. Spark provides in-memory computation. These are all the advantages. Okay. Apache Spark fits into Hadoop's open source community building on top of HDFS. Spark is not tied to two-stage MapReduce paradigm, okay, and promises performance up to 100 times faster than Hadoop's MapReduce, okay. So first thing is, as I told you, every problem shouldn't in Spark you don't need to break it down into key values, okay. That is the MapReduce paradigm. You can go beyond that, but doesn't mean you cannot use it. MapReduce is still there in Spark also, but you can use other functions that Spark provides you, and it is 100 times faster than Hadoop's MapReduce, mainly because it is in-memory computation and Hadoop is on-disk computation. Apache Spark compatibility with HDFS, HBase, Yarn. Okay, Spark is fully compatible with most of the Hadoop tools. Spark, same goes with Hadoop components such as Yarn and HBase. They're also completely compatible. Hive is completely compatible. Okay, again, runs 100 times faster. Spark can speed up jobs that run on Hadoop data processing platforms. Apache Spark provides the ability to create data analysis jobs that runs 100 times faster than those running on standard Hadoop MapReduce. Okay, MapReduce is slow because it executes jobs in batch mode, which means real-time analysis of data is not an option. Also because of the on-disk computation. Okay, main reason is because of the on-disk computation. Batch mode and interactive, that's a secondary question. Okay, not all problems require consumption of real-time data. Alternate to MapReduce, Spark is an alternate to it. It executes jobs in short bursts of micro batches that are 5 seconds or less apart. Okay, they're talking about Spark streaming. Okay, it provides more stability than real-time stream-oriented frameworks like Twitter Storm. By breaking it into micro batches, it gives more stability. I'll tell you when we are looking into Spark streaming. Okay, why micro batches are important. In Storm, it is not like that. It doesn't use micro batches for processing. It is immediate. As soon as the data comes in, it is trying to process. Okay, whereas Spark gives you near real-time processing. It can also do immediate processing also as soon as the data come, but we can create a 10-second gap, 20-second gap, so that we can have more stability while consuming the live data. The software can be used for a variety of jobs such as ongoing analysis of live data with software library, more computationally in-depth jobs involving machine learning and graph processing. Okay. Spark has, to be honest, the biggest when we look into why Pyspark is used on not Scala Spark, one of the reasons is Python has a huge collection of libraries. Okay, if you're working with Python, one biggest advantage when people are looking into Python is it has a huge collection of libraries. You have libraries that can help you write code that at a lowest level. I mean, at the assembly level. Okay, you can you can do assembly level programming using Python. Okay, you can use Python for IoT. You can use Python for AI. You can use Python for doing high level function. uh, you can use for mathematical computations. Lot of libraries are there. Okay, at the end at the end, if you want to summarize, Python has a huge collection of libraries for various different purposes. But Scala, the biggest disadvantage is that it doesn't have, outside the purview of Spark, Scala doesn't have such a good library collection that you can use it for all this stuff. Okay, so that's where it falls short. And why PySpark is again used, another thing is it is easier to develop. Python development time, let's say if you're trying to create a website, let's go with the original Python only. So you're using Django, Python framework and everything. You can create a website within 1 week, a small website, 1 week or 1 day also. But with Java or Scala, it will take around 1 month. Okay. So the delivery time is very less when you compare Python with other languages. So that is another big advantage why Python is used. So and when it comes to Spark, right? Scala Spark, the advantage that Scala had, that is faster computation, that goes away when Scala Spark is being compared with PySpark. Since both are doing processing parallelly, that compiler based and interpreter based language difference, that is basically the time, the amount of time required to run a Scala job and Python job, basically it's 1.5 times, right? Scala is faster by 1.5 times, but that thing goes away when you are using Spark, because the processing is happening across nodes, right? So it can be PySpark or it can be Scala. The processing time will be less only. Okay, so that the actual advantage that Scala had over Python or Java had over Python goes away there only. So that is the reason why PySpark is being used. I'm telling you the answer now itself. Spark supports multiple languages: Java, Scala, Python, R. Okay, it has 80 high-level operators. These are the same things, same stuff that I told you. They're same across the languages. There's no difference with the functions provided by Spark. Library support designed to add to the types of processing jobs being explored more aggressively with the latest commercially supported deployments of Hadoop. Okay, Spark tries to make sure that there is any development in Hadoop version, any new changes, that is easily integrated using new library functions or upgrading the existing library function in Spark. So that is done on a regular basis. Whenever Hadoop, there's an updation of Hadoop and some incompatibility will exist, then Spark will immediately release a version to fix it. MLlib implements a slew of common machine learning algorithms such as naive Bayesian classification or clustering. Okay, there basically all these functions are out of the box algorithm functions. Okay, you don't need to know the calculation that goes behind. Spark streaming enables high-speed processing of data ingested from multiple sources. As I told you, there are infinitely amount of data sources that Spark can directly connect with and get the data. Okay, it doesn't need any special stuff to connect it. But there are, of course, there will always be sources that you cannot directly connect. So you may need something else to do it. That also you can do. Okay, but doesn't mean that Spark is useless. It has a huge number of data sources that it can connect to by default. GraphX allows for computation of graph data. Stable API with version 1.0 Apache Spark offers a stable API. That means generally when you see, okay, yeah. One thing good about Spark is they never depreciate any old functions. Okay, if it is being used more often, even though they have brought in better API functions, API calls, better functions, they'll make sure that the previous function that was there, they don't delete it. Okay, so for example, in Spark SQL, we have where API call, a where function, we have filter function. Both do the same thing. But the reason why where came into picture was they wanted to bring in something similar to, something that database developers can understand, a language that they can understand. But filter function still exists, and people still use filter function. There's no difference as per se. Okay, there's not, if you use filter it's going to be faster, if you use where clause it's going to be slower, nothing like that. It's the reason why it came was a completely different reason. Okay, it was not to improve the performance, but to make it easier for certain developers to work with. Okay, so at that point of time they didn't depreciate the filter. So that's one advantage of Spark. They try to keep it stable. Even in the newer versions of the Spark API, make sure that there is backward compatibility as much as possible. If there are so many functions that are being regularly used, they'll never depreciate it. If the functions are not being used, yeah, of course they will depreciate. But yeah, that's what they look into, all those things. It's a very interact with the community before developing the newer versions. Okay, they always keep that in mind. Developer use it with Spark through their own applications. This helps you in using Storm more easily in Hadoop-based deployments. Spark SQL component used to access structured data allows the data to be integrated alongside unstructured data in analysis work. Spark SQL is basically structured because it is providing you database like querying, right? So that's why all the data in Spark SQL is structured. Whereas Spark also allows you to consume unstructured and semi-structured data also. Okay. Spark SQL allows SQL-like querying to be run against data stored in Apache Hive. This is one more advantage. You can directly read and write to Hive tables from Spark. Okay, that's how much integration exists between Spark and Hive. You don't need a special connector. You don't need to mention while reading or writing that I'm writing it into Hive or not. You can simply, if you have done some configuration in Spark, you can directly connect with Hive. Okay, so Spark knows that. So that much amount of integration exists. Extracting data from Hadoop while SQL query is an advantage when considering real-time querying functionality which goes around Hadoop. We'll see this in streaming. I'll show an example of streaming, how we take data from National Stock Exchange and write it into Hive, and from Hive we'll use Apache Zeppelin to do some graphs and stuff. Okay. Spark Graphics. Graphics is a library for manipulating graphs. It provides analysis for graph computation and big data. Graphics comes with a variety of graph algorithms and graph computations, and it extends the Spark RDD. Okay, basically Spark RDD, Spark Dataframe, and Spark Schema RDD and Spark D streams. These are the data structures used in Spark. Okay, if people are aware of Python, in Python we have lists, we have tuples, we have dictionaries. In Spark we have Spark RDD, we have data frames, we have schema RDD, and we have D streams. Okay, so they are the underlying data structures. Graphics extends the Spark RDD with a resilient distributed property. We'll also see how RDD is resilient. Okay, again module 4. All of these are important topics. Okay. Applications using Apache Spark in healthcare, people use it for transactional database, capturing all the medicine information, medical databases, pharmacy databases, all the stuff. As I told you, people are moving away from data warehousing in databases. They're trying to bring everything into big data cluster, right? So if you add a MySQL database for pharmacy, that is being imported into big data clusters. Okay? And Hive is used for processing. In traditional sense, they may be using Python on a single machine, so that may be slower. So when they bring it into the Spark cluster, the data may be in Hive and processing is being done using Pyspark or some Scala Spark or something. So data processing is parallel, data storage is again parallel. So that is an advantage. So transactional databases, demograph data, capturing which like now in people here are buying more Pfizer vaccines, or people in the state are taking Moderna vaccine, and all those kind of data, demographic data, right, is being captured again, being processed. Everything is happening on the big data cluster. Okay, the same. See, all these examples are from traditional source systems. Earlier, they were all single systems. They are being done on a single system. Now they are bringing it in big data systems. Okay, so it's not something new. You would have already seen it. Only thing, the underlying technology is different. Earlier, this may be You may be using Python and MySQL. Now you are using Pyspark and Hive. Okay, so that is the actual difference. Otherwise, domain perspective, they're all same. It's not like something they have been doing recently. They're doing it from past itself, but they had some solutions that were not feasible. For example, transactional database, it's been there since the beginning. Since the 1990s, people are having transactional database in every domain, not just in healthcare. Be it manufacturing, be it banking, everywhere there is transactional databases. Okay, and that is there since the beginning. But there are some new type of stuff that comes in with big data, right? Like ingestion of live data and doing analytics on top of that. So those kind of things were not there in traditional systems, right? So those capabilities were add-ons. But other stuff, it's already existing there in the for a long time. Only thing is now it has become costlier to maintain the system. So that is why they have to move into a system that is cheaper, easier to process, easier to store. Okay, so that's why they are moving into Spark and Hadoop cluster. Research data, purchase data, fitness tracker. Yeah, fitness tracker is something real-time data, right? So this is something you the big data tools give you as an add-on, and all other stuff is nothing but it's already existing, but it's not feasible anymore. So these are the two reasons why people are moving into big data clusters. Manufacturing, testing, and simulation of, okay, what is the common destination used in Spark, Hive with OSI Park, Excel in real-time projects? What is the common destination used in Spark, Hive with ORC Park, or Excel in real-time projects? I would say Hive. The reason is, once you store the data in Hive, there are other UI tools that you can use. For example, you can use Kibana that directly connects with the Hive and gives you the dashboard, right? ELK, in the ELK stack, Kibana is the dashboard, and Elastic, this is the database, and Logstash is the data pipeline, right? But Kibana can also directly connect with Hive and do it. Other than that, we also have tools like Zeppelin, Tableau, Microsoft Power BI, MicroStrategy. All these things are very compatible with Hive, so they would rather have Hive in the backend rather than Excel sheets. Okay, and it's not easy to track also. In Excel, you cannot have today's data, tomorrow's data, and 100 days data in the same place, right? It looks, I mean, it is difficult for you to, first thing we have to combine all of them. Let's say I want to look into like a database, I want to query it, then you have to combine all the Excels and work with it, right? Hive works on MapReduce. Yes, Hive works on MapReduce. That's what is running on the backend. I showed you, right? Any query that you use in the backend, MapReduce is running. Okay. In manufacturing, to test and simulate of new manufacturing process, customize production requirements, defect tracking, supply chain analysis. So this is what I gave you example last time. People are able to tell you, okay, if Bangalore is consuming too much of Kellogg's Chocos, then the company knows because they are doing live tracking. Okay, and another kind of supply chain analysis is how fast our trucks are reaching the destination. So they have all this monitoring on the delivery pipelines. Okay, IoT devices are being used, and IoT devices are constantly sending the data to Spark cluster, where in which it is doing real-time analysis, right? So if it is yesterday it took 5 hours from Bangalore to Mysore. Today the truck took 3 hours. Okay, then again there may be parallelly they may be doing another some sort of analysis. Why? What is the difference? They may be querying the Google Maps to find out. Okay, on these and these dates, generally there is traffic in Bangalore for some reason. I mean, it may be because there is Ganesha festival or too many people are working that day, something like that. So at that they are doing some kind of analysis like that. Okay, so if you're going to travel from Bangalore to Mysore, if you're going to send chocos from our Bangalore facility to Mysore, the best day would be using either Monday or Thursday because the traffic is generally less. Looking at the historical data and trying to find a pattern, these days are the best days to send it. So that kind of analysis also done in supply chain, and the kind of that's what they also have IoT devices in markets. In your More or Big Bazaar, if you go, there may be some sort of IoT devices that is capturing, okay, these kind of people looking at this particular what do you say. So there are this separate sections for food, separate section for clothes, right? So there is this company called as Aruba Networks. So what they do is they have IoT devices. Basically, this was done for US market, not in India. So Target stores in US had those IoT devices that was reading the data of your mobile systems, right? So based on that, they would come to conclusion, okay, this guy stayed at the bookstore for 10 minutes and he didn't buy anything. Okay, but he has been coming here for almost a week. So what they may do immediately, they may send a code to his mobile phone. They would have captured the mobile information. They would send it to him, saying that if you buy something in the bookstore, we'll give you 10% data, right? So all that kind of analytics, ad campaigns, everything is done in supply chain analysis. A lot of IoT is being used. Okay. Then comes media, where we are doing publishing, then learning, conversions, distribution. Okay, for distribution channel, we are doing some analytics. Okay, sales and purchase behavior. We are trying to analyze. I was talking about the Nike, right? So customer analysis, they are tapping into real-time sources and trying to find out which geography has a negative attitude towards their product, right? So based on that, they're taking some business decisions. So all those stuff exists in media. Okay, publishing, ads and organic contents. So if you see, again, Aruba networks that I'm talking about, they also have something called as RTBs. They're maintaining real-time brokers. So what they do, they would have installed cookie in your machine, in your browser. So every time you search for something, right, let's say you're searching laptop, right, so it captures that information and immediately it goes to the RTB is nothing but a Spark cluster. So they have certain ads that have the same keys of what you're looking for, right? So next time you open Facebook or some other website that allows ads, you will see that particular laptop ads being there. So that's what I was talking about. In my Google, in my Android phone, it reads everything. So when I'm looking for articles on Spark and stuff, it gave me that article. So it came to conclusion, okay, this guy reads a lot about Spark and Hadoop. So that's why when I open my Google apps, the kind of news are similar to what I've been searching for a long time. So that's how I found out about that Apache thing, right?
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So all those things are nothing but as analysis on your current user behavior and appropriately sending the ads. Behavior, basically it is both, combination of both, learning the behavior of the user and accordingly advertising your products. Okay. Internet of Things, as I told you, IoT has a big market, and they are in the back end of an IoT system is always a big data system. Okay, very rarely do I see a single machine system which is taking in IoT data, but generally it is basically big data only, because IoT is generating hundreds and hundreds, maybe at a second it may be generating 10 kb, but it is generating data 24/7 365 days, right? So that 10 kb will become 1 TB by the end of the day, right? So that is the reason why in the back end processing and storage is again done by big data only. Okay, front end there will be some IoT devices. Okay, maybe sensor. Sensor is the IoT devices, and it is capturing the sensor data. Then it is sending into the big data cluster for processing and storing the data. Government uses for all its requirement. If you see, IRCTC is built on top of a Hadoop cluster. Okay, as I told you, the data earlier it was taking a lot of time because the traditional system were not applicable. Okay, the traditional data warehouse that they were using became too big, so they I think the partners are Tata only. TCS is a service provider for IRCTC, if I'm not wrong. They are the guys who are making the Hadoop cluster. So earlier they did an early adoption. Okay, as soon as I'm talking about 2006 or 2008, the cluster was up and running in production in 2008 or something, because when I was learning in 2014 I started working with Hadoop. I started learning, so that's what my trainer told me. It was in 2008 Hadoop came into picture. I think it was 2012 or 2013. Okay, and I think now they're moving into Spark also for processing. They're moved away from MapReduce, they're using Spark there. So there are a lot of places where government can use cybersecurity, okay, to find out whether the incoming packet is from a dubious source, or the TCP connection from this guy is again dubious or something like that. All those IDS stuff, intrusion detection system, you can build on top of big data cluster. Weather forecasting, again, the data is always huge, even though real time, but the data is always huge because every second you are consuming the data, right? Traffic optimization, again, IoT devices you can use in front end, and in back end you can use big data for doing real time traffic analysis and all those stuff. Scientific research, there are a lot of domains where big data is necessary, right? Big data and AI.
What is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C#, or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. It's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century. And basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well, guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this. And Python is open source, if you've been wondering. So Python has been used by the community, developed by the community, and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks, and they make use of IPython to basically share and store all of the data with respect to the driver-client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, the first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. We've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. There are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much probably equivalent to putting out an output which gives out hello world. You can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python, and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, basically Apple's operating system, and you can use any of your favorite operating systems. In fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the #1 language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know. And of course, coming to artificial intelligence. Well, ladies and gentlemen, I know you guys might be waiting for this at this point of time. Hey, what about data science? What about artificial intelligence and much more? Well, here it is. You must learn Python today because Python is one of the most preferred language in today's world to help achieve artificial intelligence. So where is artificial intelligence implemented? Well, look around you, look at your smartphone, everything from Siri, Alexa, all the way to Google Maps, Amazon. I can go on naming thousands of applications of artificial intelligence which has been so subtly integrated into your life. You have to even understand and contemplate to see if something's AI or not anymore. That's how well it's all been implemented. So on that note, there is a 44% enhancement when you put artificial intelligence and help with the current products which are already existing. And AI will of course optimize all of the internal operations in an organization by up to 42%. AI will help make better decisions, and of course AI will help pretty much optimize all of the external operations which take place. And this is a very important point because you can see a 31% increase there. And of course workers will be free enough to make sure that they spend their time, their efficiency, and much more to actually be creative instead of doing some redundant tasks. Well, now where does Python come in? Well, you need to understand that Python gives you a very efficient way to work with data. And when you're working with artificial intelligence, it is of course in no doubt that you'll be working with a lot of data. To ensure that you can handle all of this data with ease, Python has got us covered. And then let's talk about the library ecosystem of Python. Python has an extensively huge library system, and pretty much we're going to discuss about the libraries as well. But then at this point of time, you need to understand that all these libraries which are pretty much given to the developers, the frameworks or whatever it is, all of this is helping us get closer to making artificial intelligence more intelligent, if you know what I mean. And of course, it gives us beautiful visualization tools. And compared to any other programming language, there are languages like R as well, of course, which are on the boom right now. Python is again another standard when it comes to using visualization tools. And again, this in my opinion forms a very important reason for you guys to jump on this, because as a learner, as a developer, as a person solving a problem in your company, you will require an efficient way to process the data, you will require a large ecosystem, you will require very good visualization tools, and at the end of it, there is something even more important, is community support. Since Python is an open source language, it is the number one programming language. Again, thousands of people pretty much start out with Python and learn Python on a daily basis, help each other solve the problems as well. In fact, we have the Intellipaat community where we actually cover Python as well. We cover all of the IT related concepts in depth in the community section, where we have people from across the world coming in to help each other's problems out. So make sure you check out Intellipaat's community after the session, ladies and gentlemen. And coming to the next point, Python has another strong footing in today's world. As you can see from the title, it is web development. Python provides us with so many nice frameworks to work with. Everything from Django, we have Flasks, we have Pylons, and we have Web2Py. Basically, all of these are tools to ensure that Python as a programming language can help in web development. The introduction I gave you to Python said Python is used for web development and app development. Well, you can see all of the beautiful libraries that Python provides us for web development on your screen right now. Django is amazing to work with. Flask, again, if learned, you can create very beautiful applications using that. Pylons, of course, and at the end of the day, even Web2Py as well. Well, at this point of time, my goal is not to overwhelm you guys telling you all about what Python is and what Python is offering us. Well, I'm trying to tell you the potential of Python, ladies and gentlemen, and I know that it is amazing as well. Coming to big data, of course, the entire world is a big data problem. Look around you. There is terabytes worth of data being generated every single second. We upload a picture to Facebook, we upload a picture to Instagram, we might sing and put something out on SoundCloud or whatever it is. You're putting in a lot of data out there on the internet, and it's just not you, it's the entire world population, a majority of the population who make use of all of these apps. So when you're looking at that, pretty much there is a lot of data being generated. And how does Python help? Well, as I mentioned, Python is amazingly easy to work with. It is all because of the libraries and all the support it gets. See, for example, from Apache Foundation, we have Apache Spark, and we have tools such as Dask and PyDo, which basically help in giving Python the access to basically go on to make use of parallel computing. With parallel computing, you can solve big data problems by breaking down a problem into simple sub pieces, assign it across multiple computers, and have these multiple machines, multiple nodes as we call it, solve the problem for you, and do it in such a way that there is no strain on one single machine doing it, of course. And that's not the only reason. If you're dividing the load among hundreds of computers across a server, 1,000 computers for example, you have that much of power, 1,000 times of power, 100 times of power, whatever it is, to give it to you in the most simple terms, ladies and gentlemen.
Just a quick info, guys. Intellipaat provides Pyspark online training mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session.
So handling big data with Python is a breeze, and companies are looking out for all of these, and they want you as a big data expert there. So if you want to become a big data expert, you need to understand all of these concepts. And to understand all of these concepts, you need to first set across a programming language through which you're going to work and use all of these frameworks that come with it and go on to make use of it, right? So basically, that is exactly what I'm trying to tell you guys here. When you hone in on a particular language such as Python, you have all of these beautiful frameworks to work with at the same time. Then coming to data science, of course, I've put in a fire emoji out there to tell you that data science has been on fire all of 21st century. Data science is pretty much booming right now. And in fact, guys, if you do not know, data science is being actively used right now to fight the outbreak of the coronavirus, which is spread across the world. And we have an entirely in-depth session covering basically on how machine learning and other technologies can actually be used to help fight the coronavirus, or COVID-19 as it's called as well. So make sure you check it out after this session. And of course, coming to why you should learn Python in terms of the data science aspect, well, again, it provides amazing libraries to work with here as well. For numerical computation, we have these two beautiful libraries. It's Pandas and NumPy. Both help in amazing numerical computation. And when you're working with a lot of numbers, when you're working with data frames, data sets, whatever it is, these will ensure that the same level of readability is met, and that of course you can efficiently handle all the data with ease. And then coming to data visualization, ladies and gentlemen, we have Seaborn and Matplotlib. These two are very famous tools which are basically used to perform data visualization when we're talking about data science, when you're talking about Python, and when we're talking about solving most of the data cases of today as well. Well, as I mentioned it before, let me strengthen it again. Python is the number one programming language out there as of now for data science. And if you are capable of handling numerical computation, and if you can understand and produce very good data visualization methodologies, of course you are preferred by all of the top hiring companies out there.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video. But note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code, and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console. But here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. I press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter, and if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it B plus C. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen, and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took B and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSDA and CSS, and as you can see that it added it to the it added those two strings together. Now, if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called A, B, C, D, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value, or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age and equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now, if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there. So you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far. And we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is A equals to B equals to C equals to 10. That means set all the variables on the left hand side, which is A, B and C to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals C equals 15, and if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, A comma B comma C. Now I want 10 assigned to A, comma 15 assigned to B, and 20 assigned to C. I press enter. A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B, and C, if I were to use B, C, and A, then B will be assigned 10, C will be assigned 15, and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable.
Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is we'll take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assign the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter, and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I type this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is, if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand, so let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and 1. So when you hear something like integers can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have, this will be 0 since all the 4 numbers are 0. Now what we're doing is, I want to check, if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is, if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If, let's say, this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is we take a look at it and we go 2 raised to the power of 4 and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3 and the number at the third digit position is 1. Then 2 raised to the power of 2 and the number should be 0 and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3, this should be 2, should be 1, this should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1. So we multiply it here by 1. Then at the first position is 0, second position it's 1, and the third position is 0. So what ends up happening is we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0 plus 2 to the power of 2 which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1 which is 2 multiplied by 0 and we go 2 to the power of 0 which is 1 multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1 and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now, because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators. So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I've given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1 we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator, does. It takes the binary format and shifts it by 2. Now on the other hand, we also have right shift operators, and it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed, and add two zeros at the begin, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right, and at the very end, let me show you what the not operator does, because this is very something that's not shown very accurately. Not operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the not operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, you see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4 and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discuss are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code, and we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others, and these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type RET is equals to 7, this works just fine. But if I were to type return RETURN, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So that a variable which is named var with V capitalized and a variable named var with every characters in lowercase, these are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. In when Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, it's 72. So if I were to print var with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 var equals to 7. We'll get a syntax error. But if I were to do it v1ar, this is just fine. It will work. v1ar and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path. Press enter and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now the way it worked in Java and C was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that, you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing, like the null pointer and all, but you don't need to worry about that. Just need to understand why there's two quotes and why there's one quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use three single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with three quotes. I press enter. As you can see, the prompt, instead of it being three arrows pointing left, it's now become three dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type three single quotations.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session.
Press enter. I get back the prompt with three arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line. As you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now if you've worked with mathematics, if you've worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers. So we can store that in integer as well. Let's say that I want to store negative 77. I can store it in number, or positive 77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a new version. So never mind. So if that was the case, then I could do that, but it's not. Yeah. So as you can see, it's working fine. Now, if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now, there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're using the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python, you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I am building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a Boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was ABCD1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say BOL equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter TRUE will not work since Python is case sensitive. So if I were to type BOL, that's true. And I can also assign false to it. Press enter and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us. So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers, and tuples will have some value assigned to them. And then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable, we have lists, dictionaries, sets, and in lists, we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this. And if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets. So now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0 After that, I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now, another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the fifth character or this the sixth character in this, which is on the fifth index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the fifth character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the removing the last one character. If I were to remove the last two characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f with g. I press enter, it returns another string to me, which is a, b, c, d, e, g, g, h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O or U and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary but I would do that here. Now let me just type in Sunday, and you could type it with me: Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, TYPE, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to add something to the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned somewhere, some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousand. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26. and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when it's trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple, 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple to see if it's a tuple or not. And it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add 2 curly braces. Inside it, add the key, which would be the person's name, let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter. And now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good. But one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. I press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this: store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you know you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0, and I want the person with the employee ID of 0 to have salary or something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets. Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple, and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? Set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in S, and it will show you true. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this, and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set all the 1 million things and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do one in S as well. If I were to assign a list of 1 comma 2 to it, and then instead of 1 in S I can type 1 in L, and that will return true as well. The difference here is that it takes a look at all the elements 1, 2 and whatever, and finds if something exists in it or not. Whereas in set it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection and all that, and that's very easy to do with sets as well.
Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window. And here type in VS Code. Press enter and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open with this code folder. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension. Press enter. Now, just to make it clear, you don't have to use VS Code. If you don't want to, you can use Notepad for this as well. Just go to the folder, create a file named app.py and right and click on edit. It will open it in Notepad and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this and let me just make some changes. I'll increase the font size so that you can see a little better. So it's a loading some extensions, and while it's doing that, open the command prompt. To do that, just go on to the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. Here you can do it this way. Now if I open this, as you can see, I can type in a lot of things. So let me just increase the font size. I think it's now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again, I press enter and it's there. Let me just increase the font size here as well so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I printed it's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num0, and then I keep going on like print num1, num2, num3, so print all the 4 numbers. What I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, As you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understand what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parenthesis, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they're immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter and pop is also not available. But you can print them, you can loop over them just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this DICTIONA dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys. These are the values. So Jane earns 15. John earns 20. So we type it. We print in the keys. Now if you don't want to print the keys, let's say we want to print the values. I do that. Now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value guide, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now, if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print S, it's 1, 2, 3. So this works fine. But if I were to loop over it for X in S, let me just print X. As you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in S, I'll get true. And if I were to print 4 in S, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. The next topic is encapsulation in Python. Let's take a look at that. Encapsulation is basically abstraction plus data hiding. Abstraction is showing essential features and hiding non-essential features to the user. So depending on how your application is set up, let's say that you have an application that manages the payroll of a company. Now, since it's managing the payroll of a company, the user does not need to know what kind of database it uses, what kind of file system it's using, what kind of language or what kind of drivers it's using in the background. That's all things that you have to do. So you can abstract those details out of the program and just focus on the UI and all that. So that's what abstraction means, just showing the essential features and hiding the non-essential features for you to deal with. So this is what it means. So while we're writing an email, you don't know how these things are actually happening in the backend. This is one example of abstraction as well. So when you're writing an email on Gmail, when you send the email, you don't know how the things are being put into an HTTP request, how they're being transferred from other email servers, and how the email reaches to the person. So encapsulation deals on the concept of public and private. So public basically means a function that anybody could access. So far we have created only public functions. Private functions are functions that other people are not supposed to access. You can access them under very strict and rigorous circumstances, but it's generally discouraged. So if you want to access something, then you can use update software. Then you can use a syntax that we're showing down below. So let's say that we have a class named car. It has an init method, and in that we have an update software method. It's a private method. The way we know it's a private method is that it's been preceded by 2 underscores. So whenever we start a function name with 2 underscores, that means that it's a private method. So we create an update software method, we create a drive method, and then we call the update software method. I create an object called red car. I call the drive method since it's public. But if I want to call the private method, this is how I do it. So I call underscore the class name and then 2 underscores and the function name. Now again, this is not something that you should do. It's generally discouraged to call private methods on your own. So if possible, don't do it on your own. But if you have to, then this is one way you can do it. So you can change the value of a private variable using a setter method as well. So let's say that I have a private variable called max speed. Let's say I'm creating a car game. In that there's a max speed function. So instead of me having to reach into the function and then exposing the max speed variable, what you can do is you can call a max speed function, set max speed function, and pass in the maximum speed that you want to. So using the red car dot underscore underscore max speed will not change the private variable because it's private, but you can use a setter method to do that for you. Now let's take a look at a hands-on to understand how that works. So let's say that I have a function called let's say I have a class called some class, and here I have a function. Let's call it public. I'll print public function. And now I can create a private function. Always remember, underscore underscore means private. Private. This takes in no functions. So I will just print private function. Now I think I'm getting some error, mainly because this is supposed to be a class and they need to accept a self parameter. And now if I were to create an object, and now if I were to call the obj dot public, this would work. So it's calling the public function. But now if I were to call the private function underscore some class underscore underscore private, it's calling the private function for me. So that's how this works. Now let me tell you how to deal with the private variables. So let's say that I have a self dot underscore underscore private equals to instead of it being private, let me call it balance and set the balance to be 0. So let's say that I'm creating it for some account. Now I want balance to be private, mainly because, let me call it INIT. The reason why balance is private, because there can be certain rules that a bank has depending on how the things are set up. We might have multiple rules. So it could be that a balance can never be equal to 0, or it could be that a bank has that whenever you open an account, a balance should be minimum of 10. So we can set it here. Now also when we're setting the balance, there could be multiple procedures that we need to follow, that we need to log the old balance, then update the new balance, and then log that as well. So these are the kind of things that we'll take a look at in the set balance function. We take self, we take balance, and what we'll do is self dot b underscore underscore balance equals to, all right. So I need to put a comma here. All right. So now instead of this, I can create account, and I can also create a get balance function. So def get balance self, and what it will do is it will return self dot underscore underscore balance. So now all I have to do is print obj dot get balance. I'll print it again, and before that I will change the balance, set balance to be 20. Now if I were to run this, what do you think will be the output? Let me just, so okay, I'm getting none here. Okay, obj is an account. I call the init method def self dot balance is being set to 10, and then I'm passing in the balance, or I could also do it this way, self dot set balance to be 10. Still getting none. So we have self dot balance, we have self dot set balance, we have an account, and we are using the obj. Let me just print it here. Okay, so we're getting the balance, but we're not able to return it, mainly because it's a private thing. So that's why we're not able to return the function. So make sure that you are understanding that. So you can't return a private value, but you can use it underneath. So as you can see, now I have 10 and 20. Let me just remove this. And if I were to print get balance, instead of we're printing 20, but if I pass it here, save this and run it again, as you can see, the current balance is 20, 10, and then it gets printed to 20. So that's how that works. Hopefully it's clear to you, and let's move on to the next topic.
So let's move ahead and let me tell you about some of its advantages. This will help you to know more about why you should use Pyspark. So like we can see here, we have speed, powerful caching, real-time computation, deployment, and polyglot. So on number one, we have speed. So when you compare it with the traditional large-scale data processing, it's definitely 100x faster than them. Alright. In terms of powerful caching, well, Pyspark will give you a powerful caching with disk persistence capabilities. On third, we have real-time computation. Well, there's a plethora of data which need to be processed in real time. Let me tell you a fact. You know what? Every minute, around 48 hours of video is being uploaded on YouTube. Twitter gets around 98,000 of tweets and more than 168 millions of emails are sent every single minute. Well, these data comes in bits and pieces from many different sources. It can come in various forms like words, images, numbers, and so on. So Twitter is a very good example of words being generated in real time. We also have websites where statistics like number of visitors, page views, and so on are being generated in real time. There's so much data and they're not useful in their raw form. We have to process it and extract insight from it so that it becomes more useful to us, right? So this is where Spark Streaming comes into picture. It is exceptionally good at processing real-time data and is highly scalable. It can process enormous amount of data in real time without skipping a beat. Alright. Next feature we can see over here is deployment. Well, you can deploy PySpark through Mesos, Hadoop, or even through Spark's own cluster. Alright. Next we have is polyglot. Well, simply it means that it supports multiple languages like R, Python, Java, and Scala. It basically provides the shell and Scala and Python, which you can access through the bin folder of both Scala as well as the Python. Alright. A question might arise in your mind, like under which situation should I use Python? Or under what scenario should I go with Scala or Java or R? Alright. So let me tell you a fact. The most used programming language with Spark are Python and Scala. Alright. So now if you are going to learn PySpark in this tutorial, it is important that you should know why and when to use Spark with Python instead of Spark with Scala. So let me just compare Python and Spark with some parameters. This will make things clear for you to decide. So our first parameter is performance speed. Python is comparatively slower than Scala when used with Spark. But programmers can do much more with Python than Scala because of its easy interface that it provides. On the other hand, Spark is written in Scala, so it integrates very well with Scala, making it faster than Python. Alright? So next we have is the learning curve. Python is known for its easy syntax and being a high-level language, it makes it easier to learn. Whereas Scala has an arcane syntax which makes it hard to learn, but once you get a hold of it, you'll see that it has its own benefit. Alright, next is the data science library. Python supports multi-data science and machine learning libraries. But on the other hand, Scala lacks proper data science library and tool. Scala does not have proper local tools and visualizations. Alright. Finally, the last parameter is complexity. So Python API has a simple yet easy and comprehensive interface. Whereas on the other hand, Scala's syntax and the fact that it produces the verbose output is why it is considered a complex language. I hope the things are getting clear to you. So before we dive deeper into the Pyspark concept, let me tell you about how big tech giants like Yahoo, TripAdvisor, Alibaba, and other big multinationals are using Pyspark for them. Well, Yahoo uses Apache Spark for its machine learning capabilities to personalize its news and web pages and also for targeting advertisement. And also for target advertising. They use Spark with Python to find out what kind of news user are interested in reading and categorizing the news story to find out what kind of user would be interested in reading each category of news. Next is the TripAdvisor. Well, TripAdvisor uses Apache Spark to provide advice to millions of travelers by comparing hundreds of websites to find the best hotel price for its customer. The time taken to read and process the reviews of the hotel in a readable format is done with the help of Apache Spark. Alright, let's discuss about Alibaba. Well, Alibaba, I guess most of you have heard about it, right? It is one of the world's largest e-commerce platform and runs some of the largest Apache Spark jobs in the world in order to analyze hundreds of petabytes of data on its e-commerce platform. Alright, so I guess now you have an idea that how Pyspark is being used in the industry, right? So guys, if you're a mobile viewer, get ready with your laptop because now we'll proceed with the installation part. So let's install Pyspark in your system. Just to keep it real, just in case you are stuck, you'll find many installation reference out there on the internet, which you can just go ahead and refer to and get installed. So guys, in this tutorial, I'll be teaching you how you can install Pyspark on your Windows machine. Alright, if you're a Linux user, add your email ID below and I'll send you the installation step for it. You can just follow it and install it on your machine. Fine. Well, before we actually proceed with the installation part, there are some prerequisites required for Pyspark installation that you must know. So as a part of prerequisite, you must have the Jupyter Notebook installed on your machine and you must have an updated version of Java. Alright, so let's just open google.com and just search for download Pyspark. Well, I'm assuming that you guys have installed the prerequisite for this session. So proceeding ahead, let's download the Spark. Just Google it, download Spark. The very first link which you'll get is the Apache Spark link. Just click over there and it will redirect you to the Spark Apache website. As you can see over here, the Spark release is 2.4 of November. It's very recent. And the package type which I'm selecting is pre-built for Apache Hadoop 2.7 and later. You have other options available over here. So I'm selecting pre-built for Apache Hadoop 2.7 and later. And finally what I'll do, I'll just click over the download link over here. It will redirect me to a different page where I can see over here it's a mirrored link for me. I'll just click it and my download will start. So yeah, it's a pretty big file. Just make sure that you have a very good internet connection if you are downloading it. For now, I'll cancel this as I've already downloaded this file. So let's cancel it. Let me just show you where I have downloaded it. Under downloads, I have this file. Spark 2.4 Ben Hadoop 2.7. Alright, just unzip it, extract files. I'll extract. Just extract the files. The files I extracted, I'll just save it somewhere. Like, let's save it in the D. Okay. By the time it does save it, just open your CMD. So our next step would be to edit our environment variable. So let's create some environment variable using the setx command. My first variable is spark underscore home. And after that, I'll specify the path of my Spark file. So this is the path. Let's paste it. Done. Okay. Next, I need another environment variable as Hadoop underscore home. Then again, specify the path of the file. Hit enter. Done. Now, since I want to launch my Pyspark shell in Jupyter Notebook, so I need to define two more parameters over here. Pyspark driver Python and Pyspark driver Python OPTS. Alright, this will help me to open the Pyspark shell in Jupyter Notebook.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I'll write setx Pyspark underscore driver underscore Python and IPython. Hit enter. Done. And my next parameter is setx Pyspark underscore driver underscore Python underscore OPTS and notebook. Hit enter. Start. Alright, let's close this terminal. Now let's open a new command line prompt. Now my first task would be to redirect to this bin folder. Alright, so this is the path. Let's copy it. Jump to the D directory. CD space. I want to go over till bin. So yeah, so this is my path. Hit enter. I'm in bin. Now my next step would be to execute Pyspark with the command Pyspark. I'll use a master parameter for setting the master node. And since I want 2 cores for local testing, so I'll specify master local. How many cores? I need 2 and hit enter. So what it will do, it will open me a Jupyter notebook on my local host. So yes, we have successfully installed Pyspark on our machine. So for now, just click on new, select Python 3 and it will open a tab where you can write your Pyspark code. Alright, so this is the Jupyter notebook with Python 3 where I'll be writing my Pyspark codes. Alright.
So without further ado, let's quickly check out Spark architecture, guys. So I pretty much have a very simple diagram here to denote what happens. So we have something called as the driver program in Spark. So driver program is the link between you as a programmer and Spark's program. So all the data that you input, all the data that you need manipulated, and to go about working with it, you need Spark to understand your data, right? So again, our driver program, which consists of this concept called as Spark context, is pretty much used for this. So again, thinking about drivers, right? So think about it, recall if you're familiar. So if you have a brand new hardware where you need that hardware to talk to your machine, you need the hardware to talk to a software, and at the end of the day you need to use that. So basically you'll be using a driver there as well, right? So again, the concept is again pretty similar and simple out here, guys. So coming to Spark context pretty much forms the main entry point for any functionality in which you'd go about doing in Spark. So basically at the end of the day, our Spark context is used to create what we call RDDs. Again, I'll walk you through it. To create accumulators, we used to broadcast a couple of variables and all of that. But one thing that at this point of time in the introduction that I would like to tell you guys is, again, you need to know that for every single instance of Spark running, a Spark core running, you need to have only one Spark context. So if you have more than one, again, you cannot run it side by side and you will get a error, guys. So one Spark context for every single program and you'll be good to go. So again, all of the data that you've inputted pretty much goes into our cluster manager, where we have a couple of management tools that we looked at in the previous slide, where again, this depends on you. If you're pulling your data from the cloud, you're pulling it from a couple of different nodes, or you're pulling it from one standalone node and all of that, right? So the cluster management, I think, forms a very vital part. Because think about it, right? So if you're forcing someone to always use offline data, or say use data only from a machine, then it really doesn't make sense. But then if you give them freedom to pull the data from the cloud, pull the data from another node, pull it from another cluster, cluster is basically the group of nodes and data. So when you give them this amount of freedom, then it would really help scalability, help a lot of users, a lot of developers at the end of the day, right? So cluster management is again customized for your requirement, where you pull out the data based on your needs and all of that. And next we have the worker nodes, guys. So worker nodes are, at the end of the day, it's the endpoints of our Spark architecture, where the data gets converted into information, where we getting the task done. As you can see on your screen, we have something called as the executor, right? So that is what it literally means. So worker nodes again are your endpoints of the system, where you will go about working with it. You will go about you'll be asking your worker nodes to pretty much use the algorithms, learn something, and tell you give you a valid output. So all of that part goes about in the worker nodes, guys. So again, at the end of the day, worker nodes needs to have it needs to be in touch with Spark context for various reasons. Don't worry, I'll be walking you through that in a couple of slides. But that's why you see the big arrows up and down, where it keeps talking to each of the nodes. So it is important that you talk to every single node that you're actively making use of, right? So if you're making use of 10 nodes, but then you're only telling your program that you'll be pulling data from one single node, you know that there are 10, but your program is seeing only one. That really wouldn't make sense. So to make your program, to convince your program to see 10 outputs, and to see 10 inputs, that forms a vital part. So again, as we already Spark provides a very well defined layer architecture, which makes it really easy for a beginner to learn. And all of these components and all of the layers are loosely coupled, guys. So again, as I've mentioned about the freedom of going about manipulating for your requirements, you are not asked to learn in a very tightly bound environment, where you cannot wiggle around or do something of your own. And I think this makes Spark a little easy. So again, driver program runs on pretty much the master node, what we call of the Spark cluster, which is again the master slave organization, where you need to know at this point that whatever driver program we have, again, it runs pretty much on the master node of the Spark cluster. And so it is basically, it schedules all job execution and negotiates, as I've already mentioned, with the cluster manager. And we'll be using it to translate RDDs into execution graphs as well. So think of RDDs as a simple array at this point of time, and a lot of data, a lot of numbers usually, and all of that. So our the entire architecture here, it makes it easier to pretty much translate this entire RDDs and numbers into graphs, guys. So the driver program, again, it can pretty much split up graphs as well into, it can split up the graphs into a couple of stages as well. So this will simplify your use case when you're going about coding and, working on a very big project, guys. So again, as I've mentioned, the role of the executor is pretty much to take care of all the execution of the tasks that you provide. And every application has to have its own executor, because again, it is not native to what you're doing, and pretty much most of the tasks are different from each other, right? So again, the executor, as I've mentioned, also performs all of the data processing that it needs. It can read data, write data, it can push the data to external sources, it can pull in data from external sources as well. And you can see the small arrows on your left where it talks to the cluster manager as well. So it interacts with a variety of storage systems, and this again makes it easier to go about, guys. So with cluster manager, again, it is the service which is pretty much responsible to gather everything from your driver program, to gather all the data that's required for the executors to work about. And then you can have the standalone cluster manager as well. So pretty much it is one single entity, and you will go about using the standalone cluster manager for your learning journey, because I don't think you would it would be valid to bombard you with a couple of multi-node networks and to go about that way, right? So cluster manager, again, as we already walked you through, it basically depends on what you're doing. So it can be a very simple Spark application, and it can lead all the way to something really fancy, right? So so next up, we'll be checking out Spark deployment modes, guys. There's a variety of Spark deployment modes that we have already talked about. The first most important thing you need to know is that Spark works in standalone mode, right? So we can go about launching the Spark cluster. You do not need any third party cluster manager to work with Spark. Spark is again, I mean, this cluster is basically again used to deploy Spark applications as well. And next we have Mesos. Mesos, again, the most important thing that Mesos can do for Spark is it usually replaces our cluster manager in Spark, the native cluster manager, and it goes about providing a private cluster of data for you, and then it provides a lot of tools as well. Next up, you can have Spark on Yarn, so you can pretty much deploy it on top of Yarn, and usually Spark with Hadoop can enhance Spark's capability by a lot. So it's like this extra masala we put on a dish, right? So put that kind of analogy in your head. So Spark with Hadoop is it plays a major role in upping Spark's game, guys. So that's what I wanted to convey. And we have Amazon EC2 as well. So Amazon has been providing us with a lot of good cloud services these days, and I'm sure you guys already know what Amazon EC2 is, right? In case you do not know, well, basically Amazon EC2, it stands for Elastic Cloud Computing, and so basically, we know what it stands for. So it is a web service that provides, secure, resizable computing capacity, and it does this. I mean, it is not at the end of the day, it is on cloud, right? So it is meant for scalability, and that is how EC2 works. And to push your entire application to cloud is something really nice, guys. I mean, I've personally worked on a couple of projects in with EC2 where I've moved a couple of stuff there, and it makes your life a lot easier. Cloud at the end of the day, right? So then we have Kubernetes, guys. Kubernetes, again, it is an open source chain. So basically, Kubernetes was founded by Google. It was invented by the developers at Google, but right now it's being maintained by a separate firm. The firm is called Cloud Native Computing Foundation, and sure, Kubernetes is fun to work with as well. So what I want to convey with this slide is that, in terms of Spark and its deployment, you can go about working with it standalone, with Mesos, with Yarn, with EC2, and with Kubernetes as well. So quickly jumping on to the next concept, which is Spark Shell. So guys, Spark Shell pretty much is a very, it provides the most simple way to go about learning what Spark actually is. But do not be fooled by the simpleness of shell, because shell programming is again a huge asset for any programmer, or because at the end of the day it is again a very powerful tool which is used to perform in-depth analysis as well. And writing shell command, I personally prefer it to be fun, because of the you can go about interacting with the shell directly, and to get used to it, to see a lot of code. I think for me Spark Shell is really fun, guys. So our Spark, the shell pretty much, again, it supports three types of interactive shells, guys. So we have Spark Shell with Scala, we have with Python, and with R as well. So we can go about concentrating how it works with Python. Let's quickly dive into what Spark Web UI is, guys. So think about it. What do you think about Spark Web UI, where you can use Spark Web UI, and what you can go about doing it, right? So quickly take a minute to see if something pops up in your head, or probably if you've seen or read about this somewhere else previously as well. So I hope you guys could figure something out. So coming to the concept, well, the web UI is again pretty much the web interface of a Spark application, guys. So why would you need a web application? Again, at the end of the day, the UI is really nice, and you would rather have take a look at a quick UI and figure stuff out really fast rather than getting messy, right? Well, mainly it is used for inspection. It is to see what your Spark jobs are doing, what's happening with your particular clusters and all of that, guys. So consider where every single time you create a new Spark context, this will basically tell your application to launch one instance of your web UI. Your web UI can be pretty much on it is on the local host machine, right? So there is this particular ID that you can use it, and yeah, you can do a lot of things with it. You can go about working with jobs. You can check out what the stages of your application is. You can check out what the storage, what's the issue with storage. what's going on, I mean how much amount of data your each application needs, so you can go about having your resource allocators allocate that. You can check out the environment in which it's being worked on, right? So a lot of things that you can do, and you will be talking to your executors at the end of the day as well. So web UI is really a fun way to take a look at that. So the jobs tab, again, yes, it is usually used to show all the status of whatever is happening with your current Spark jobs in that particular application, guys. So as I've already mentioned, the Spark context, you will be looking at the context in the job tab basically. Again, this particular jobs tab consists of usually 2 pages. So it consists of all jobs where you're given you're presented with a nice to look at list of all the jobs, and then you can go about finding out the details for each individual jobs as well. And later basically the tab which it is used to display your stages per state.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's say you have your state to be your application is in an active state, it's working, your application is pending execution, your application has completed execution, it has been skipped, or it has failed and crashed, something like that. So to find out all of this, I think web UI is it's really helpful, guys. And the stages tab again is to tell you basically when your Spark application basically got initialized, guys. So the stages tab that we are checking out is basically used to show that current instance of what's happening. So again, as I've already walked you through the instance, it can be stopped, it can be executing, it can be a lot of stages as well. Basically you can go about customizing this, but let's not get into the depth right now. Again, the stages tab, it includes all stages page, where this page will tell you the stages of all your applications. Then you can pretty much move into one stage page, and later you have something called as pool paging as well, guys. Coming to storage, well, yes, the storage tab again goes about displaying the information about RDDs. Again, if you do not know what RDDs, I hope I am piquing your curiosity on what they are, and this entire module is pretty much about RDD, so we'll be checking that out in the next couple of slides. Again, in the storage tab, we have something called the summary page, where summary page basically shows us the storage levels and partitions of all of these RDDs, and it shows us the size and the executors which are used for this. Use for partitioning our individual data, organizing the data in a structured way, possibly. And guys, the storage tab, right? So what we're talking about, it includes 2 pages. One is called as a storage page, and the other one is called as the RDD page. The storage page will greet you with all of the data of what your application is consuming, and the RDD page will tell you of what your resilient data sets are, carrying. What's the weight that they're carrying? What's the data that you're presented with? Is the resource present to be allocated, and all of that, guys. Next up, coming to the environment tab. The environment tab again basically displays the values for different configuration, a lot of variables, and your environment as well. Why would you need this? Well, at the end of the day, you can be working with Java, Scala, Python, and you'll be talking to a lot of system properties at the same time as well. To go about giving you a quick look at everything, I guess this would make it very important, guys. Again, the tab, pretty much as soon as it's created, you have 2 pages, guys. So one is the parent Spark UI, where you will be it's almost like an admin access to your application, let's say. And then you have the app status store, where you can go about coding and finding out what your application is doing at that point of time. And the next important tab is our executors tab, because executors tab will give you one single page, a huge summary of what's going on with your executors, that was basically created for your applications to run. So there's a lot of things it can display, but mainly you'll be concerned with the memory usage, the disk usage, the task that is in hand being processed, and the information that corresponds with it. The storage memory column in the executors tab pretty much goes about showing the amount of memory that that particular application is consuming in real time, and it will also show you the memory which is basically reserved for caching couple of data as well. So major caching actions goes on in this stage where we require faster access or near real time applications. So our executors tab pretty much give us that big summary there. So moving on, next we can go about having a quick introduction to the Pyspark shell, guys. So as we're already aware, Pyspark shell, again, it exposes our Spark programming model directly onto Python, and we can map, we can go about using Python with Spark directly. And our Pyspark shell pretty much links our entire Python API directly onto our Spark core, and it is used to initialize the Spark context as well. And as I've already kept on mentioning for a while now, majority of the experts, majority of say data scientists, analytics experts, they use Python because it has this amazing amount of huge library where you can pretty much find a library for even one of your custom requirements as well. So at the end of the day, I'm sure people at Spark had to integrate Python with it, because think about it. So Python gives you access to numerous libraries, and then if you can do all of that along with Spark, hey guys, that's a win-win, right? So integrating Python with Spark was definitely a boon. Yes, I can vouch for that. So yeah, Spark, again, it requires Python to be available on the system path, because Spark needs to know where Python is, and to have that unrestrained access, untainted access basically, and that is basically used to run all of the programs, guys. So to quickly give you an idea of what a Spark shell looks like, here is what it looks like on a Windows 10 machine, where you can pretty much go about installing Spark. I mean, installing Spark on Windows is it's very simple, guys. So as soon as you open up your the Spark shell and you go about typing PySpark, you can be greeted with a message which says Apache Spark with Python. And this is how some people might like working with shell and some people might not prefer. I mean, that's personal preference. But sometimes, yes, I still hold my word where I've told working with shell is fun and you'll be learning a lot as well. So next, quickly have an overview of how we can submit a PySpark job, guys. So with in terms of PySpark or Spark in general, it's not that all of our code are independent of each other, right? So sometimes we have this native code dependencies. It can be with other projects. You can have multiple source codes from coming in from multiple directions, and then you need a way to go about packaging them with your application, and you need this code to be basically distributed to every single node on your Spark cluster as well. So for this, we usually, we go about creating an assembly jar file that contains our code and all of its dependencies. So there is a quick requirement for Java as well. And you have Maven again, which can have assembly plugins. And basically when we're creating your jars or say lists in Spark and Hadoop, so again, these are certain dependencies that we need to know, we need to work with. And again, here's a quick overview as well. So after that, we'll have the assembled jar file, which we can basically call as the bin file, or our Spark submit script, which is used to basically, as the name suggests, to submit our script while passing our jar file as well. So as soon as you hit Spark submit, so this script is basically used to launch the applications that you've just programmed and to push it on the cluster, guys. Again, quick recall, Spark is already pre-configured for Yarn. It does not require any additional configuration to run. Yarn controls all of our resource management, scheduling, and security. It is possible to run an application in any mode, right, either cluster mode or client mode. So to be launching it in cluster or client mode, all you just have to go about using this simple piece of code. So you might be wondering all the backslashes, right? So if you're going about using shell programming, then you'll be exposed to a lot of slashes as well. So have a quick pause of the screen and try to see if you can figure out. I mean, it is not important at this point of time for you to know what this does, but then just see if you can figure something out, right? So most of your learning happens due to your perspective. So you try to figure it out and on your own, and I think that holds better in memory as well. So go about quickly pausing the screen to see if you can figure something out. And if you cannot, not to worry. Anyway, we'll be checking this out in the next couple of modules. So there, you can get familiar with this as well. So again, this is the steps which you'll be using to going about building the application. So we'll be creating a document. Let us say we'll call it PySpark job.py .py extension, because again this is a Python file. We'll be storing it on any of our local drives, local machines, and whatnot. As soon as you open the file, yes. So the what we're doing here is we'll be printing, hello, this is PySpark, right? So you can upload this particular file into our Cloud Labs local storage, guys. So if you're not making use of a virtual machine at this point of time, you can have this tiny hello world code to be pushed onto our Cloud Labs local storage, and you can perform this particular steps to go about working with it, guys. So basically, as I've already mentioned, to run your application you will be using Spark Submit Master, and we'll be using the yarn cluster here. So we're using yarn deploy, and as soon as you go about using that client your file name.py, it will go about pretty much working with it. And if you can see here, if you can check out the mouse, this is where you have your application output as well. So this is how you would go about submitting a PySpark job, guys. And so how can we go about checking a PySpark job using a couple of Jupyter notebooks? Spark can pretty much go about easily running in its standalone mode that we have discussed. And consider this tiny example I have on the right for you, right? So this is again Google Colab. I'll be quickly walking you through the same. So in this particular example, we'll be importing PySpark for our usage. Firstly, we'll be installing PySpark, we'll be importing PySpark, we'll be initializing our Spark context, followed by that we'll be performing our calculation. So we'll be using the mod function. This is basically our basic, Spark job. And later we'll be using an RDD operation to perform a transformation, guys. I hope I am, again, piquing your interest on what an RDD is. So if I have to give you a small trailer of what RDDs are at this point of time, well, RDDs actually stand for resilient or distributed data set, guys. So RDDs are the fundamental structures of Spark. And every data set in an RDD is again divided into a lot of local partitions, which is needed for each different clusters and all of that. Anyway, we'll be coming back to that. So let me quickly open up my Google Colab, so we can walk with our first PySpark job, guys. So this is Google Colab. You can basically access it by typing in collab.research.google.com. And this is basically, guys, at the end of the day, this is just a Jupyter notebook which is hosted on Google Cloud. So you can carry your code easily everywhere. So I've been using Google Colab for a couple of years now, ever since its launch, and I find it really easy. Basically, it's convenience, guys. So all you have to do is to run your code, you type in your code. So our first code is again to basically check the Java version that we require, and as soon as I go and hit the play button right next to it, done. So your code is executed, and you do not have to install Python, you don't have to install the dependencies, you don't have to go about configuring the runtime executor, nothing. So all you do is type in your code, hit play, and you're good. So that's how simple it is, guys. So basically we have Java version 11 right now, but for our Spark applications, most of the time we prefer Java 8. So I'll be installing selection 2 is basically Java 8. So I'll be going about installing Java 8 for that, and we'll be downloading Spark as well. So wget is used to download it from a particular server, and here's the official server link for picking up Spark 2.4.4.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session.
So as soon as I hit that, our Google Colab will go on downloading Spark and uploading in its file section as well. And this will take a minute, so we'll just continue as soon as we're done with the download. So that took about 20 seconds, guys. So that was pretty quick. And as soon as you download it, it is in a zip format, right? So it's in a TGZ format. So to go about executing this, we need to first of all unzip it, right? So we will use this command called darxf, where we are unzipping it in a format where Google Colab understands what is present inside our our Spark zip file. So after this, we have to install something called as Find Spark. Can you guys quickly guess what Find Spark is? probably take a second to figure out what find spark is. Think about it. I mean, if you can't figure it out, it's fine. So basically, to keep your spark instance to be portable, we make use of find spark at the end of the day, guys. So this is a very tiny module, so this should be, I'm guessing, installed under 5 seconds, and that's done. Again, you need to set up a couple of environment variables. We have to set up Java home. We need to set up the environment variable spark home. So this is the code to go about doing that, and as soon as I hit play, that's done. So let us go about creating our first Spark session, guys. So we'll be importing find Spark, or to go about starting your Spark session using find spark.init method, and then we'll be importing pyspark.sql. So we'll be including the SQL module from the particular Spark session, and at this we're just telling that we'll have only one local instance where you're working with it. So again, at this point of time, we're doing nothing but just creating an empty session for us. But you need to know that we have further code to check as well. So I cannot just go about executing further code because Spark session is already running right now in Collab. So let me quickly stop our session so we can pretty much rerun it again. Next up, we need to install Pyspark. So we have installed Spark now. Let's quickly install Pyspark. So this should take about half a minute, which is what I assume. Let's quickly import PySpark again, begin a new session. Let's go about creating our Spark context, right? So from PySpark, we're importing Spark configuration. Again, from the same module, we're importing Spark context as well. We're setting a variable, configuration is equal to Spark config. Conf.set master is local. We're telling it that this is the only local instance which will run. You can have any application name that you want, and here we just call it Spark Basics, guys. You have SE. SE is again our Spark context variable, where it's pretty much simple, guys. So you use this code, and this code is our standard, which is set to pretty much to go about creating your Spark context of your own. So let me run it again. It should take less than 10 seconds to go about running it. Here is what we were discussing in the PPT. We're defining a modular function where we're importing NumPy and we're returning the modulus of that. So again, RDD is equal to sc.parallelize range of 1000, mapping it using the take function. I know that you guys are not familiar with any of these right now, but then to give you a quick example, this is how it works, guys. So basically, it is like a list of all of the elements. Again, it is a structured data type. It forms the native of Spark. And don't worry, I have lots of examples that I'll be showing you, a lot of functions, a lot of operations that I'll be walking you through when it comes to RDDs as well, which is actually the next section that we'll be checking out. I just wanted to get you familiar with Google Colab in case you chose to use another Python IDE for the previous modules, and I just wanted to show you how you're what you need to go about setting up your PySpark job, guys. So what are Spark RDDs, guys? So I've already told you Spark RDDs pretty much stand for resilient distributed data sets. But at the end of the day, how is it? Why do we need it? What is Spark? We'll be just checking it out in this particular module, guys. So this module is basically all about RDDs, and we really need to know what they are, why we need it, and all that, right? So RDDs are immutable. They are they are separate, split, structured partitions of data. So basically, data, records, collections all mean the same. And they can be, how can they be created? Is basically you can have a couple of functions work on it. I'll be walking you through the functions as well. We have map, we have filter, we have group by function, load, and loads of functions. So when you have all of these operations done and you have certain things which are done to your data, well, most of it is you need to save your data after after you do certain operations on it, right? So to have a certain stable storage media, the media can be HDFS as well, and so after the transformations that's being done, you need a place to store it. So the transformation being worked on that particular data, guys, that is what RTDs are mainly used for. So there's a couple of things that I need to walk you. Very important things is pretty much with to start with. It is again, the first thing is in-memory computation. RDDs support lazy evaluations, fault tolerance, very good immutability. Again, as I've mentioned, partitioning, very good persistence, and coarse-grained operations as well. So here's a quick workflow of how an RDD works. So we have RDDs, we have 1 and 2, which again club into single simple units. And then RDDs are like arrays, right? So they're pretty much structured data. So this structured data gets converted into graphs. DAG is directed acyclic graphs. And with a directed acyclic graph, what usually happens is data flows from one node to another in a structured manner, where data can jump back and forth, and each node is connected to another node which is ahead of it. So basically what I want you guys to figure out at this point of time is to know that the RDDs goes from looking like arrays and a lot of numbers, and it basically goes into a graph where our Spark unit can understand what's going on. So after our DAG scheduler finishes its work, where it assembles it, orders it, and stores it, so this is next passed on to our cluster manager. A cluster manager will figure out where to pull the data from, right? So it can be EC2, it can be via Kubernetes. You can pull the data from a lot of places. So our cluster manager again is used for this. So all of the tasks set from our RDD. So consider each individual RDD operation to be a task, right? So this entire task set is pretty much pushed onto our task scheduler, where the task scheduler will figure out when to execute what, and how long to allocate a resource for that particular task, and so on. And so all of this data is pushed to the executor, and our executor will go about executing and giving us the required output that we eventually require, guys.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So why would we require RDDs, guys? Think about it. So just to answer that question is the next part of this module. We need to find out what are the stopgaps in the existing methodologies that lead us there, right? So firstly, I have in-disk computation, guys. So before the existence of RDDs, what used to happen was we had, again, ton loads of data back in the day as well. But all these data were being processed in a hard disk, in a spinning, slow hard disk. So we already know that in-memory computation can be done, which is already supported. Obviously, executing something in your RAM on your cache is 100,000 times faster than what it's done on your hard disk. So with in-disk computation, again, we needed something to go about stepping up our game, and we needed in-memory computation basically. So again, with in-disk computation, you're going to be using a lot of memory to store, and at the end of the day, if that is slow, it really is a turn off, right? So next we have job execution. So basically, whatever was existing, right? So consider MapReduce basically. So MapReduce needs to store some of its data. It needs to have an intermediate storage space, which again we called it HDFS. So it needs a place to store all the intermediate data to access it, to pick it up again. With the job execution, another important point is that it makes so overall computation of your jobs are really slow. So probably we can imagine and we can handle slow execution if it's one job, 10 jobs, and it takes about 5-10 minutes. But if a 10-minute job was taking about 35-40 hours, then that would really slow down things, right? So again, overall, it slows down your input-output operations, serialization operations, replication operations, and so on. With parallel processing, again, when we didn't have Spark, most of the data processing were not done in parallel, first of all. And even if an application supported parallel processing, it was not as efficient as that, guys. So we know how the RDDs are solving the problem for us. Well, mainly RDDs have, again, as I've mentioned, they have a huge capacity, huge capability to handle various volumes of data. So how does this do it? Well, basically it processes them all parallelly. It has multiple logical partitions where it can access, work on each of the partitions, and then save it later, guys. So you can go about creating an RDD whenever you want, but it's only executed whenever they are needed. So you can go on bunching up, creating tens and hundreds of RDDs that you want, and since Spark supports lazy evaluation, it'll only be picked up whenever it is needed, guys. So let's quickly check out some facts to, to go about explaining why RDDs are better than what's existing today. And the first important point I want you guys to note is that it supports, enhanced distributed computing, guys. So distributed computing in this day in terms of big data is again a big boon, right? So again, Spark RDDs are useful for, distributed computing, which involves processing lots and lots of data over lots and lots of computers with respect to lots and lots of jobs, right? So having this distributed computing capability is a big thing, guys. And secondly, partitioning. Well, RDDs again are partitioned. So basically, by partition, what we mean is, in simple terms, it is basically split into a couple of logical partitions, guys. And the partition data is distributed across all the nodes that are present in the cluster as well. So that is again a very important fact of why RDDs are better. And thirdly, location stickiness, guys. So basically, RDDs can define their own preference, so they can have their own location to where they have to stick to the partitions and where they need to be present for the data requirement procedures. So again, location stickiness is again another very important reason of why RDDs are required. Next up, let's quickly jump in to find out what are the features of Spark RDDs, guys. So as we already talked about this, as I've already mentioned this, the first major important thing of Spark RDDs is in-memory computation, guys. So, and any RDD for that instance and all the data that are present there, it can be pretty much pushed onto your memory, and you can have it stay in that memory for as long as possible. And this is, I've put it first because this has to be the most important feature of Spark RDDs, guys. And secondly, with respect to immutability, you need to know at this point of time is that an RDD pretty much cannot be changed once it is created, guys. So that is what immutable means. And sure, you can perform certain transformations on it, and it can only be transformed, but it cannot be changed on the whole. So RDDs are immutable, guys. Lazy evaluation, again, the data, it's not available or transformed until something is executed where it triggers the requirement. So you can code in 10-15 RDDs and you can just leave it there. It will only be picked up when it is needed, right? So again, supporting lazy evaluation is again another big advantage of this. Coming to cacheability, guys, this is again another very important feature of Spark RDDs, where our cache storage, it stores all of the intermediate RDD results just in the memory. So nothing is being pushed to your hard disk or local storage. And the biggest advantage here with RDDs is that the default storage for its cache is in memory, guys. So this ensures higher efficiency, better speeds of data access, and all of that. And the next important thing is parallel data processing, guys. So to process data sequentially is surely an advantage. But to go about processing your data parallelly, side by side, is something which takes, which requires a lot of muscle. So again, we can be very happy and satisfied with RDDs because RDDs can process the data in parallel for us. And lastly, the another important feature of Spark RDDs is that it can have types, guys. So it is a typed configuration where your RDDs can be of the type integer, it can be of the type long, it can be a float, and this again ensures better readability. It is more concise. It gives you that feeling of tailor make, where you can have your data which is in perfect condition, where as soon as you glance at it, if it's an integer coded data, if it's data with large numbers using long, or if it's a decimal number which has float and whatnot, guys. Next up on this module, we need to check out the ways the ways which is basically used to create RDDs in Pyspark, guys. Again, that's the basically that's the symbol of collab that you see on the right in yellow. And we've already checked out how we can create RDDs in that simple example I showed you, right? So we'll be importing Spark configuration, we'll be importing our Spark context. Or to go on about creating a Spark context, we'll be creating a conf object, guys. So basically, this provides the entire configurations for our Spark application. You'll be setting the application name. You'll be setting the master node as well. In this, in the example that you see, it is local because there'll be only one instance in this particular example that I'll show. And yeah, so we'll be defining the app name, the master URL as well. Master URL is local in this case, and we'll be using SC. SC is nothing but an object which is derived from our Spark context, guys. So we can go about doing another quick set of operations as well. So we can, create an RDD using a simple list. So we have already walked you through list in module 2. So just quickly, revise the concepts of lists. So here we have a variable values, and we have 5 elements in a list, and then we're performing this operation called sc.parallelize, and we'll be passing the values. We'll be passing the values and creating the RDD using that, guys. So sc.parallelize is an unfamiliar syntax for you, right? So sc.parallelize is an unfamiliar syntax at this point of time. So the parallelize method, basically when you're applying it on a collection, right? So in our case, the list is the collection. So when you're going about doing that, basically a new RDD is created for us, and all of the elements that are, they are copied into this particular RDD. So parallelize will pretty much go about creating a new RDD as well, and the syntax to go about doing is parallelize and passing it a collection, guys. And to print an RDD value, we usually use the take function, guys. So RDD.take of 5 will pretty much print the 5 items which are present in our collection. And moving on, there's a couple of things I'll be showing you practically as well. So to upload a file to Google Colab, we have this particular syntax from google.colab, import the files, and then we'll be pushing it into a variable uploaded is equal to files.upload. Again, that is a GUI. Again, I'll be walking you through that in a second. And we can go about initializing an RDD using a text file, guys. So if we have a particular text file where we're doing something, or we have a lot of data in the text file where you want your RDD to pick up the data in the text file, sure, you can do that as well. And we can go about printing the text from the RDD as well. So let's quickly jump into Colab, and we can check out the next set of demos, guys. So again, here's the demo that we're talking about. Values is equal to 1 2 3 4 5. It's a quick list for us. Parallelize creates our RDD, and as soon as I hit take, we'll have the output of it, guys. So uploading files to Colab, again, as soon as I run this, just see what happens. So it'll allow us, it's still running, so it's still waiting for me to put up a file. Let me quickly, jump to our desktop. We have a Spark file which is ready. It's a text file, basically, nothing important. So basically I have, I have some gibberish written in there for this example, guys. So loading a text file is again pretty simple. sc.text file of spark.text. The location here we're giving spark.text because, inside the files we already have it. So there is no other no other path where we have to provide it. So it is just files in case of Colab, guys. So as soon as I go about running this, it will pick it up. And as soon as I hit rdd.collect, which is basically used to print the RDD data, so it will say Apache Spark with Python is Pyspark. So this data our RDD has picked up because of what I have put in the text file, guys. So it is as as simple and straightforward as that. Moving on, the next concept that we'll be checking out is something called as persistence and caching, guys. So to begin, we already know that RDDs are support lazy evaluation, right? So you can go about using the same RDD any number of time you want, and it'll go on recomputing it as well. So this goes on for a while. Sure, for small amount of data it won't have a major damage, but for large huge data sets which are worth terabytes, say, to recompute it every single time, I don't think it is very efficient, right? So to go on avoiding this recomputation on a single RDD multiple times, you can have your Spark to persist the data. So persist the data will pretty much store it in its partition and hold it there. So if the node that pretty much computes the RDD and pushes it to the partition, and if the node has a data, let's say if there is a node which has data persisting on it and it fails, so sure, Spark will again recompute all of the lost partitions of the data when it's required. So that is the keyword here, when it's required, right? Not all the time. So again, sure, RDD. So can you only persist? No. With RDDs, again, they come with a method which is called as unpersist. So unpersist will again let us remove all this data manually from the cache. So let us say you do not require it, and you require your cache storage. Again, cache is again a small amount of data, right? You cannot push everything on the cache and rather have it stagnant there. So basically you can use the unpersist method that you can go about removing all the data, RDD data, from the cache, guys. So here's a quick persistence level chart I have for you guys. So with persistence level, you need to know that you can perform this is basically to give the user flexibility, guys. So with the memory only level, you'll be pushing all your RDDs onto your cache directly. That's why the space used is high. The CPU time is low because the data is accessed faster. It is always pushed in the memory and none is on the disk. So again, it stores an RDD as a Java object basically. And so what happens if your cache is already full and it doesn't support? Most of it is saved into the cache, and the other part which is not cached will basically be recomputed when needed, guys. So again, we have memory only, sir. We have memory and disk. We have memory and disk, sir, and we have disk only, guys. So at this point of time, I would just recommend you pause this particular section to glance through of the levels, guys. So there is, you can have high CPU time as well, which is not efficient if you push everything on your disk only, and none of it is pushed to the cache. None of the intermediate storage is pushed to the cache, and all of your data are on the disk as well. So this again is inefficient, right? So quickly pause the screen and have a look at this persistence chart, guys. So coming to caching, guys, we already know that caching data is very important, and when your data is being accessed repeatedly, right? So again, it is very important to go on caching it. We call it a hot data set because you might require it at every single point of execution, say in an iterative algorithm and whatnot. And cache is fault tolerant, as we've already discussed. And let us quickly go back to an example, and we can check out the example where you can have a data set and you can pretty much have it caged, guys. So let me quickly jump into Google Colab, and we can work out with it. So coming to persistence, as we already have it with persist, it is going to hold it in the cache and it is going to tell you where it is holding it, guys. So this is again a very important readability aspect of Spark as well. And coming to caching, as soon as we go ahead and hit spark.txt, again spark.txt is the file which we imported a couple of minutes ago. So with that, again text file.cache, so basically text file.cache is used to hold it there, and to basically at the end of the day, as a developer, as a programmer, to know that your data is fault tolerant and it will be there if something messes up is something important, guys. So now that we're done with that, let's quickly jump into operations that we can perform on RDDs, guys. There's a lot of operations that you can eventually perform, but then there's two main important types of operations that you can perform. So the first one is called as a transformation. Think about it, right? So RDDs are immutable, as we already discussed. So to work around this, we need something called as a transformation. So the transformation will basically return a new RDD, guys. So a lot of emphasis on the word new, guys. Since it's immutable, then creating a new RDD is, it's inexplicable. So creating a new RDD is a great requirement, guys. Again, what an action will do is basically it will return one singular value to us, and that will make our lives a lot simple, guys. So you will basically figure it out when you're getting your hands dirty with a lot of code. And without further ado, let's quickly check out RDD transformations, guys. So again, transformations, as the rest of RDD concepts, are all lazy operations that are basically performed on one RDD unit. And doing this will eventually lead to a transformation, will lead to creating one or more new RDDs as well. And how will it work? Well, here it is. RDD transformation, pretty much it will return a single pointer which is created to the new RDD. So our application needs to know where the new data is going, right? So basically pointer is used to memory map that. So our transformation will basically return a pointer to the new RDD, and it will allow us to create the dependency which is required in between each of these RDDs. Because let's say you have you have a couple of RDDs and each has a function to do something. It each has a unique function to it, and then to go about letting the RDDs talk to each other, calculating the data, having it stored in one common place, and all of that, right? So it's usually a parent RDD, and under the parent RDD we have what we call pointer dependency towards the child RDDs, and we work on with it. But at this point of time, let me not bombard you with a lot of in-depth details. All you have to know at this point of time is pretty much there is the dependency which exists in between each RDD, guys. Again, Spark is lazy, right? So by lazy, what we mean is lazy evaluation. So nothing will get executed unless you actually go about making some transformation or having an action that will actually create a trigger. So the trigger is basically what starts the operations here. So you can have job creation and execution there as well. So RDD transformation is transformation is basically not a set of data. You might be wondering if it's a set of data at this point of time. Well, it is not. It is a step in a particular program. It can be the only step, or it can be one among many steps. And so how the transformation works is it basically tells Spark how to get the data and what to do with it, guys. So couple of transformations that you can that we'll be walking you through with is basically map. We'll be checking out flat map. We can check out filter. We can check out map partitions with index. We can check out samples, union, intersection, all of these, guys. So without further ado, let's quickly check out each of these operations, guys. So the first transformation we'll be looking at is the map, guys. So what map in simple terms does is basically it passes every single element through a function. So think of mapping in literal terms, right? So let's quickly jump into code where it will be better to understand with code, guys. So again, we have a list. This is basically all strings, Spark, RDD, example, sample, and other examples here. So as soon as we use x.map and we pass a lambda function through it, so what basically happens is it lets us map it into key value pairs that you can go about seeing here. So Spark is mapped with 1, and RDD is mapped with 1, sample 1, example 1, and all of that. So our lambda function is pretty much used to perform the mapping here. So again, this is the code that we just walked you through. So you can pretty much map the key value pairs to be anything that you want, and this is the it is used to add a little more structure to our data, guys. So next we have flat map, guys. So flat map, what I want you guys to know at this point of time, it is pretty much exactly like mapped, but then you can have your values to be mapped from from 0 to any number of output items that you want. Why would you do this? Because let's say you have a function that should return multiple number of outputs, right? So we already know that majority of our functions will only return one output. But let's say we require a function which requires more than one output. So let's say you require a sequence. So in that in that particular case, we will require the flat map, guys. So again, we have sc.parallelize. We're basically creating 3 elements, 2, 3, and 4. And we are passing it on to our rdd.flatmap lambda function. Range is 1 to x. Dot collect again is added instead of doing separately. So basically here we have separated out y.collect, and here you can go about adding it there as well. So this again is pretty much creating instances and copying the values for us. So as you can check out 1 1 1 2 2 and 3, guys. So flat mapping, again, you wouldn't use it directly, but then you can go on a mapping to multiple elements that you want. You'll not be using it practically, but then hey, it's good enough. It's good to know, right? And next up we have filter, guys. So filter again, it returns a collection of elements which is you're filtering based on something, right? So think about filter in general as well. So you're filtering something based on name, based on ID, based on your roll number or whatever, right? So again, filtering here works the same way as well. So you have a collection. In our case, most of it is lists, and we'll provide a condition to it saying if this condition is valid, just collect all those elements for us. So coming to filter again, we have 1, 2, 3, 4, 5. If any of these individual elements, when you perform the modulo operation 2, if the reminder is basically 0, then we go about collecting it, guys. So we're going to divide 1 by 2. You will get a reminder, so that's not picked. You divide 2 by 2, reminder is 0. Yes, pick that. You divide 3 by 2, you will not get, you will have a reminder of 1, right? So that will not get picked. 4 divides 2 with a reminder of 0. Yes, 5 doesn't. So go about doing it. You'll get 2, 4. If you can, put in a 6 here, then you will pretty much get 2, 4, 6 as well. So it's as simple as that, guys. Next up, we have the sample operation. So sample, pretty much the process of sampling is where we small amount of data which either requires replacement or which doesn't require replacement, right? So having a sample doesn't have to have any ordered values, right? So you can have any random number generator to give you certain random data as well. So with the sample operation, we can have three parameters, guys. So this method supports three main parameters. The first one is with replacement. So with replacement is basically say sampling a certain element multiple number of times, right? So when you're sampling it out every single time, then you can have it replaced as well. The next up is the fraction. Basically, with fraction, you go about making the size of your sample so as a tiny snippet or as a fraction of what your RDD's entire size is. And you can do this without replacement of data as well. And next we have seed. With the parameter seed, what we basically do is, it acts as a seed for our random number generator, where we'll have a number being generated for us. So again, we're creating a number of range to 9, and it will pretty much go about generating a sample data for us, and you can work with that as well, guys. So to check out another example out here, we can check out another different range of data, but at this point of time, just quickly pause the screen, take a look at the code, and we'll be jumping to Google Colab, guys. So we're in Google Colab, and I just executed the second piece of code. So we're just creating sample data, which is from 0 to 8, and at the end of the day, we're collecting the simple sample data as well. And the next important operation that we should look at is the union operation, guys. So basically, union of two RDDs is basically concatenating and mixing all those elements. And yes, union does support repeated elements from most of our RDDs, guys. So let's quickly jump into Colab and execute it. So we have 1 to 9 on our first parallel, and then we have another variable called as par. We're creating an object of it from 5 to 15. So as soon as you perform the union operation on this and collect it, it is going to pretty much merge everything into one collection, and that is basically the output that you're greeted with, guys. So the next operation is intersection. Again, similar to union, but then it is the literal intersection, right? So whatever is in common in between both of these RDDs is what we'll be getting out of it. So quickly executing this piece of code from range of 1 to 9 and 5 to 15 in the numbers being generated here. 5, 6, 7, 8 are what is common between 1 to 9 and 5 to 15, right? So that's exactly what's printed. So the intersection is pretty much the common elements in both the data sets, and it's it's as simple as that, guys. Next we have distinct. Well, with distinct, basically we are transforming, creating a new RDD with all the distinct elements, right? So as I've already mentioned, it supports repeated elements, but let's say we do not require the repeat elements, right? So sometimes we require this hard coding where we require only distinct elements from it. So to go about doing it, basically all we do is it is exactly the same as our old operation, but again here we're doing a union operation. We'll just be adding the dot distinct method, guys. So dot distinct will eventually tell the interpreter to just give us distinct output, and to to filter out all of the repeated elements, guys. So another important thing that you can do with RDDs is basically to sort it using something, guys. So you can go on mapping something to another key that we've already seen, but what if you have to go about sorting this with respect to any of your personal any requirements, right? So here we have a sort by function, and this pretty much supports sorting in the ascending order, guys. So we have random numbers out here, 5, 7, 1, 3, 2, 1. As you can already see, they are not ordered in any fashion, but as soon as I go ahead and run this, you can check out that it's ordered, right? So it's 1, 1, 2, 3, 5, 7. So if we go about adding 10 here, 10 will remain in that last slot because it is the highest number. So again, after it's mapped, can we go on sorting it as we've already seen in the slides? Yes, we can. So this will be mapped again in the ascending order. So whatever is mapped for 1, Z comes first. Whatever is mapped for L comes next. Then H comes because it is the next 10, and lastly we'll get A, which is 26. So sort by is pretty much as simple as that, guys. So let's quickly check out the next one. The next is something what we call as map partitions. And map partition is the a simple alternative when you have to use map and for each, guys. So map partitions are pretty much called only once for every partition, but in the case, if you remember, in the case of map, where what used to happen is we used to, basically it was an iteration, right? So we used to call it every single time for every single element of every single collection. So to pretty much bring up our efficiency, what we do with map partition is we call it only once. So we've defined our function f, and we have a variable called iterator, and we have something called as yield sum iterator here, guys. So what happens here is you just pick it up once, you pick up the data once, you iterate through it once, rather than just picking out single data for every single RDD. And but then that particular instance, what we saw, it was not indexed, so you do not know how you can go about pulling the data and what the data actually does. So to get a quick idea of how you can pull up the data with indexing it, we have map partitions with index, guys. So it's basically a single term, but then I've just split it out in the title to just get better readability. So what map partitions with index does is it returns a brand new RDD for us by applying a function on each partition of the RDD while tracking the index of the original partition. So we need to find out what the original partition's index is, and then we will go on keeping a track of it, guys. So we have 1 2 3 4 and 4. As soon as instead of just throwing in our iterator variable, we have something called a split index that we'll be pushing onto our function. And as you can see, instead of just using rdd.map partitions and collecting it later, we're pretty much going about map partitions with index, and then we're yielding the sum operation of it, guys. Again, you will not be using all of these operations on transformations on your day-to-day basis, but then it's really good to know that you have access to all of these and you can go on using it, guys. So next up we have group by, guys. So if you guys are familiar with SQL programming, the group by here pretty much works the same way as well. So what we basically do is we return a brand new RDD as we've been doing with all the transformations. We do this by grouping objects in the already existing RDD, and we'll be using a grouping key to know what we are grouping it by. So let's quickly jump into the code where we can check out group by, guys. So again, we have a collection 1 1 2 2 3 5 8. So rdd.group by is what we'll be using. So we're gonna group by the values if it performs and validates the module of 2, and we'll be collecting that, guys. And later we're sorting it as well. So as soon as we go about executing this, we get 0 2 8. That's valid. We get 1 1 3 5 as well. So basically you're grouping it with respect to an order, you're getting a key value out of it, and then you're sorting the key, guys. It is really simple. So the next thing is something called as key by. So what a key by does is basically it changes the key of the RDD element that we have been working on for a while now, and it does this using our given key object, guys. So with the key objects, you can already check out the code. So we are basically doing an exponential operation, x multiplied with x, and we're basically having a value from the range of 0 to 5 with us, and we're performing the list operation on it with y. And lastly, again, we don't know yet what the zip operations means, which is exactly what we'll be checking out next. But what you need to know is basically we'll have a key, and you can have your individual collection items of the data arranged with respect to the key, guys. So what is zip? So the zip operation, it is used to join the two RDDs by combining a certain part of each other, right? So think of it as a literal zip locking with each other, right? So you have one part of one thing, one part of the module talking to another one. So it is pretty much something like that here as well. So basically what we do is we return an RDD formed from this list, and we create another collection by combining all of these elements that we have obtained in pairs. So we obtain a pair from one RDD, we obtain a pair from another RDD called Y, and you can check out the iterative example now on the screen as well. So we'll be picking out say A from RDDX with the data values 1 and 2. We'll be merging it with the data values of Y, which has the values of 4 and 1, right? It's pretty much as simple as that. So this will work when we have both of the RDDs of the same size, right? So what if one of the collections has a bigger size? So then what will happen, it'll map all our common elements, but whatever is in excess, that is pretty much ignored, guys. So let's quickly check out our zip function. So we have the range 0 to 5, 1000 to 1005. We'll be zipping our y with respect to x, and we're going to be collecting. So 0, 1000, 1, 1000, 1, 2002, 3003, 4004. Perfect. So next again, we'll be checking out our zip with index, guys. Again, it's a single word, zip with index, but for readability I just pushed it out separately. So what we do here is pretty much we'll create a new RDD. Again, we'll be pairing all of our elements that are in our list already. So whatever lists are present for us, we'll be checking out all the elements that are present there, and we'll be pairing it with their index as well. So you need to know that with Python, again with Spark as well, with Pyspark, and all the indices start with 0, guys. So since we're just adding an index for it, all you can do is pretty much, A, B, C, D, the output we should give it is 0, 1, 2, 3, guys. So A will be mapped to 0, B will be mapped to 1, C will be mapped to 2, and the index of D is mapped to 3. Pretty simple, right? So next we have the repartition transformation. So repartition, if you've ever played around with installing Windows, Linux or something, then you would have been familiar with what repartitioning a storage medium means. So basically you'll be changing the number of partitions, guys. So it is either it is used to increase or decrease the number of partitions in an RDD. In our case. So how does it work in the backend? Well, all it does is pretty much it does an entire shuffle of all of the data, and it creates new partitions where our data can sit in a fashion manner, and all these data, all the partitions are distributed evenly as well, guys. So let's quickly jump into Google Colab and let's analyze. So the data we have is 1, 2, 3, 4, 5, 6, 7, and the second data set is 4. We're sorting it. We're using rdd.glom to pretty much go about with our repartitioning. So the output we should expect is 1, second element to be 2, 3, third element to be 4, 5, and the fourth element to be 6, 7. Perfect, guys. So to find out the length of this, again coming back to my presentation, again, to find out the length of this, you can pretty much use the repartition.glom. So repartition of 2.glom.collect is again giving our outputs. As soon as I go ahead and run this, it is going to tell us we're basically working with 2 RDDs, and 2 partitions have been created where the data is being stored uniformly, guys. So it's pretty simple. Next we have coalesce. With coalesce, the practical part of coalesce is think about it, right? So you will have thousands of partitions when you're working with a huge data set. Coalesce is again used to combine, it is used to unite a couple of partitions where the data might be similar, or the data is not similar, you just want to bring it under one RDD, then coalesce is pretty much your friend, guys. So we have 2 data sets here, 1, 2, 3, 4, 5, and 3. So as soon as we pretty much use .glom.connect with coalesce, as you can already check out, we have one single entity which is giving us the data, and the data is being merged and united into one, guys. Here is another example of how coalesce works. With coalesce, again, you can already check it out that we've split up the second element as we've used in glom in the first example, and in the second example we've pretty much gone about coalescing it and bringing it into one single unity, guys. One single entity, sorry. So next, so what is repartition, what is glom with respect to repartition, what does coalesce have in difference to each other? With coalesce, you need to know that we'll be using the existing partitions which are already present, guys. So this is basically used to, it is used to keep the data which is being shuffled into a certain minimum extent. But with repartitions, it always does a full shuffle of all your data, and it creates brand new partitions for every single collection of every single RDD, right? Again, with coalesce, results basically in every single partitions, they are stored with different amount of data, right? So not every single data element is of the same size. With repartition, again, repartition tries to pretty much partition your data in such a way where each of the data partitions are pretty much almost equal sized. Coming to the speed of execution, coalesce is pretty much a lot faster because the first of all the shuffle is minimized, and second, it has data of its own different dimensions. So whenever data needs to be picked, honing in and hunting in on the data is really faster with respect to coalesce than repartition, guys. So repartition is a little slower when you compare it to coalesce, guys. So all these while we were checking out transformations with respect to RDDs, right? So next we can go about starting checking out the actions we can perform on the RDDs, guys. So we're already aware, unlike transformations, RDDs, they pretty much create another brand new collection for us. But here, with respect to actions, what we actually do is we create a new value which is given back to our Spark driver program, guys. But then to start an action, it needs a trigger. So actions have to be triggered with either a previously constructed RDD or another data entry point, guys. So with respect to the RDD functions, there is a couple of functions that we'll be checking out, and there's the reduced functions as first, there's take order, take count, collect for each min max functions, standard deviation functions, sum, mean, variance, and all these operations, guys. So let's quickly start out with reduce, guys. So with reduce, what it basically does is it brings everything, all the collections of a data set, and it we basically run all of these through a function of our choice. So as soon as we go ahead and let me quickly jump into Collab where we can go on checking reduced. So with it, the syntax is again pretty simple, guys. So for every method, every action, every transformation, we have a dot method which pretty much corresponds to it, and we'll be following the function that it needs to be passed through is basically the parameter that is supposed to have for the reduce function. So as soon as we run this, it is going to add all of the elements that are present in our function, guys. So just passing it through a simple function is what we're doing out here.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here's another simple example that we'll be pulling for all the values of in the range from 2 to 10, and so all these value here as well are being added together, and we're being given the output, and we're running a lambda function as well, like we've been doing for a while now. So if you guys are having some quick time running remembering lambda functions, I suggest you quickly jump into our previous module to get a quick rundown of what the actual lambda function does, guys. So the next action that we will be checking out is the first, guys. So first, again, if you can guess, it pretty much gives us the first element in our collection, right? So as soon as I go ahead and hit this, I get 2 3 4. The first element has to be printed. So if I do it 1 2 3 4 and run dot first on it, it is going to give us 1. So it is as simple as that, guys. So parallelize will be inputting our collection, and we'll be running the dot first method on it. The next action is take ordered, guys. So basically what we do here is we'll be returning an array with a certain set of ordered values for the RDD, guys. So consider the example on your screen. We pretty much have input 1539402, and we'll be taking elements in the ordered value of, we need 5. So basically what we're trying to tell here is we need 5 values, and we'll be taking it in the ordered sense, guys. So the first 5 values in the ordered sense will be 0 1 2 3 4 again. So again, as you can check it out, we have 0 1 2 3 4 because these are the first 5 ordered elements that we are outputting from the RDD that is present, guys. So next we have take. Take again, it pretty much picks up your value, but it does it without an order. So whatever order your RDD has been input in, or the collection that you've input in, is what it is exactly considering here, guys. So we have 1539 402, etc. So this here will be picking up the first 5 elements in the order of their occurrence. So as you can check out, 15394 is being picked up, but here we are picking it up in the ordered way. So that's the difference between take, ordered, and take, guys. So next we have count. Count, I guess you can already guess, right? So it pretty much tells us the number of elements that are presented that are present in an RDD. So as soon as we go ahead and hit count, let's count manually, right? First 1 2 3 4 5 6 7. So we have 7 elements. As soon as we run dot count on this, it should pretty much tell us that there are 7 elements present. Let's go ahead and add another one just for the sake of it, and it says 8. So the dot count method pretty much gives us the number of elements which are present in that particular RDD, guys. And next we have the collect action. So with collect action, what we're basically trying to do is we're trying to get all of our elements as an array, guys. So at this point of time, with certain transformations, we were creating brand new RDDs, but with actions, we're not doing that, right? So with actions, let's say if our driver program requires an array, it requires an entire structured data input. Collect pretty much does that, which we've been using and seeing for a while, right? So with collect, I mean, we're using collect for a while here right now. So pretty much, I'm sure you guys could have guessed it. So the collect action pretty much just pulls it out and gives us the array output that we've been seeing from our first section. And again, here is another example as well. So it's pretty much just another just a different collection of elements out here that we're pulling it out. But what we're doing with respect to the second one and the first one is, if you guys can see clearly that we have the the distinct method which is being present here. So we have gnu, cat, rat, dog, gnu. So gnu was repeated twice, rat was repeated twice, right? So that is pretty much being avoided just because we're making use of the distinct method, guys. So collect is very simple. And next we have save as text file. So basically, let us say you want all the data which is stored in your RDD and you want to push it as a text file. So you pretty much, if you want to pull it as a text file. So if the RDD's data set has to be presented as a text file to you and it has to be stored somewhere in your local file system or your HDFS, then pretty much you'll be going about doing this, guys. So with the save as text file, so pretty much we'll have a sample data which is generated for us. And as soon as I hit this, so if you're using a Linux or a virtual machine, this is usually how the data goes about with the path. So /user/bin/my data a1 is the text file where the random data is stored, guys. So again, we can have instead of random data, we can just pretty much go about giving our own data and then pretty much having it save as a sample file for us as well. So since we're doing this on a Google Colab on a Jupyter Notebook, the files which are pretty much output are saved online. But if you're doing this on a local machine, then you'll have to give the full path of the file that you need to put. So let's say you want it in your desktop, you just cannot save desktop. You have to just go about doing C drive, users, your username, and then desktop and the file name, right? So one important thing that you need to know is with Windows or with Linux, the extension is very important, guys. So I have had a couple of learners come to me with an error. So the file doesn't pretty much open because your native operating system such as Windows or Linux, it does not understand the the type of file which is being processed. So that is again another important thing which I pretty much wanted to tell you guys about. And jumping back to the slides, we have the next one is for each, guys. So with for each, again, the practical literal use of for each is where we are passing every single element into a function of our choice, right? So here we have defined a function called it f, where the variable is x. So what the function has to do for us is all it has to do is print. So we have defined the function, we're printing it, and then all we're running is this. We're running this RDD, and we're using the for each method to go on printing that out, guys. So let's quickly check it out. Basically, we're just printing each element and we're running it across the for each loop, guys. So next we have something called as the for each partition. Well, with respect to the for each partition, what we're trying to do is we're executing every single function for every single partition. So the access to all of our data elements that are contained in every single partition is, how can we go about moving with respect to every single element is basically we'll be using as an iterator as an argument, guys. So we'll be pushing an iterator to tell us how we can step across each single element and how we can go about printing it, guys. So for each partition is very simple. So we have a function which does the operation where we're running through each of the instances and we're printing x, and we have 1 2 3 4 5, which is our data elements. As soon as we go ahead and collect all the partitional elements here, so pretty much we'll be greeted with the same output of 1 2 3 4 5 as well. And now coming to a little bit of mathematical operations, we'll check out what min, max, sum, mean, variance, and standard deviation all mean. So Spark RDDs again support actions like min, max, sum, max, variance, and all the standard deviation operations as well. So I think it's better to move to collab and show you. So let's say we have numbers, a variable where we're generating an RDD for values from the range 1 to 100, And as soon as you go ahead and sum the values from 1 to 100, the value of 1 plus 2 plus 3, so on until 100 is pretty much 4950. And running numbers.min is going to tell us what the minimum number is here. In our case, the minimum number is 1. Next, we have variance. So variance is pretty much calculated by finding out the mean of it. So mean is usually the middle element in an ordered set of elements. By ordered, I mean either in ascending or the descending order. And the variance is how much each individual value varies with respect to the mean, guys. So here in our particular case, for the values from 1 to 100, our variance is what we get is of 816, and variance usually remains constant for that particular data set, guys. So numbers.max, what is the max element that are present? So basically our range starts from 1 and goes all the way up till 100 and not 100 included, right? So the maximum number in our particular case is 99, guys. So from 0 to 99, if you have to check out the mean, then the middle element that you'll be considering is 50, right? So that is exactly what we're doing here, guys. So number.mean will pretty much give us give us the mean element, guys. And standard deviation is how each single element deviates with respect to the mean. So we've calculated the mean, then we need to find out how much each of the single element moves away from the mean, guys. And in this particular case, it is around 28.5. It is pretty much as simple as that, guys. So next up, we'll quickly check out a couple of RDD functions, guys. So we already walked through a couple of functions here, right? So we've seen what caching does. So caching pretty much stores an RDD without computing it again. With collect, we'll be returning all of the single elements. Collect count by value will pretty much return us a map with the number of time that each value occurs. Then we have distinct. It pretty much returns an RDD which contains only distinct elements and no repeated elements. In terms of filter pretty much returns the RDD containing only the elements which map to that particular filtered function. And for each, basically we'll be applying one single function. In our case is f. So we'll be applying one single f to all of the individual elements of the RDDs that are being worked on, guys. And with persist, again, as you already checked out, since the storage level, if it is memory only, then all of the data, intermediate data, the caching data is just stored in memory all the time. But then we can force it to bring it to our hard disk as well. That is with the persistence level table that you need to check out, guys. So storage levels are available, and basically depending on there's a lot of things that you need to check out before using the persist operation, because at the end of the day you might require one module a lot of times, but then it's not specific to get it very quickly. So then you can have it stored on your hard disk and you wouldn't mind that extra stretch, right? So something like that. And we have another couple of functions that you already checked. We have the unpersist function where we'll be forcing it to remove the persistent blocks from our memory. We have checked out union, we have checked out intersection. Count will pretty much generate the number of elements that are present in an RDD, and sample pretty much returns the RDD of that particular fraction, guys. So next we can check out count by value. So count by value, let me quickly jump into my collab where we can check it out. So we have 1 2 3 4 5 6 7 8, again 2 4. So we have a couple of values here for our list, right? So as soon as I go ahead and run this, so if we are counting it by value, then it is going to tell us it is an integer type which is being counted, and it tries to map our values of the RDDs for us, guys. So it is pretty simple as that. And next we have to debug string. So with our to debug string, if we have to find out where the RDD is cached or where the RDD's value are being stored, if we have to check it in the backend, we'll be pretty much using .debug string, guys. So we have a range from again 1 to 19 or 1 to 13, and we're pretty much subtracting and storing it into the RDDC. So as soon as we hit debug, so wherever these individual values are stored, let's say if we have to map it for something else, or we have to use it for some other operation in the future, or to check where it is natively stored, we'll be pretty much requiring the mapped addresses, guys. So pretty much to debug string is literally used to to debug and let us know more about it. Let us check out how we can go about working with key value pairs, guys. So what you need to know at this point of time is there are a number of ways that you can get paired RDDs in Spark, right? So pretty much that's what we've been checking out for a while now. and there are many formats that can pretty much directly return all of these paired RDDs with all of their key value data as well. But with all the regular cases that we have checked, we need to convert these regular RDDs and then we have to turn it into our paired RDDs, right? So here it is being done natively. So how can we do this? We've already checked it out. Basically, we can run the map function where a key is mapped to value. So creating a pair, which we've already checked out, guys. So rtd.map is pretty much going to assign a key value pair for all of our singular elements, and it'll create pair RDDs for us, guys. So basically, here you can check it out: A1, B1, C1, D1, E1, A2, B2, C2, D2, and E2. So this is pretty much two different entities, and you can see a key element from A1 being mapped to the rest of the elements here, a key element from A2 being mapped to the rest of the elements there. And next up, we'll check out something called as RDD lineage, guys. What is RDD lineage? So RDD lineage is basically a graph with all of the parent RDDs which were given before transformations, guys. So as soon as you apply a transformation, we're already familiar that another duplicate RDD is created and that RDDs are immutable and so on. So lineage pretty much graphs us out. It gives us a graph of it gives us a DAG directed acyclic graph of the parent RDDs of that particular transformed RDD, guys. So it creates this path. It creates a logical execution path starting from the parent RDD and going to all of the transformations which have been done, guys. So it's pretty simple. You will require this to, we've already checked it out. It's pretty much debug string to print our lineage, and it tells you the map where the memory slots are given. But then you'll only require this if you're going about debugging your application or if something is wrong with that. To further talk about this, so basically, let's say we have an RDD graph, which is basically the result of all of the transformations that we have done. And, we have an RDD lineage graph, which is generated on that. So since we have done some transformations on it, they will actually be executed in particular order, guys. So here is to explain more about the debug string method. So basically we have been doing rdd.toDebug from all this while. So with all of these functions that have been, let's say you've used the Cartesian method, you've used the map method, you've zipped it, you've used the union method, then you've pretty much gone using keyby, you've used another union on all of these, right? So to give you the path of execution, to give you a route that you have taken, pretty much you'll be using that again, guys. Let us check out word count using RDD concept, guys. So what is a word count program? A word count program will pretty much return the frequency of every single word that occurs in the particular file. So let's say we have an RDD that is created which basically stores a text file data, and later we have we'll perform a couple of RDD operations which will eventually give us the word count output of this, guys. So pretty much how we can go about creating an RDD using a text file, as we've already checked out. So in this particular case, we'll be uploading the file to Google Colab, and we let Google Colab take care of our file, and we'll be filtering it using our lambda function, and we'll be checking out with the length of corresponding elements to be greater than 0. We'll be splitting all the words separately, and we'll be having a flat map for us at the end of it, where we'll be splitting it based on an empty character. And lastly, we'll be using the reduce by key and sort by key, where we'll be counting the frequency of occurrence of each single word, guys. So let's quickly jump into Google Colab and let's do that. So instead of pyspark.text, let me quickly go about doing spark.text, because which we already have, right? So we have spark.text. So as soon as I go ahead and create our RDD, we're picking it up, we're adding a filter to it, we are making it a flat map where we're splitting all of the individual elements, and we are actually counting the word, right? So now as soon as I go ahead and run this, pretty much all of these words have been put only once. So we have Apache Spark with Python is Pyspark. So all these are occurring once, right? So let's quickly change that. Let's have Spark here. I'm gonna give another Pyspark. Probably let's do it a couple of times here. S is caps. Sorry about that. Pyspark. So let me quickly save it. Come back to our Google Colab. Let's go to the part where we actually uploaded it. Or there's another simple way where you can upload files, guys. So to basically to upload files, all you have to do is open this tiny tab. You have to hit upload. You can actually go on deleting this right now. Go to desktop, go to Spark. upload this. So yes, so whenever you've uploaded files, it'll get deleted as soon as the runtime is recycled, guys. So now Pyspark is one, but let's create another RDD because we're picking it up from a new file. Let's filter it out again. Let's add flat map to split all the elements. Let us perform the word count and sort the words. So as soon as I go do this, it says Pyspark appears 3 times. Pretty much simple, right? And then you can pretty much save this entire flat mapped output into a text file, and you can have it under the folder called as word count. So if you're using this in your local machine, you need to give the location of the folder where you'll be pretty much wanting to store the data, guys. So the next simple concept that we'll be quickly checking out is called RDD partitioning and achieving parallelism, guys. We've been talking about partitions a lot, right? So partition is nothing but a logical chunk of data, which is basically large amounts of data. And Spark manages to pretty much use all of the partitions, and it helps parallelize all of the distributed data that we have, and it has to do this with minimal network sending, right? So you need to send the data and the receive data between executors as well. So if half of your time is wasted with just sending and pulling data, then it really doesn't make sense. So Spark has to do this efficiently as well, and it does. Well, how? Well, by default, pretty much Spark tries to read the data into an RDD from the nodes that are right next to it. So it will pretty much figure out what the access time of data from each node is. And this will basically tell it how close the node is from the RDD, right? So then it pretty much does the data pulling and pushing, and now we have the criteria where it really does minimal network trafficking, right? So here consider we have a couple of items. We have about 25 items on the screen, and the RDD here is split into 5 partitions of 5 each. So item 1 to 5 is partition 1, 6 to 10 is partition 2, 11 to 15 is partition 3, 16 to 20 partition 4, and respectively 21 to 25 is the 5th partition. So again here, as you can check out, if we are mapping it, we can cross map it to something else where we are pretty much using it as efficiently as possible, guys. And since Spark usually accesses distributed partition data, and to optimize all of the transformations, it creates the partitions that can hold a lot of data. So every partition is pretty much being created where it knows that it can hold a huge chunk of data, guys. So do we have to program how we partition the data? Well, absolutely not, because RDDs get partitioned automatically without a single intervention from the programmer, guys. But Spark pretty much gives us the functionality where we can go on adjusting the size, the number of partitions, or how the data has to be partitioned based on our particular application, guys. So this can be done using the def get partitions and array of partition method, where we'll be pretty much this is basically functioning on an RDD, and this will get to know the number of partitions that are present in the particular array, guys. So coming to the types of partitioning, we have 2 types of partitioning. One is hash partitioning and one is range partitioning, guys. So again, this is another step taken by the developers at Spark, where they're giving you the customization to partition it based on your particular needs. But there is a very important thing that you need to know is customizing partitions is only possible when you're using paired RDDs. So you cannot go about using this on single RDDs, guys. And but then so this might feel like a disadvantage at this point of time, right? But it is not. So again, another basic advantage here is that pretty much you will have data which is very similar, right? So you'll have multiple cases of similar data which is located at the same place. Then shuffling the data pretty much in by transforming it by using group by key, reduce by key will again make it an efficient way to pretty much know that you have an index where you can pull your data from. You can arrange it, you can sort it based on that particular index element, and this is again an advantage of having paired RDDs as well. So coming to the hash partition technique, the hash partitioning again is pretty much the technique where one single key, we call it the hash key. So the hash key is basically used to distribute all the elements across the partition, guys. So one thing, I mean, you will not be using this practically, but I just found this to be an important concept that I want to teach you guys. So with hash partitioning, basically you need to know that we have something called as the hash key, guys. So the hash key is at the end of the day our go-to person, where we'll be using it to distribute our, basically we'll be using it to track, to create and to distribute all of the values in terms of different partitions, guys. So again, we have one single RDD on the top. We have a couple of elements in that particular RDD, and pretty much we'll be hashing it. We call it the hash key. So we'll be using the hash key to pretty much tell where where the particular key and where the element of that key has to sit and in which partition basically. So all you need to know at this point of time is that hash key denotes where an element has to go into which partition, guys. Coming to range partitioner, well, we already know that RDDs, they have keys, and sometimes these key will have a particular order, say ascending order or descending order, and to go about doing this in a fashioned manner instead of using a hash key will be pretty much going about using range partitioning, guys. So range partitioning will work when you have something in ordered. So how do we go about doing it is basically we'll have tuple here. Our tuple will have keys which are in the same range as our native RDD, and keys in this particular range partitioners are actually partitions based on all of the sorted range of keys, guys. So you need to, the keyword that we are trying to highlight here is pretty much sorted. So the keys which are present here are partitions which are based on the sorted range of keys and the native ordering of the keys as well. So how do we go about doing range partitioners? Well, it's simple, guys. So first we need to compute a reasonable range boundary to our data, right? So we cannot have huge set of boundaries and work on it. Basically it will take more time. Followed by this, we'll be constructing a partitioner, giving the partitioner that particular range boundary that we're using it, and telling it to partition our index and work with it from there. And lastly, we'll be shuffling our RDD values against this particular range values, guys. So we have a couple of tray numbers out here to give you as an example. We have the complete tray number and from where it moves. So central station, northeastern station, Bayview, and all of that. So you can pretty much observe that a value from the southern train has been put into another RDD out here, and a value from our first central RDD has been put here as well. So as soon as a new RDD is being created after using our range partitioner, it is being done in a certain order. But then you need to know that the values are being shuffled after the values are being changed, guys. Coming to the last concept of this particular module, we'll be checking out how we can pass functions to Spark, guys. So basically most of Spark's transformation and some of its actions, it basically depends on passing the functions that we have already seen, right? So we usually pass functions by adding it, we're sorting it, and we can use functions there as well. So each of the languages that we'll be working on, Python, Java, and Scala, they each have a different mechanism to allow the operation of passing a function. And in Python, we can pretty much pass one function inside another function, and you can have it under an anonymous setting as well, which is the lambda function that we'll be using, and a couple of other functional APIs provided by Python as well. But some other considerations that come into play here are the name of the functions that we pass, the data that we reference in that function, and if the data needs to be ordered, and if they need to be serialized, guys.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. dstream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So Spark's API, again, the most important point on this slide for you guys is that it relies heavily on passing functions in our driver program, so it knows what can be done and what should be done when it pretty much runs on the cluster, guys. So two recommended ways to go about doing this. First one is to pretty much go about defining an anonymous function. Basically, it is a method which is used for any short snippets of code. But then what if you have a longer program or a longer set of code that you need to go about doing it? Well, sure, you can pretty much use an anonymous function as well, but then it is impractical to go about using typing it out in a single line. So we can use something called a static methods, where we'll be using a global singleton object to go about doing this, guys. So coming to the first anonymous function, so basically it's a method where we'll be using it for short pieces of code that I've mentioned. So one quick example for a short piece of anonymous function that we already discussed is the lambda function, guys. So lambda x, this function basically returns nothing but a sum of 2 to the input variable. So whatever is on the left of the colon is again the list of parameters that you need to pass, and on the right is the expression that which is required to involve all of the parameters and to perform operations in that. and you can name the functions as well. So as we already seen, 1 2 3 4 5 values and RDD is being created. We are creating the map function, and then we are having the lambda give us the +2 output of whatever is the input, guys. So functions take in multiple parameters, or the functions can take no parameters as well. So there's pretty much no compulsion that you have to compulsorily push in values to a function, guys. So as you can pretty much check this out, we are adding 2 to each of the elements here. So 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, and so on, right? So it is pretty much simple, guys. So with the anonymous status of this function, so as soon as you pretty much find it's basically saying is that it needs to init our main function and then get the value of x. So you can have the lambda function return the x plus 2. It doesn't have to be as simple as x plus 2 what we've shown here, but then you can pretty much go about doing it in more complex ways, again depending on your application as well, guys. So coming to static methods, let's say we have the quick example where we're defining an object. Let's call the object as my functions, and let's pass a function to it calling it as func1. So instead of just passing values to our function, what we can go about doing is pretty much we can do the call by reference as well. So if you have to revise call by reference quickly, then you can go about checking out the older module. But to tell you what call by reference means is basically the value gets copied into the formal parameter, and changes done inside the function pretty much reflect outside the function as well. So instead of having just one singleton object where you'll have to create another duplicate object and work on it, with respect to static methods, it basically requires nothing but just sending one single object, and it contains it basically that single object that you send will pretty much pull in and bring all of the class data mentioned along with it as well. So here's what a simple class looks like. Class name of it is my class. We have function 1. We have another function, it's called do stuff, and basically here what we're trying to do is we're creating an instance of the class, and we'll be calling the function of it, guys. So the do stuff method of it. So the map inside the reference is pretty much it's the func1 method, and the whole object. So as I showed you in the previous slide, the entire object has to be sent into this class, guys. So to give you a quick example with respect to mapping, it is exactly as similar as writing rdd.map, where we are mapping the same reference, this dot func1 of x, guys. So again, Spark is pretty much giving you the highest efficiency possible when you have to define an object like this, and when you have to pass the entire object towards the class, and you can pretty much go about mapping it using one single line, guys.
So Spark for big data, let us understand how Spark works with big data. So originally, what we used to do for big data, now big data is any data source that is outputting data at a very high rate, like petabytes per second or terabytes per second. And big data is also considered any data that is basically above the size of terabytes or petabytes is called big data, because it is of an extremely high size, right? So earlier we used to use this framework called Hadoop MapReduce to process big data, right? So what Hadoop MapReduce used to do was basically, if you had a bunch of computers together, if you had a bunch of servers all connected together, you will basically divide the data that you have to process across all of those computers or servers in equal parts. Once you've divided the data, all of those servers or computers will execute their part of the big data analytics query on the part of the data that they have received in parallel. So that reduces the time that it would have taken to process that big data if we were doing it in a sequence only on one system. So Hadoop MapReduce was the first framework that helped us achieve big data computing with parallel programming, basically. So each node executed their own job, and after all of the jobs were executed, the output was aggregated, it was combined together, and at the end of it, we got the output at a much faster rate, right? So you can see the original framework, big data is here. We pass the data through Hadoop MapReduce framework, right? And we get our desired output. So the problem with Hadoop MapReduce is that it's a primitive technology. It was used in the earlier days when random access memory, or RAM, or physical memory as we like to call it, was really expensive. So you must remember a time, if you're familiar with computer hardware, you must remember a time when RAM was extremely expensive. Now it's not that expensive. We have it in plenty amount in almost all mobile phones that we use today. So RAM has gotten a lot cheaper ever since the early days. Earlier, when we used to process big data, every temporary file that we used to create in between our jobs, every temporary output that we used to create in between our jobs was written to the disk. It wasn't, we didn't depend on the RAM. We wrote that output on the disk, the hard drive, right? And then when we needed that intermediate output once again, we basically read that from the disk again and put it back into the RAM. So that is how it used to work, because we didn't have a lot of RAM. So we didn't store anything on the RAM for a really long amount of time. We stored it on the hard drive, right? So after we read it, and then we got our desired outputs. But the problem with this essentially was that there were input output delays, right? Because every time you're putting the data back into your hard drive and reading it back into your physical memory, there is some lag, there is some input output delay. So this input output delay, when you're dealing with extremely large amounts of data, this input output delay can add up to a lot, right? It can increase the time taken by your job by a lot. So we needed a solution for that. So when RAM or random access memory started getting cheaper, when physical memory started getting cheaper, another alternative was developed to Hadoop MapReduce, and this alternative is called Spark. Now, Spark uses a framework called the Spark engine for its processing. The usage of the Spark engine over the traditional MapReduce framework emphasizes on in-memory processing and the usage of shared variables across nodes. This makes Spark about 100 times faster. So how does this Spark work now? So earlier we were writing everything, every intermediate output was being written onto the hard drive. In Spark, since now RAM is cheap, we store the intermediate output on the RAM itself. We store it on the physical memory of the node itself, because we have the ability to, because we have RAM in plenty. So because of this, there is significantly less input output delay, because we don't have to write anything much to hard drives anymore. We can simply read our data once from the hard drive, put it into the RAM, process all we have to, and get our output directly. Now, for smaller files, the difference between Hadoop MapReduce and Apache Spark is not at all visible. But when we are talking about files in the terabytes and petabytes, we can almost certainly see that Apache Spark is about 100 times faster in the output that it gives us as compared to MapReduce. Let us look at how normal data is processed. So if you're coming from a data analytics or a data science background, not from a big data background, if you've done something with data analytics or data science, so you must have used these particular technologies like Python and R. These are the most popular technologies for data related subjects, essentially. So data analytics and data science with Python and R. So you have your normal size data. Say if you have a data like 5 MBs, or if you have a data like something like 500 KBs, right? Very small amount of data. So this is generally the size of the data set that you must be familiar with when you were using Python or R. This is the normal size of data, very small nominal sort of data set, but you plot your charts and whatever you have to do. So that is normal data, right? So you pass it through Python and R or Java or Scala, and you can use the libraries that they have to process this amount of data, and you can get your desired output. So this is for normal data. But what if you have big data and you want to use the same languages, right? You don't want to use any exclusive language for big data or anything. Not that anything like that exists, but if you don't want to use anything, if you don't want to learn anything new, you want to simply integrate big data in what you know as it is in your data science or your data analytics. So Spark provides you with exactly that. Spark provides APIs, application programming interfaces, for all well-known data analytics languages like Java, like Python, like R, and like Scala, for seamless and easy integration, eliminating the need for training for newcomers, right? So basically, you'll use the same logic. You'll use the same logic as you were using with Python, and you'll use the same logic as you were using with R. You will simply import a bunch of libraries for Spark. If your system has Spark configured onto it, you'll just import a bunch of libraries for Apache Spark, and then you can simply pass big data sets as well in your query. If you pass big data sets in your Python and R, normal vanilla Python and R, they would have given an error, or they would have taken a lot of time to execute that output, because they were running on single node systems. When you use these libraries with these Spark libraries with these languages, you can essentially take advantage of the multi-node Hadoop cluster or multi-node big data cluster that you have. So you write your normal Python script, you import a bunch of libraries, you run that Python script, you run the Python commands, and you'll get that output at a much faster rate, similar to what Spark can provide you. So that is the advantage of using the Spark APIs with these languages like Java, Scala, Python, and R. So I hope that makes it clear for that particular doubt. Okay, so let us understand the workflow of Spark, how to query data files. How do you actually query data files with Spark? So it's a very simple Java-based model.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session.
So a data frame is something that you need to familiarize yourself with when we're talking about, particularly when you're talking about Spark. A data frame is a data set organized into named columns, right? It is conceptually equivalent to a table in a relational database or a data frame in R/Python, but with richer optimizations under the hood. So one thing that you need to note specifically is that when you are creating a data frame with pandas as opposed to when you are creating a data frame with Apache Spark, there is a difference. So when you're creating a data frame using the Apache Spark libraries or API, what happens is the data frame is optimized for big data. So the data could be spread across multiple nodes. The data frame will pick all of the data up. It will pick the data up from all of the 6 nodes and give you a combined view of that data. A normal pandas data frame cannot do that. So you can essentially use that data frame like a relational database. You can run SQL queries on it like we are going to be doing today. We are simply going to be importing that data frame, importing that data set using Pyspark, and we're going to be running SQL queries on it using Pyspark essentially. And so it is conceptually the same, but there's a fundamental difference that is there are richer optimizations provided when we're dealing with big data, when we're using Spark APIs. So the workflow is as follows. You have your raw data. Now, this raw data can be semi-structured or unstructured or even somewhat structured as well. So that is a different case entirely. We're going to be talking about semi-structured or unstructured today. So example of semi-structured would be CSV files or JSON files, where you don't exactly have SQL tables available to you, but you have files in a particular format, like in CSV files, which is an abbreviation for comma separated values. All of the files entries all of the files data points are separated by commas. So the comma is a delimiting value that separates all of the data present in your text file. So that is semi-structured because it at least has some structure to it. In unstructured, you can basically write up a random sentence, and that would be your unstructured data because it does not have any order associated to it. It's just a combination of words put in a random order. So that is unstructured because it does not have any structure to it. Say if you have a raw data, unstructured or semi-structured, you use something like Python or you use something like Scala with these Spark APIs. What will happen is when you import it, it will create JVM objects, right? This is the Java virtual machine objects because Spark runs on top of Java. But the libraries are available for Python, R, Java, and Spark. But Spark at a fundamental level is coded in Java, right? So it will create JVM objects. Now, these JVM objects can be treated as RDDs. These are resilient data sets. And then you can specifically pass a function called the 2df function, and you can convert them into a structured data format. So now this structured data format is in the form of an SQL table, and these are called Spark data frames. And then you can simply run, as you can see over here, you can run Spark SQL queries on these Spark data frames, and it will function in the exact way as an SQL table would, and you'll get your query results. The advantage, why are we not using MySQL? Why are you using Spark? We are using Spark because it is very well optimized for big data, while your MySQL is not at all optimized for big data. So this is the entire reason we are using Spark data frames, that we're not using Python data frames and we are not using MySQL data tables, essentially. So Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So what we are going to be using today, we're going to be using the Spark SQL context with our Pyspark libraries, right, today, to analyze the data today. So let's continue. So we're heading on to the demo, but a few quick things before the demo. when we use Spark libraries with Python, the combination is termed as Pyspark. There is no such language as Pyspark. Basically, you're using Python, but you're using the functions available in the Spark library. So that is casually termed as Pyspark, but it's simply Python with Spark. And we're going to be using the Pyspark in action with the help of Jupyter Notebook, right? So we're going to be executing it. So if you have done Python before, you know what the Jupyter Notebook is. In all probability, we're going to be doing just that. So we're going to take us there in R. What we are going to be using today for our Jupyter Notebook implementation is Google Colab. So if you know, Google Colab is something like this. You can simply go on to this website and you can start coding in your Jupyter Notebook. You don't need to install anything new. If you're doing some minor things, if you're doing more complex things like big data analytics projects and stuff, then this Google Colab is not recommended in that case. Then in that case, you would use your own system, or you would use something like a cloud system, right? Like your AWS or your Microsoft Azure Databricks or something like that. So since our data set today is going to be small, because we're going to be just demonstrating how Spark works with data sets in general, we're going to be using Google Colab. You can do the exact same thing with Google Colab as well. Right, you can take a screenshot and you can essentially enter it, all of it over here. So the first thing, I have written down some statements beforehand. So these are statements that help us set up our Pyspark session. So since writing all of this by hand would have taken a lot of unnecessary time, we have simply written it down beforehand. So the first thing that we obviously have to do, you need to have Java installed onto your system. So the first thing that we did was install Java, open JDK 8. JDK 8 is the version that is compatible with Hadoop, and it is the version that is compatible with Apache Spark as well. So make sure you have JDK 8 installed onto your system. And then we have simply provided the link to the library of Spark that we are going to be using, which is the Spark 2.4.7, which is compatible with Hadoop 2.7. So this is what we're using. Although this is not the latest version of Spark, the latest version of Spark is Spark 3, but we're using 2.4.7 because, in my opinion, it is the most stable version of Spark, right? And then we've extracted it, and then we've simply installed Find Spark. Now, Find Spark is a tool that helps Python find out that a Spark framework exists on the system. So when you install Find Spark, it will basically initiate a session with the Spark libraries. So we're going to be using that as well. The next thing that I have done, first I'll play this so that this actually executes first. So it will take some time to actually happen. Okay, this has executed. Now we will set the paths. So setting the paths in my temporary Google Colab. So I've set the paths, right? And then I'll simply start my Spark session. So I have imported Find Spark similar to the manner you will import it in Python. And then I've simply initiated the location and the name of what I'm actually going to be using. The Spark home has been configured, and I'm going to be using Find Spark init to initialize that. And then after the Find Spark has been initialized, we have our Pyspark available to us. And from pyspark.sql, we're going to be importing the Spark session, and we're going to be starting our Spark session. The variable will be Spark. These are very complicated terms, so do not confuse yourself with all of this. If you decide to get on with the course, if you decide to get into the course, all of this will be very clear to you. But for now, we're only looking at how to data analyze, right? So let us just generate the session. So once we play that, it will take some time, but it will start up our session, right? So I'm getting a lot of, some people are from a machine learning background and some people are coming from their data science background. So they're asking as in what sort of knowledge base do they need to have in big data when they're basically going on with their machine learning and deep learning and whatever. So it is a general, if you're from a data analytics background, right? So if you're implementing something like machine learning or deep learning or artificial intelligence or data science, you all must be familiar with the fact that data sets really matter. The data should be really good. And the more data that you have, the more clean data that you have, the better will be your machine learning model, the better will be your artificially intelligent system, and the better will be your insight that you get from your data science project. Right? So it depends on the quantity and quality of data. So big data as a technology that if you learn big data, if you understand how big data works, you can integrate it with machine learning. Right? Once you integrate it with machine learning, you can create even more accurate, like pinpoint accurate machine learning models. So the big data knowledge in the machine learning environment and the data science environment is extremely helpful. So I would recommend everybody who is in the machine learning and deep learning environment to enhance your skills by understanding how to use big data sets. We see Hadoop in the code. Any info on that? So if you're seeing Hadoop in this code, so that is simply the file name. We're not actually using any Hadoop particular statements. We're not using Hadoop libraries. We're using Spark libraries. Spark essentially runs on top of a Hadoop framework. So, but we are using Spark. We're not using Hadoop library. Okay. So the next thing I would do is show you how data frames work. So I'll simply use the Spark session to create a data frame. It'll create a data frame essentially where we're only seeing the top 3 rows of a data frame that has the column name hello, and all of the values corresponding to that column name are world, up to a range of 1,000, right? So we're only seeing the top 3 rows. But if we simply remove this and put it into 100, we'll see world, up until 100 records, essentially. So let us continue now. So the next thing that I'm going to do is actually I'm going to be importing a file that I have personally on my system, and I'm going to be analyzing that. So the topic for today is analyzing data from different sources. So I'll tell you how to especially access those different sources. So I'm going to be accessing something from my own file system, and I'm going to be putting it on the Google Drive file system, and then we are going to be analyzing. So first thing, Google Colab helps you with this library where you can import files when you're using their platform. So I'll simply play this and it will simply pop up a screen. I'll get a screen and I can choose a file that I want to upload. So I have this data set called sudo facebook.csv, right? So we're going to be using that. So once I click that, the file will be uploaded. We'll see when it's uploaded 100%. Now, right now it's a 2% upload. So once it has been uploaded 100%, we can carry on with our next statement. So it takes some time to actually download, upload. It's a file that is 7,000 bytes. So that is about 5 megabytes. So yeah, it has been uploaded 100%. The file is there, and this will start executing in a minute. Once the stops executing, we'll execute our SQL statements with Pyspark. So yeah, our statement has finished executing. We have successfully put our file onto our Google file system, and now we'll simply create a code block and start with our programming or data analysis. Not programming, essentially data analysis. The first thing that I'm going to do is create a data frame. So I'll call this df again and equate it to spark.read.format. The first thing that I need to specify is the format. So format of the file is CSV option. So I'm going to be adding a few options. Firstly, I want to include the headers because the CSV file has headers. So the column names essentially are headers. So I'm going to put that value to true, that yes, my file does have headers. Use the headers. So these are more technical aspects, particularly related to if we are actually accessing this entire data set as a schema. So yes, I want to do that. So I'm putting that value as true. And then we're going to put a data mode, which is going to be fail fast. So in case of any data loss, the data is going to be replicated and recovered. So put that into fail fast mode and load, and then we have to provide the location. So the location is the present working directory. Since we've already uploaded the file, we simply need to write the file name. So that does that. I think we should be good to go. Yeah. So we can play this and it will create our data frame out of the file present in the Google file directory. Yes, it has played successfully. And if we simply write something like df.show and put in something like 3, we get our output. So we can see how the data frame looks like. So the first column name is the user ID, which is the unique identification number of each individual on Facebook. We have the age of that individual. We have 14, which is the age. 13, I think, is the minimum age limit for Facebook. So we have ages 14. We have the date of birth of that individual. We have the gender. We have the number of days the person has been on Facebook. We have friends count, right? We have the friendships that person has initiated, so the friend requests that the person has sent. We have the amount of likes that the person has made. We have the amount of likes that have been received by that person. And all of this data has been divided into 4 more columns, which is how many of these likes are on mobile devices and how many of these likes are on web browsers. So we have a very definitive data set for Facebook, and we can perform a whole lot of analytics, like real case analytics with this data. So I'm going to show you just that. So one of the questions that I'm getting is, what are the other file formats except CSV? Okay, so you can use JSON as well. You can use other things as well. Say you have packet files. Essentially, you can use packet files. Essentially, Spark with Spark, even if there is not a preset file format that is available to you, like when you write spark.read.format CSV, and whatever file format that you may personally have does not exist in the Spark libraries, there's not an issue for that as well. You can also use surds. With surds, you can also import your custom file formats as well into your data frames. So that is pretty flexible with Spark. If you do a little bit research, or you're guided in the correct direction, you can implement that pretty easily. So it's not limited to CSV. All right, so let me continue. Okay, so a lot of things we can do with this data. First thing that I want to do before I actually start executing SQL statements, right, is I want to create a temporary view for this particular data frame, so that I can access that name with my SQL queries. So the first thing that you have to do is register this data frame. So create or replace temp view, and whatever name I put in here within these double quotes, this would be the name that I would refer to it when I'm using the Spark SQL context, right? So the name that I'm going to call it is Facebook data, and then I'm going to simply play this. So yes, we've successfully created our temporary view. So what are we going to do now? Now it gets really simple, especially for people who are coming from an SQL background. This can get really simple now. See, the only part of Pyspark that you needed to know, especially in the case of SQL context when using with Pyspark, is up until now. From now on, it is a simple Spark.SQL, and whatever query you put in these double quotes using the table name Facebook data, it will execute and give you that exact output. So this could be 5 MBs of data, this could be 5 GBs of data, and this could be 5 terabytes of data. The exact same procedure will be followed for all of those. So now you can see how Python is advantageous when we're using big data with Python, right? Because you are not essentially learning any new languages, right? You're not essentially learning Scala. You know Python, and you can simply execute all of this with Python as well, right? So Spark SQL, put in something like select, and say I want to count the number of rows, the number of people who've registered on Facebook. I want to count the number, right? So I can write simple count, put in an asterisk over there, right? So this will count all of the rows, right? And I want to get in the table name, which is Facebook data. So once I've done that, if I simply put in a dot show and bracket open, bracket close, right? So this particular function will execute this query and give me the output. So we can see now that we are getting our output, which is 99,003. These are the number of records available in this data set. And that is exactly what we're getting, right? So you can see how advantageous this gets. If the number of records was 1 million or 2 million or 3 million, and you have a big data cluster available to you, you have PySpark.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Installed on that big data cluster, right? And you can simply call in the Spark API and do this with Python itself. This normally you couldn't have done with a Pandas data frame. You can do it with a Spark data frame using Python. So this is the advantage of using Spark SQL or Pyspark, essentially. Not Spark SQL, but Pyspark. All right. So let me do something now. Let me find out the average age of male users and the average age of female users, similar to what you would get as your employer would ask you to find this out for a marketing campaign or something, right? So select SQL, and then what we will do is use our SQL knowledge to it. So we will find out average age. I think age is the correct column name, which is age over here, right? Yeah, that's correct. Average age, and then we will put in gender. So because we are going to grouping it by gender, right? So once we grouping it, once we put in the from Facebook data over here, we put in that, and then the next thing that we can do is group it by gender, so that we get the average age for the male gender, the average age for the female gender, and the average age for the non-disclosed gender as well. So dot show, put in a double bracket and play this, and this will execute what it needs to execute. So we can see. So in the averages, we can see that the gender, okay, that is a pretty high age. Did not expect that, but okay. The average age for the people who have not disclosed their ages is 74 years. The average age for the female Facebook user is 39 years, and the average age for the male user is 35. So yeah, that was not the answer that I was expecting, but that is the case with data analytics. You run these use cases on it and you get that appropriate output. So we generally know that people in the mid ages are generally more active on Facebook, create more accounts on Facebook. So it has lost sort of that earlier on when, say, we were dealing with the entry times of Facebook, right? Essentially, where younger people were generally more on Facebook. Now we have transitioned from Facebook. Younger people have transitioned from Facebook to Instagram. Right now, people in their 30s to their 40s and 50s are generally creating more accounts on Facebook. So it gives a lot of insight with relates to gender dynamics and age dynamics when we're talking over these particular things. So let me do something else. What if I do something like Spark.SQL? So we'll find out the average number of friends per gender as well. So let us see which gender at an average has the most amount of friends when we're talking about Facebook accounts in general. So average, we'll see over here, which is the friend underscore count. So friend underscore count, right? Just a moment, we don't have to put a double quotes over there. Yeah, so friend underscore count, and then we put in a gender over here and from Facebook data and group it by gender as well and show, and we play that up and we can see the average friend count for each of these genders. So we can see at an average, the people from a non-disclosed gender have 184, females have 241, and males have 165 friends at an average on Facebook. All right. So we can see that, and let us continue now. So all of this minded that whenever I close this particular tab, right? Whenever I close this tab, all of this data will be lost, right? In SQL, it wouldn't have been lost. It would have remained there in the relational database. But in this particular case, the data will be lost because it's a temporary. It's stored in the RAM. It's stored in the RAM of this particular Google Colab instance. And once I close this, the data will be lost. Right. So say, let us do something else other than that. Right. Spark.SQL, and let us find out at an average what can be find out. Let me look at it over here. So let us find the amount of users on Facebook. Do they use mobile phones more, or do they use computer devices more, right? Do they use desktops more or laptops more to access Facebook? So this is something that is also possible. The logic for that is I can simply see the mobile likes, and I can simply see the www likes and compare both of these, and we can simply evaluate from that whether a person is using mobile phones more or whether a person is using their browsers more, like their computer browsers more. So how do we go about that? Select mobile like, and that's that. Mobile likes. Okay, mobile likes. Select www underscore likes. Okay, and we can simply put an average over here as well. So do that, and from Facebook data, forgot to put in a double quote over here. That is important. Because you're essentially passing an SQL command, right? That is what you're doing. That is why you need to pass it as a string instead of something that is inbuilt in, say, Pyspark. And we can also add a few more things to it. Let me think what we can do over here. So let us put some age demographic onto it. So let us find out this particular thing where age is greater than equals to 13 and age is less than equals to 35, right? And we can do that, and that is how SQL functions. And we close that up, put in a dot show over there, back it up and back close, and we play that up. So we get this particular data from this particular age demographic, which is 13 to 35, right? So in the people who are 13 to 35, we can see that at an average, there are 113 likes per account, and at an average for the web browser, for the computer web browser, there are 45 likes per account, right? So this basically shows that people use mobile phones more than how much they use web browsers, because obviously mobile phones are more handy, right? But let me see if as we get to a higher age demographic, does it change? Right. So I think it's not going to change, because I think people from all age demographics tend to use mobile phones more today. But let me confirm that. That is what data analytics is all about. And given a age demographic that is above 35, and we put a play over there, so we can see that it's the same, except obviously the activity is a lot less, but it's the same. 94 likes per mobile device, not mobile device, per account on the mobile, and 57 likes per account on the web browser. So we can see that. So we've done that, and similar to that, we can perform other queries as well. So we do something else. We've taken out averages a lot. What else can we do with this data? Just a moment, guys. Short. Let us just simply find out the trend of age and friends count as well before our course advisor joins us. Okay, so let's continue with that. Sorry for the delay. Just a moment. Do I need to do I need to code every time I lose the session, right? So you don't need to do that. So with that is the thing with about using these frameworks, like you have your Google Colab over there, or you're using some sort of an offline Jupyter notebook, or if you're using scripts, like you're writing some script in Sublime Text or Atom or Visual Studio Code, you write that script, right? What I mean by runtime over here is that during the execution of the statements, right? That is the runtime. And if I simply end the session right now, the data that is being stored in the RAM of this particular instance will be lost. These statements will not be lost. I'll have to simply play them once again. So say if I close this particular session right now, if I click on the close button, if I come back and I simply don't play all of this, if I don't play this, if I don't play this, if I don't play this in sequence, and if I simply directly go over here and play this, right, it will not run. I'll have to play this in a sequence for this to actually get into an active session and have the data in the RAM. We have our data frame initiated over here, and we have our temporary view created over here. We need to do all of this before we can actually run this particular statement. Is what I mean by not losing this. Is what I mean by losing the data when I lose the session. Because in Spark, the data is stored in the RAM. It is not stored in the hard drive. So make sure if you're using something like Google Colab that you don't end your session if you still have some queries to go with. Otherwise, you'll have to go through the hassle of running it all over again. So yeah, all right. So what else can we do with the data? So let us see. Like I think we pretty much understand the gist of it. I think we've pretty much gone through the gist of how all of this functions, right? You can run anything in a normal SQL format. There are a lot of functions that you can run, not just the average function, something like Spark.SQL. So if you're familiar with SQL, you know all of these. So select. How do we go about it? What if we do something like friend underscore count, and we simply do something like user, I think, ID. So user ID, yes, underscore count user ID from Facebook data, order by, and we put something like friend count, right? We do that and we put a show over here. I think this should run. This will put it in ascending order of friend count and user ID. I think if we put a DESC over here, I don't know if it's before the friend count or after the friend count, but I'll play this just to see. So if we put it in DESC, so we can see that the maximum friends that a person has, at least in this data set, is 4,923. And that is of this particular user ID. So we can also do that. We can sort the data as well, and you can understand how long it would take to sort this data if we are simply dealing with vanilla scripts, vanilla systems. And when you're using Spark, you essentially have your data divided into multiple, multiple nodes, multiple blocks. All of those nodes will execute their respective blocks, and the data will be sorted in a much faster manner, right? Because you're essentially doing a form of parallel sorting, and then all of the data is combined at the end and aggregated, and then you get your sorted data. So you can imagine sorting is a very expensive task, and how long it would have taken to do this for a terabyte worth of data if we were simply using pandas for that. So we can see how it functions. Let me see something else. We can also use something like sum. So I simply put it over here and put in Spark.SQL and select some friend count from Facebook data. So put that over there and show it, and we play it. We can see that the sum of the friend count is 194, 39317. So we calculated that pretty much instantly. So let us look at the architecture of the HDFS and how MapReduce would actually operate on it, right? So the architecture is quite simple. So imagine generally the big data clusters in big organizations have hundreds to thousands of nodes attached together. Here we're only talking about 4 nodes, just so you guys can understand what I'm actually talking about here. So firstly, there is the name node. Now, the name nodes could be multiple, the data nodes could be multiple. There's no limitation that the name node should only be one node. It could be multiple nodes, right? So what happens is you will take the computer that has the most, that is the weakest essentially, and you'll make it the name node. And you'll take 3 average performance computers as data nodes, right? So whenever you're coming in as a client to that particular HDFS or big data cluster, you'll start to upload a file, say it's a terabyte file, right? And you're starting to upload it. So what will happen is you'll first contact the name node. The name node will then see which data nodes have the space. So it will check which particular hard drives in the data node have the space to store that data. So firstly, it will determine which data nodes you're going to be storing your data on. Then it will basically communicate the block size. So the data will automatically be divided into the blocks of that size, whatever block size you've set, and then it will get started to store on the data nodes one by one. So the first block, say the green block, as you can see, they are colorized as well. The first block, let us say the green block, goes on the first data node, and then the orange sort of block goes on the second data node, right? And the third, the red block goes on the third data node. So imagine that, right? There are also 2 other colored blocks. I'm going to be explaining what that means in a second. So imagine you've divided into green, and orange went over here and red went over here, right? So whenever MapReduce programs run on the Hadoop cluster, The green block will be executed in data node 1, the orange block will be executed in data node 2, and the red block will be executed in data node 3, minimizing the time by 3. So it will basically divide the time by 3. So, and the next thing that HDFS helps you implement, now this is not that prominent as we're only using 3 data nodes, right? If there were 100, then it would make sense. Say you set the replication factor to 2, right? So the replication factor essentially is a solution that helps you deal with data loss. So say data node 1 fails, it goes bad or some hardware failure occurs. So you don't want to completely lose the green block, right? You don't want to lose the green block because that is just a part of the data that you don't want to lose. So HDFS, depending on the replication factor that you've set in your HDFS, if it's 2, the green block will be replicated 2 times. So it will be replicated on data node 2 and it will be replicated on data node 3 as well. And if there are replication factors 3, if there is another data node, it will be replicated on that data node as well, right? So even if data node 1 fails, you still have access to data node, the particular block that's green. So similarly, data is also replicated, whatever blocks are put on the data node. So say then you uploaded the file on the data nodes, the client comes in to read the file, right? He wants to access that file that you've just uploaded, the other client that wants to read it. So what will happen is he'll be automatically connected. Once he contacts the name node, he'll be automatically connected to the data node that is the closest to him. So minimize latency essentially. So if data node say if this is in say for example Los Angeles and this data node is in say New York, they're all connected together for some reason if they're not closely located for that matter. So if this person is in New York, he'll be getting access to this data node because that is the closest to him, right? If all of the data nodes are present in one location, so in that case, it doesn't really matter in that manner. So the name node is storing where the data begins and where the data blocks end. The name node is storing that information, the data of the data, the metadata. So it will store where the green block is, how many times it has been replicated, and where the replicated blocks are, right? So that is what the name node will store. So in that manner, the HDFS essentially runs in a very conjunctive sort of way where everything is organized and stuff. Can we integrate Hadoop with Azure? Or it needs Linux system? You can easily integrate with Azure. Azure has a service altogether for that particular aspect. So firstly, Azure, you can use Databricks with Azure. Azure is a Microsoft cloud service for those of you who don't know. You can use Databricks with Azure. And it has all of the cluster computing elements already built in without you having to install anything. Okay, MapReduce runs on the same Hadoop cluster that stores the data using the nodes to process in parallel. Yes, it does that. So the server, what is this? The next question that I have. Using MapReduce for storing huge data, so that using server is reduced or not. So see, in today's day and age, server technology is really cheap. So when Hadoop was developed originally, servers were really expensive. So servers are really cheap now. They're not as expensive as they used to be. So earlier when this was made, servers were really expensive, but now we can. So let us continue now.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below. Now, let's continue with the session. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We're going to be analyzing a Facebook data set, right? It's not that big of a data set because obviously I'm not going to be uploading a terabyte data set on the Google servers or the Google Colab, right? But when you're dealing with this at an industry level, it is almost the same procedure. You only have to deal with the providing the link to that data, and Hadoop manages everything. The HDFS manages everything on its own. So you don't have to really deal with all of the blocks of data. It all happens seamlessly. So let us go to the Chrome tab that I have open. So I currently have my Chrome tab open over here, right? So I've already written some things down. So this is what is required to actually start up this particular process, right? So if you sign up for the course or something that we have, you'll get access to this particular code, but it's easily available as well online in this particular regard. So the first thing that you will obviously need is Java 8, right? So Java 8 is something that is a prerequisite for Hadoop. So if you're having HDFS on your system, you need this particular implementation. And if you're running Spark on your system as well, you also need Java, because Spark essentially uses JVM objects, right? So you need Java installed. So that is why I've installed Java. And then I've installed my Spark, right? My Spark and Hadoop combination over here. So that is a link that keeps changing from time to time depending on the repository. And then I've extracted it, and then I've installed FindSpark, which helps us integrate Python with Spark, right? I've set up some environments for my Java and my Spark so that I'm able to access it. And then I have started with my Python code. So firstly, I've imported FindSpark. So we've connected our Python with our Spark by initializing the FindSpark module. And then I have imported one module that we're going to be needing for our session today, which is the pyspark.sql module, where we're going to be writing some SQL code within the vicinity of Pyspark. So the first thing that I would do is initialize my Spark session, right? So we need to initialize Spark sessions before we actually use the Spark variable, right? So I'll be uploading my data set with the Google Colab implementation. So firstly, I'll play this. Actually, I have to play this from the start. So I'll be playing that firstly. So it takes some time because it connects to the Google servers, and then we are able to do that. So the website is collab.research.google.com. If you go there and type anything, you'll be able to do it. You'll be able to create your own Jupyter notebook. So this is essentially an implementation of the Jupyter notebook that we have. So it takes some time for it to download. I'll just wait for that. Let me run. It actually takes some time. So sorry to keep you guys waiting. I'll just pause this one for the time being. All right, so I'll play this firstly. The problem that you have with Google Colab in specific is that every time you start the notebook again, you have to run the commands again. So it's not like you are getting access to an already built Linux system. So every time you start Google Colab, you're actually initiating a Linux sort of cloud, right? So you have to install all these things again. It's good for practice, I would say, but it's not good for actual development purposes. Yeah, so we've successfully run the first block. Now we will set up the environment. This will take no time, and we'll initiate the Spark session, right? That will also not take any time. So firstly, I'll upload the file. So it asks me an option to, when I type files.upload, it asks me an option to select the file that I want. So I want this Facebook data set. So I click on that. And once I've clicked on that, Google will automatically put it into the drive, and then I'll get the access to it. So 12% done. So here you can see the percentage. So 59% done. It takes some time. Let us finish with that. So meanwhile, I can write some other code as well on the bottom. So we'll just go ahead and do that just a moment. Yeah. So firstly, while this is uploading, let me type in some code, right? So generally what you get with big data is if you're dealing with organizations, right? Organizations obviously want to boost their businesses, and the way to boost their businesses is through marketing. So the marketing is the number one thing that actually is the success key for businesses, right? So a lot of these organizations are online, like Amazon, like Google, and they have large user bases, like enormous user bases. And all of these users have data sets. They are generating data almost on a day-to-day basis. So if you go on Amazon, Amazon knows what you like. Amazon has idea about how many stars you've given to its products. So all of that data Amazon has. So what Amazon will do is give that data to the big data analyst, and the big data analyst will basically answer some questions, find some information out of that data, give that visualize that data, or basically summarize or document that data, and give it to the marketing team. And then the marketing team or the sales team can make their pitch based on it, or make their marketing strategy based on it to maximize profits, right? If you're dealing with a data science team, you can forward that information to the data science team. The data science team and the machine learning team can implement models based on that data to be able to create recommendation engines and properly recommend the customer, know what the customer likes, right? So that is how all of that works. So firstly, we'll create the data frame out of this data set. So df is what we'll call the data frame, and it's like a Python variable. Df will be like a Python object. Df equals to spark dot read dot format. So we'll specify the format that we actually want our file to be. So currently what we're importing is a CSV file, which is a comma separated value file. As you can see, facebook dot csv, right? And we want to include the headers because the data set that we are dealing with has headers. So the first row of the data set is the header name, and we'll put it to true. So the header status is true. Yes, we want to include the headers. Option infer schema. So infer schema, and when we put it to true, what it will do is it will automatically detect the data types of the values. So it will create columns based on those data types. So if it's a numeric 1, 2, 3, 4 column, then it will assign an integer to it. And if it's a name-based columns, then it will assign string to it. So the next thing that we'll do is mode will be fail fast. So if there are any exceptions, it will automatically be detected. And then load. Then finally, this is the part what I was telling earlier on, that no matter where you have your data, you'll simply put in the location here. So if you have data present in the HDFS, you'll do something like this, and given the location. If you have data present in the directory, the present working directory, then you're simply given the file name. So I'll copy the file name, put it over here. So, and then I'll click on play. So when that play starts executing, we'll have our data in our location, right? So just to confirm, first thing that I'll do is actually create a temporary view out of this data and put this data frame in the Spark SQL context, right? So first thing that I'll do over here is type in what was it, create or replace temp view, right? So the other advantage that you get with using Python is also get this auto recommendation thing, right? You can get all of the details of that particular function that you're using. That is not the case that is possible when you're using Scala sort of the command line libraries, right? So if you're doing this from the command line, it will be a lot difficult for you if there is any error or anything. I'll assign the name. Let us call this FB because FB is short for Facebook, and we'll click on pay. So what will essentially happen now, this FB name is what we are going to be referring to DF in the Spark SQL context. So Spark will create a virtual SQL environment, right? Virtual SQL environment means that there's not an actual database that we have installed. We don't have a MySQL database, but Spark will mimic an SQL environment. It has created a virtual environment in which this data frame is going to be considered as an SQL table. So that is what we are calling this virtual table as, like FB. So code, let us see how this looks. Spark.sql. You simply have to type that and type in the normal SQL statements. Select asterisk from the table name that we've just assigned it, FB, and put it in a dot show, bracket open, bracket close, and then we click on play. It'll actually give us the data set as we can see, right? So keep in mind that this is something really convenient if you're coming from a database management background, right? You can see these are the only new commands that you essentially have to deal with a little bit of Python. And after you've done the steps until here, if you're using simply Spark SQL, if you're not using any sort of complex Python code, right? This is how easily you can get started with big data. So if you're coming from an RDBMS background and if you want to deal with data that is of enormous size, right, and your SQL skills are really good, you can get ahead and basically create your career out of this, right? You can create a career in big data analysis as well. And then you can expand upon it with other knowledge as well as you move ahead with Python, with Scala, or any other technology you've chosen to start your Spark SQL career with, right? So we've done that, and we can see that there's user ID, so the unique primary key number, the age of the Facebook user, the date of birth, the gender, how many days the person has been on Facebook, the friends count that the person has, the friendships that the person has initiated, that means the number of friend requests that the person has sent, the number of likes that the person has, the person has given to other people, the number of likes that the person has received, and this particular number of likes has been divided into mobile likes. So the number of that has been done with mobile phone applications, and the number of that has been done with web browser applications like Google Chrome or Mozilla Firefox, right? So that is also accounted for, right? So let us do some analysis with this data now that we know what the column names are. So it's quite simple to do that as well. Firstly, let us evaluate the average age of a person on Facebook, right? So what you'll do for that is, or we could just, the first thing that we could do definitely is type in spark.sql and open up an inverted comma and pass our SQL query, select count and given an asterisk over there. So this asterisk means we're using all columns, and FB. So when we do that and we type in .show and we click on play, so it will give us all of the count of the columns, count of the rows that are there. So there are about 99,003 records in this particular database, right? So this particular advantage that you get with this is you can simply write .show as a Python function and you'll get your answer, right? There are other things that you can do with this as well. If we go with spark.sql and given another query like select average, and we can give a column name. So for instance, if we want to go with age, we want to find out the average age of a person on Facebook, we'll type an age over there in the average section. And from FB, we put in that and we close this up and type in .show. We do that and we click on play. So it gives us the average age is about 37. So the current average age for an individual on FB based on this limited data set that we have is about 37. So I think it gives us a right rough estimate, right? So say for instance, the marketing team wanted that question out of you, now they have it. So the advantage of running this with Spark is that no matter the size of the data set, whether it's in terabytes and there are billions and billions of records, you can do it pretty easily, very easily. For this matter, it can happen really fast. If the cluster is big and the processing is happening in parallel on different nodes, this will happen in almost the same time as it happened for me over here. So go on another and we can do some creative things with it. We can also find out the count of males and females and basically do this average age thing as sort of a male female thing. So let us try that. Spark.sql select average age. So once we've selected average age, we also want something that we are going to group this column on. So we want to group this by gender, right? So once we include that column name and we type in from FB. So this is basic SQL, by the way, and type in group by gender. When we do that and type in .show over here, click on play. So it will categorize the average ages by gender, right? So for the gender that is non-disclosed, we have 74. For female, we have 39, and for male, we have 35. So it's double value. It's a double value, by the way, right now. But that is because it's actually calculating average, and average by default is calculated in double. So that is there. So the next thing that we can do something more creative with it. How does Spark operate in parallel? So Spark actually operates quite simply in parallel. Similar to MapReduce, you're actually installing Spark on all of the devices that are present in your big data cluster, similar to how you would install Hadoop. So say, for instance, you have HDFS already installed on all of the devices. So it's already Hadoop, the Hadoop cluster has already been created. Now your administrating team will come in and they will install Spark on each of these systems, right? So when you go ahead and like over here, when I created this particular data frame, right, and I specified an HDFS address, right? So whenever I specify the HDFS address, it will automatically take all of the blocks that are present across all of the nodes. It will give me a combined view over here, right? So we don't need to concern ourselves with block 1, block 2, block 3, block 4, so on. When we give in the file name, right, it'll automatically go to the name node, understand where all of the parts of the files exist. It'll import that file in the data frame. We don't have to deal with any of the complications. We just have to store the file on the HDFS and we have to import the file using Spark. So that is how easy it is. Will any changes made through Spark be reflected in the original database? No. So this is the advantage with Spark SQL. You're essentially housing this entire data set in your RAM, right? So this is a temporary view of that data set. So here you can make changes, but you can create a new file with it, right? Or you can overwrite the existing file that you have, right? But it's not necessary that any changes that you would create, any data frame changes that you would create will be reflected on the original data frame. In fact, these things, these particular data frames that you create, this DF, is immutable in nature. So immutable means anything that you want to change to this data frame as well, even in the RAM, right? You'll have to create a new data frame out of it. So say if I wanted to alter the value of 106 to something else, you would have to create a sort of new data frame for it, right? If you wanted to add a new column to it or remove one column from it, you have to create something like df2, right? So the way we manage that in Spark, if you want to create new columns in it, is firstly we'll create a new column out of the existing column, and then we'll use garbage collection to remove this column so that we are not actually over our RAM limit, or we're not actually over using our memory, right? So let's continue with that. What else was I talking about? Yeah. So now let's see how this can be integrated with Python pretty easily. So say right here we had the average value like 37, right? What if we didn't want to see this like in a table format? What if we wanted to store it in a Python variable? That is quite easy as well. So say our variable name is X, right? And we want to basically have this data stored in that variable so that we can do further Python operations with it, right? So we do that. We remove the show because we don't actually want to show it over here. The thing that we'll do is type in dot collect, right? We type in dot collect, and then since this is a table value, right? So this comes automatically in the form of an array, right? So we cannot actually collect it in a single sort of X and expect to see the value as a singular value. So we'll treat it as a two-dimensional array. So anything, any SQL table that you will have in life is sort of a two-dimensional array. So the first would be 0 and the second would be 0 as well. So you're essentially taking the first value, the 0, 0 position value, right? And that when you do that and you click on play, it executes without any issue. And when we click on print, say for instance, x plus 2, right? So when we do that and click on play, so instead of getting 37 and this, you get 39. So I hope that is pretty clear as well. So this is similar to Pandas DF. So the next thing that we can do is say, for instance, we can find the likes received at an average for a female and a male, right? So that is something that is quite interesting as just curiosity point at an average. What gender receives the most likes on Facebook? So these are the sort of interesting questions that you can answer for your marketing team or your sales team. So average likes underscore received. I think we're correct with the spelling. EI. Always make sure I don't mess that up. And average likes received. And then we copy gender over there, and from FP, and what we can do now is something like, I can provide an alias to this, so I can call it average like, right? So I can refer to it as average like instead of something like average age. And then we can do a group by gender and an order by average like, right? So what this will do is it'll also it'll do the grouping, and it'll also do the sorting. So it'll be sorted in ascending order. I'll click on play. So firstly, we have the minimum average like, so that is 67, that is for male. For non-disclosed genders, we have 157. For female, we have the average like of 251. So gives us some demographical data, right? So we get that data out of this. We understand how gender dynamics work on Facebook, what sort of the behavioral personalities of people are on Facebook. We can understand from these data sets. That is how easy it makes it. And then remember, you'll always have this data in extremely long formats to give you an accurate viewpoint, right? So if you have 10 records of data, it wouldn't actually give you anything specific to go by. But when you have millions and millions of data records, you have a sort of an accurate answer as to how these things work, right? And something else we can do with it, let us see, let us do something with age demographics, right? So let us understand how many friends people have between the ages of 13 to say 25 and from 25 to 35. So let us go with sorry, not average age, average number of friend underscore count. And we go by from FB. Now we can use a where clause for this, right? Age could be greater than equals to 13 and age is less than equals to 25. We do that and we click on dot show. We click on that and we click on play. Oh, actually, I think it's a moment. What did I do wrong over here? Just a moment. So is the each correct? Okay. Just a moment. Yeah. So actually, I got confused for a second there and implemented the Java equivalent over here. So I shouldn't have done that. The and percent symbol doesn't actually work with SQL. So for the people with the SQL background immediately notice that. So I forgot about that. Yeah. So when we use the and, it actually works with that. Sorry. So thank you, Deepak, for correcting me. Yeah. So yeah, I use the and percent symbol there by mistake. So when we use the and, we get the average friend count, 268. So that is the average friend count of a person that is on Facebook between the ages of 13 to 25. And when we change this to something like 26 to say 50, so let us see how that works out. So that is significantly less. That is 113. That also tells us about age demographics. If we want to find out the usage of individuals on Facebook. So there are two data columns that are available. That is the mobile likes received and the www likes received, right? Not www likes and the mobile likes. So these might seem like normal sort of columns that are there. We can also determine the usage of individuals. Like at an average, people say between the age of SQL and just a moment, spark.sql select average, and we say if we want to find out the mobile likes, we copy that column name and we put it over here, and we take average the website likes, so Facebook from browser and Facebook from mobile applications, from FB where age is greater than equals to 13 and age is smaller than equals to 25, and we type in a dot show over there. We do that and we click on play. So we can see that the average mobile likes is about 123. So this gives us an idea essentially that the web browser usage is quite low these days because everybody has portable devices, right? The usage of computers for accessing social media websites is quite low anyway. So we can see that this from this particular data that we have, right? And if we change the age as well to see if there is any difference between older people and younger people. So we can type to 20 greater than equals to 26 and 50 like the previous. And when we do that and we click on play, so we can see that it's less, but the ratio almost remains the same. So it's mobile likes higher and average web browser likes are low, right? So these are sort of the things that you can do with it. You can also perform some complex mathematics with it as well. So these are sort of the things that you would have to do if you want to find out any relations between the data. So this tell you about this before the course advisor actually joins us, right? Just a moment. So instead of using the Spark SQL context, right, you can do some other things as well. So data frames are not just limited to Spark SQL. There are other ways you can refer to them. So for instance, if you want to use something other than Spark SQL, right, if you're coming from a development sort of background and you want to do some complex modeling with your data, right, In that case, you'll use the group by like directly on the df instead of using the fb, which is the virtual name for that in this SQL context. You'll use group by. And for instance, if I want to refer to a column name in group by, right? So I can simply type in, for instance, age. For instance, age. Let's use age. Let us group all of the data by age, right? And then once we've done that, and we want to do something else, for instance, we want to calculate the average. And for average, I mean, say we want to find out the tenure of the person on Facebook, right? So let us use the tenure column name. So once we've done that, then we will type in order by. So we will sort this data by the, let's say, age. We want to sort this data by age, right? From lower to higher, we want to sort it like that. And then if you want to sort it by lower to higher, we can simply go ahead and given the ascending value as true. If you keep it, if you don't actually add this, it's by default considered to be true, right? If you want to actually arrange it in descending order, right, it'll actually give you the data in descending order. So firstly, we'll do it in descending order, then we'll do it in ascending order, right? And we type in dot show. So once I do that, and hopefully if there are no mistakes, it should run. So there's an issue with that. Tenure is not a numeric column. All right, so this particular column is not entirely numeric, I believe. So there's some problem with the data set in that regard. So I'll not use tenure. Let us use something else. Let us use friend count again. So there must be some string values as well. So it's not entirely a numeric column, in my opinion, then, and there are string values in that as well. So we'll change this to friend count and click on play. So that is something that we have. So we can see that there are people who've given wrong ages as well, or maybe impossible ages as well. There are as high of ages as 113 that are there on Facebook. So that is there, and the average friend count, which I believe for the person that is of 113 age on Facebook, is about 334. There's 112 and so on and so forth. If you want to see a lot of these to us, so if you type in 113 over there, we'll see 113 records. We click on that, and it starts from 113. It goes all the way down to I think it will go down to 1. It'll actually not go down to 1. I think the minimum Facebook age limit is 13. It will go down to 13. So it goes down to 13. And from 13 up, we have this. And if I simply remove this and click on this particular button, the play button, we get the data in ascending order as well. So it starts from 13 with the average friend count is about 164.75. And we go down, we get the average friend count statistics for every age. So this is how easy it makes this particular job to be, right? So hold on tight. I'll be contacting my course advisor now to guide you guys with the career opportunities that Pyspark has, the career opportunities that big data has in general, to guide you with any of the questions that you have career-wise. So I'll resolve some technical doubts before I actually do that. How do we integrate Spark with machine learning? So Spark also comes in with libraries called mlib. Like Spark has a library called mlib. Spark mlib deals with the cluster-based machine learning computation. So basically, creating machine learning models is a very daunting task when you're dealing with big data, right? So you're not going to be actually dealing with machine learning in a linear sort of format on one system. You're going to be dealing with creating machine learning models using the processing power of multiple systems. So for that case, Spark also provides the mlib libraries, which you can use for machine learning purposes. Okay, for data science roles, how much PySpark is required? Okay, so this is quite an interesting question. For data science at a base level, you don't need PySpark at all, right? If you're dealing with data analytics, right? Data analytics on its own is not that well of a paid sort of a profession, right? Data analytics is the entry level profession in data, right? It's the basic level profession. When you get into big data, you get quite a high bump in your career resume, so to speak, because you now know how to handle data at a very grand scale. which is the case with a lot of big companies today, right? So once you understand how big data analytics work, like data analytics, when you're dealing with big data, right? Then using that knowledge, you can integrate that pretty easily with your Python knowledge, say for instance, in data science, right? Or your R knowledge in data science. So instead of doing your data analytics, data science jobs on small data sets like you were doing earlier, now you're doing that same job on big data. And that is what is required in today's industry. Somebody who knows big data and is implementing data science with big data, using data visualization with big data, using cloud services with big data, and then implementing machine learning and artificial intelligence with big data, because your machine learning algorithms and your artificial intelligence algorithms will be extremely accurate if you're creating them with big data, because it takes a lot of data together to create it.
Just a quick info, guys. Intellipaat provides Pyspark online trading mentored by industry experts. The course link of it is given in the description below.
So, guys, we have come to the end of the session. Hope you all enjoyed it. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.